that we're given is good. We have to reason. Not everything that we are given is a good thing. So me, as a young black man, I will always practice and follow the teachings of Pombe Magufuli. I was the same as a lot of people yesterday, but because of his teaching, he made me remove my mind. Okay, so I was the same as a lot of people, and a lot of us was like him yesterday. So thanks a lot for your time. You know, I dedicate the 6 hours and 30 minutes, you know, to celebrate his teaching, his legacy. And he teaches we have to do with our heart from deep down and leave legacy for people who are in need. Thanks a lot for your time. Now, let's get started. So I'll try to go fast a little bit so we can catch up with time. So this is the first question here. They say integrate. So I got like 200 questions. So let me start with this one. They say integrate. So if they say integrate, all of first and foremost, I want to let this. Let's say to any letter. Let's say m equal to square root of x, and then I want to differentiate dm equal to, on the differentiate is going to give you 1 over 2 square root of x and then d dx. Okay, but square root of x equal to m means I want to replace this equal to m. So dm equal to 1 over 2 square root of x equal to m. So I'm going to say m and then say d dx. So the dx here I'm going to replace with the what there. So I can say 2m coming is going to be 2m dm. Okay, so dx equal to 2m dm. So I'm going to replace this dx with that, and we know this equal to m. So this one is going to become, okay, it's going to become integral e, and then square root of x equal to square root of x equal to m, and then dx equal to 2m dm. So I'm going to write my 2 here, and I put my m here, so I get like by part, and this is going to be d dm. That's a good way of writing. So I'm going to write my 2 outside, and then this m I'm going to put here, and then e, so it can be in a format of by parts. So from by part integral, we know the formula say, the formula by parts is saying, okay, integral of u, integral of u dv equal to uv minus integral v du. So our u is this one here, and dv is this here. Okay, so we're going to let u equal to m, and then differentiate du equal to dm. Okay, and dv equal to em dm. And then what we're going to do, we're going to integrate this. So when you integrate here, you get v equal to, when you integrate, they're going to give the same thing, em. So we have everything, so we can substitute. So we say integral u dv, which is this one here. So I'm going to leave my 2. So we'll say, okay, 2 or integral of this one is the same as integral of e d means m dm equal, we still have our 2, right? So I can say, okay, write my 2 outside, u equal to m and v equal to em minus integral of v. What is our v? Our v equal to em, and then du, our du equal to dm. Okay, but when you integrate dm, you get, when you integrate em exponential, you're gonna get what? You're gonna get what? When you integrate em, you're gonna get what? Em. So when you get em, you're gonna get em. So I can just say em here. So all this stuff's gonna give us em. Okay, sorry. All this stuff's gonna give us what? It's gonna give us em here. Em. Okay, so now we know the value of m, so we can substitute back the value of m. What is the value of m? M equal to, what is the value? M equal to square root of x. So this is going to become 2 m equal to square root of x. So I can say, okay, first and foremost, I can factor out e power m because this is common. So I can take out e power m and then replace it with m minus 1. Okay, let's factor out e power m. So it's going to become 2 e power m here, 2 e power m, become 2 e power m, and that's going to be m minus 1. So now it's going to be e, what is m? M is square root of x. And they're going to say m, what is m? Square root of x minus 1. And they will plus our c. So when you integrate this is the same as that. When you integrate this, you get that. But this one here is integral me. Okay, what is that me? Our m, square root of x. Excuse me. This going to say, we can just put that right here. When you integrate everything, which is given, integral of e square root of x dx, we get 2e square root of x minus 1 plus constant. So this question here is done. So we're going to have to erase, and then we go to the next question. Okay. So I'm just doing this for MAGUFULI. So let's just erase this. I'm just doing this for MAGUFULI. Okay, now let's do that question right there. So that question, this is the integral type of, if somebody give you integral of a function dx. What is a? A can be any number, 2, 5, 6, 8, 7, 5, 6. So now you see our number a is a number, and this is the function. So how you integrate this? This you integrate, say 1 over derivative function. You write under, and then what you do, you just write exactly the way how you have. And here you say ln of only this a, and then you plus constant. Why plus constants? Because we don't have a limit. Okay, these are integration rule, so you need to memorize this rule. So I'm going to say 1 over, I have to derivate my function. My function means whatever is in here. But when you derivate this is going to give you 2e to x. Because when you derivate e to x, when you derivate this, look, what you do, you derivate whatever is here, it's going to give you 2, and then write exactly. That's what I say, when you derivate this, it's going to give you 2e, which is 2e, whatever you have. And then what you do, we say you write a f of x, a exactly what you have. What is a? Our 2, and then write exactly what you have here, 2x, okay? And this is ln of a. A is the number which you have here, which is 2, and then we plus our constant. So this is going to be our answer for this. This is our answer. Okay, now we go to question number. This one is done. Let's go for that one. Let me check if it's recorded, because I made a big mistake today. I was just recording another series of 100 different sessions, and then the camera was not recording, so I just want to make sure quick. So recording. Yeah, it does record. Thank you. Okay, cool. It do record. That was very surprising. Okay. Record. Let me make sure again. So, does it record? Does it record? Yes, it does record. Okay. Cool. Now, okay, so now let's go for that one. So for that one is the question number 2. If somebody give you law, okay, let's say 1 over f of x dx. So this is 1 over function. 1 over, this is a function. If there's no other stuff, just 1 over function. So this may say ln of absolute of a function plus constant. Okay, so now we're going to do the same thing, but do not forget, whenever you have an integration of a function, you must say 1 over derivative function. So you must write f prime. So we're going to do the same thing here. So you see this formula here, so say, okay, 1 over derivate this function. When you derivate this function, when you derivate 8x, you're going to get 8. Derivative is going to be 0. Derivative 1, you get 0 family. So say ln of, write exactly, 8x minus 1, and then we plus constant. So that one is done. Now let's count for this one. Okay, now this one is easy. So it's tricky, but it's easy. For me, it's easy. Okay, so now they give integral. Now they say cosec whatever. So whenever you have an integral cosec of a function, and then cot of a function dx. So whenever you do cot of a function, the answer is going to be cosec, negative cosec of a function. But do not forget 1 over derivative function when you integrate. Must be 1 over derivative function, and then for this case, when you derivate cosec cot, you get
negative cos, and then you plus constant. Negative cosec, you get function. So we're going to do the same thing here. So you see here, cosec, cot. So how you know this? You're going to have to memorize all the rules, okay? So now for me, it's going to be 1 over derivative of function of function is 3x squared, 3x squared. When you derivative, it's going to be 6x. So it's going to be 6x, and then negative cosec, and then write exactly the function they give to you. Plus constant. Why plus constant? Because there's no limit. Now let's go to the next question for him. Okay, next question. So if you're not careful, you end up making mistakes, which is going to make your solution look lame. Okay, now let's go to the next question. So next question, that one. Okay, so we have the integral sin x dx. Okay, so sin x dx cubed. This is a trigonometric integral with a power. So I'm going to say this. Let me say integral sine x and then times sine x dx. Because sine x squared times sine cube. So then I can replace this one. This is going to be 1 minus cos from trig identity, and this is going to be sine x dx. So I want to let's say u equal to cos x. So when you derivate this, the u is going to give you negative sine x dx. But take negative out, so negative is going to come this side. So sine x dx equal to negative du, means this equal to negative du, and this equal to u, because cos x equal to u. So I want to say this same is integral 1 minus u squared, and then this half here, sin x dx, negative du, so take negative du. So now we're going to have, I can just multiply that this out. So negative integral of du, because it will be integral of the first one, du, but this minus with the second one. Okay? There's a minus here, right? Okay. Minus positive integral of u squared du. Okay, now this is going to give us, when you integrate du, you get u. So negative of u plus, this is going to be power rule, you add 1, and this is going to be 3, and then you add the same thing, it's going to be 3. So u 3 over 3. So this is, but we know the value of u. What is the value of u? Value of u equals cos x. It's going to be negative cos x, and then plus cos cube x, and then over what 3, and then we plus constant. We plus constant because we don't have no limit. So this is our answer. See, if we did capture, oh yes, it did capture. Now we go for the next question. The next question is easy. I haven't even checked and just say it's easy because it's always, for me, it's easy. Okay. I'm going to have to do 200 integrals in an hour. Okay. Now, which other question now? This one here. So we got integral of x, and then this x squared minus 1, and this dx. So let, for example, m can be let in any letter. 2x minus 1. dm equal to 2x dx, but here I have x dx, which is x dx. Divided by 2, this is this cancel. So I'm going to say integral. So instead of x dx, it's going to be dm over 2. So 1 over 2 is going to go to the back. It's going to be dm over, this is u. m. So now we have a 1 over 2. When you integrate, 1 over m is long of this m. We did this one, previous question, plus another question that we did. So they equal to half ln absolute. What is the m? M we know equal to x squared minus 1. X squared minus 1 plus constant. We're done. So this one is done. Let's go there. Okay, cool. Now, let's answer that one on top. So that one, they give us integral 4 of sine power 4 x, and then cos cube x dx. So what I'm going to do, I'm going to change this. So say integral, or I can say integral, this is say sine of power 4 x, and this is going to be, can separate square and 1 because of the trigonometric identity. I know cos square equals to something. So say, okay, this is the same as cos square x, and then times cos x dx. So this and 1 minus sine square. So I'm going to say sine power 4 x, this will be 1 minus sine square x from trig identity cos x dx. So I'm going to let now see sine cos. So say let's say u. I like u. So sine equal to sine x, and then differentiate is going to be du. Differentiate sine is going to give you cos x dx. So this is cos x dx equal to du, and then here's u. So it'll be integral u power 4, and this could be 1 minus u square, because this is square, u square, and then cos x dx equal to du. So this is integral, multiply that out, so it's going to be u power 4 du. So it's going to be u power 4, because you multiply u power 4 times du. Okay, now this is going to be u power 6, because power 4 u minus integral u power 6 du also. Now, when you integrate this is easy, because this is going to be you add 1 from the power of integral, you add 1, it's going to be 5 over 5, so it's going to be u power 5 over 5, and this is going to be minus u, add 1, 7 over 7. Okay, so now, but we know the value of u equals sine x, okay, fahmy? So sine x, power 5 over 5, and then minus sine x power 7 over 7 plus constant. Easy, what plus constant, because we don't have no limits. Now let's go question number the next one. Like I said, when you finish this question, it means we've done already 15 questions. I love this. So what this series means is you're going to be more confident, and then you don't want to have that feelings like losing consciousness or get confused. You know, the only thing you're going to get is to get that motivation and keep it driving. Let's get that. Let's get it done quick. Okay, now let's go. This one is done. Let's go. So this one is done. Now we go for that one. Cos x. Yeah. 5 minus sin x. Okay, so this is easy. I will let this equal to u or k, whatever. Okay, let u equal to 5 minus sin x, sin x. So when you differentiate the u, it's going to be 5 minus, when you differentiate sin, you get cos. I'm wrong. When you differentiate 5, you get 0. Okay, let's take that little thing. Okay. Now differentiate u, get the u, and then differentiate 5, you get 0, and then differentiate sin, you get cos, but we have minus here, cos. Our minus is still there, cos x dx. Okay, so what we're going to do, we're going to substitute over there and get it done with the question. So it's going to be integral cos x dx equal to, so take this negative to this side. So cos x dx equal to negative du, so negative du, and then over 1 over, this is u. So negative, when you integrate 1 over u equal to ln of u. Okay, negative ln, but what is that u? 5 minus sin x, 5 minus sin x. Plus constant. Okay, now we're done. Now we go to this question here. Now we start a little tricky, okay? Okay, now that one here, okay, let me show you something. Trigging, integration of a trig. Integration of the trig, okay? Integration of the trig, I'm going to give you, let's say, integral of, 1 over, let's see, a squared plus f of x squared dx. This same is say 1 over divided by this a. A means can be any number. And then derivate this function here. See, this is going to be f prime, but this is only for tan. If you have this format, you do like this. But for sine, for hyperbolic function is different, because for those, you don't need this a here. You don't need this a, okay? For hyperbolic, sine and cos, inverse of a trigonometric, you don't need this. But for tan inverse, you need this. So you write your a, f prime, and then f prime, and then we say arctan. Arctan, and then write your function exactly. And then over this a means the number which is there plus constant. When you say arctan means tan inverse, the same thing. When you say arc, for example, sine, this is the same as say sine inverse. Or for whatever function, let's say this function, fx, it's going to be f of x also. So sin inverse, arctan, arctan meaning, when you say arctan, meaning tan inverse. It does not make any difference. So for that case, now we say, this, if you look carefully, is in this format. It means there's a plus, a, so we have to write in this format. Here, you're going to say, okay, integral, dx, 9 means 3, square plus, and 5 means like a 5x squared. So it's already in that form. So we're going to say 1 over a. A is just this number. See, a squared means it's going to be 3. And then differentiate. You have to differentiate your function. Function is 5x. So it's going to be 5. When you differentiate 5, it's going to get 5. Only function, not square. Okay? Now we're going to say arctan Our function is 5x over a equal to 3, and then we plus constant. So now you come in a situation where you have a root now. If they put root, what's going to happen? Like, for example, they put root here. That's another story. I'll explain to you now how you do it. For example, this question. Okay, so if there's a root here, let's say integral of, let's say a squared plus f of x squared, and then we have a root here. So this is another case. What you do is say 1 over, so now do not put a, okay, because this is not tan. See, this is not, when there's a root, that's another case. Okay, so this will be 1 over derivative function. Derivative function, and they say this is arcsinch. This is arcsinch. If it has a root, it's arcsinch. And the ratio function over your a, and then you plus your constant, because there's no limit. So, but not only that. So this is for hyperbolic function. This is for hyperbolic. So when you integrate, they might tell you, okay, integrate using this method, or use by parts, or use whatever. So it depends on the question. Not all the question you can do maybe by parts. Not all the question you can do maybe by integration, by trigonometric integration. Okay. So they're gonna tell you, they're gonna detect you. Sometimes if they don't detect you, you can do in your own favorite methodology or favorite part that you feel like is very essential for you to go through. So for me, for example, they say do hyperbolic means I'm going to use this method. But if they say use the trigonometric, the same question they say use trigonometric. So for trigonometric, the same question is going to become, it's going to be like this. 1 over prime function, same question with the root. And then you're going to say, put your absolute, and then put your absolute, and then put your function. You see this one here? Put it here. And then you add exactly what you have here. A square plus f of x square, and then absolute plus constant, because there's no limit. So the same question you can do either, depending on the question. For example, they give us this question, which is very similar to this because we have a root here. So I want to say for that case, let me rewrite that. If I have to rewrite, that's going to be dx. 49 means it's 7 square plus 8x. 8x or square. Which is, okay, now this is the same as says, okay, let me start with the hyperbolic. It's going to be 1 over function. What is the function? 8x. F derivative means you have to derivate. When you derivate 8x, it's going to give you 80. And then we say arcsinch. So you can say arcsinch, or if you don't want to say arcsinch, you can say sinch inverse. It's the same thing. I could say sinch inverse, or you can say arcsine. Either you write arcsine with no inverse or inverse. Okay, now, write your function 8x over a. What is a? A equal to this number here, which is 7 plus constant. Okay, but if I don't write like this, I can say this is the same as, so this is for trigonometry. No, this is for hyperbolic. Hyperbolic means when you say sinch, cosh, tanch, sec, those are hyperbolic. So now they say in trigonometry, the same thing, so this is hyperbolic. Hyperbolic. Now, the same thing now, let's do by trigonometry. So it's going to be 1 over derivative function, it's going to give us what? 8. Put your absolute, and then write exactly 80x. And the plus, write your function exactly here, which is this one, 7 as well, or I'd rather write this. It doesn't make a difference. It's okay. This is going to be square root of 49 plus 64x. And then another absolute clause, and then plus c. So we're done. So that question is done. Now we come for question number 9. Question number 9. So you see, you can change a lot when there's a root, when there's no root. So you need to pay extra attention to that. Because if you're not, then you'll be trouble in exam because it gets you confused. Okay, let me go quick a little because I feel like I've been slow because I want you guys to understand what's happening. Okay, now we go to question this one. So that one is kind of similar with that, but you know it's different. The power is different. Let's see how we can do that. This one right here. Okay, so integral sin sin the cos sin 3x. Okay, that one. Let's go. So I'm going to do the same game. I'm going to break this. So I'll say integral. Or, for example, you see the face when I break this. How if I break this? I can do that too. Let me challenge myself. Let me break this one now. Because the face one, what I did, I broke this. So let me try to break this one now. Okay? So I'm going to say if I break this, it's going to be... So let me write cos Q x, and then let me break this. It's going to be sine square x, and this is going to be sine x, because sine cube d dx. And then this is going to be, this is an integral. Okay, we have a cos cube x. Sine x is, for my identity, is 1 minus cos square x. But we have a sine x dx. Sine x dx. So what I'm going to do, I'm going to let this. Let u equal to cos of x. And when you differentiate du equal to, you differentiate cos of x, you get negative sine of x. So, dx. So this is sine of x dx. So I don't need this negative. So the negative is going to come this side. So what I'm going to do, I have to replace everything. So this question is going to become cos equal to u. So it's going to be u, but this is cube. And then this is going to be 1 minus u but a square. And then this sine of dx equal to negative du. So negative go out, and this will be du. Now multiply that out, so we have a negative still. Okay, now we say u times 1 is u cubed with du. Now there's a negative here, negative positive. U power 5 du. Now this will be u plus 1, and it's going to be 4 over 4. So it's going to be u power 4 over 4 plus, but this is minus. So this will be u power 6 over 6 plus constant. Now we know what u. What is a u? U equal to cos of x. So cos power 4. So okay, say 4x over 4, and then plus. Okay, this is going to be cos power 6 over 4, but this is x plus c. No, there's no limit. That's why r plus c. Okay, question number 10. So 10 is tricky a little bit. So my whiteboard is kind of getting dirty, so I have to use handy. Look, I don't have a good equipment, so I'm trying to use like handy. This is handy. I don't know how you call in your country, but we use this to clean up something which is let's say whiteboard or floor. I use this most of the time, so because I don't have good equipment, so I use this. So because the whiteboard is getting dirty a little bit, so if I can use this, means can help me to clean this. Okay, and we can just get this done. Okay, so you see now we kind of clean up a little. So I use water here. I use water to clean. Okay. Clean up. Wow, see, it's looking better now. See, it's looking way better. Okay. So I use this quick. Okay, clean up. Okay, follow the question. I'm done already. Like this one, I'm done already. Let me just get them going. Okay, cool. Okay, this one already. So far we have done 11 questions. Man, I gotta move quick now. But the problem is, I can go quicker, but I'm worried about you now, because sometimes I don't just want to do for the sake of me. This is for you. Okay, this is for you. Now, so we have a question right here. We wipe again. So this one I use for drawing my whiteboard, and this is for clean up the weight one. Okay, now it's dried a little. Okay, now integral ln of x square dx. So when you square, it means something times the same thing. So this is an integral ln of x times ln of x. So this is by parts. So by parts we say integral u dv equal to uv minus integral v du. So what is our u? This one by u. Let u equal to ln of x, and dv the rest, which is going to be this. This is u, and this is going to be dv. So dv equal to ln of x dx. So dv equal to ln of x dx. So I'm going to differentiate this, but this I'll integrate. So this must be integrated, but this must be differentiated. When you differentiate u, you get du. My pen, come on now, don't do that again. When you differentiate ln of x, you're going to get differentiate this, you're going to get 1 and then over x dx. Let me check my camera, people, just a second. Does it record? Yes, it does record. Okay, cool. 1 over x dx. Now you come here. When you differentiate dv, you get v. When you integrate, you get v. Now when you integrate, this is another story. This is by part itself. So we have to take it and treat it separately. So I'm going to say, okay, so now let me take this, because whenever you have an integral of ln is by parts. So let's treat it separately. So say integral of ln of x dx. So we're going to stop here for so long, and then we come back later. So this is going to be u, and this is going to be dv. I'll use the same form. So u equal to ln of x, and dv equal to dx. So I have to differentiate. This is going to give you du, and the differentiate is going to give you 1 over x dx. When you integrate this, it's going to give you v. When you integrate this, it's going to give you when you differentiate this, is going to be 1 over x. When you integrate this, it's going to give you x. So now I'm going to use the same formula here, u v. Okay, so say so integral of ln of x dx equal to uv. uv means this and that. So x ln of x minus integral of v x multiply du. What is the du? du equal to 1 over x dx. So this is equal to x ln of x minus this and this cancel, so you get 1 integral of 1 dx. Integral of dx equal to x. Okay. Meaning if I integrate that, it's going to give me ln of x, so it's going to give me ln minus x. So now I don't need this, but in the solution exam, make sure you write it, okay? So for now, I don't need this, so but make sure you write the part of the solution if you do something else. Okay, cool. Now we go. So for that case now, we say, okay, now we go. So I got all my stuff here. So it's okay. Integral of ln of x times ln of x, which is ln of x squared dx equal to uv. What is that u? Or u equal to ln of x times this. So I can say x ln of x minus x times uv. But I'd rather start with this. I don't like to write ln and then something next to it. Ln must be like, if somebody say ln x times x, is not good to write like this. Better write x ln of x. That's the best way. Okay, cool. Now we go. So for that case now, we're going to say minus, and then say integral b. What is that? b equal to x ln of x minus x. Okay? And then multiply by du. What is that du? Our du equal to 1 over x. So it's like 1 over x. So you can just put x underneath. Or you can say 1 over x if you want. You can say 1 over x times dx. So look, you see here you can factor out x, because x ln x, x. So I can take x out, and then because look, this x and this is x. So I can take x out, and then I can write like this. It's going to be 1. How about that? And then I know this 1 and this going to be 1. So for that case, this is going to be x ln x minus x ln x, and like I say, x ln x minus, okay, so this is going to be ln of ln x dx minus integral of 1 dx. So it's like dx, 1 dx dx. Now this is going to be x ln of x minus x, and then ln of x minus, I can just say this equal to, when you integrate ln of x, we know, when you integrate ln x equal to this, remember we did this, equal to that. It's going to be ln x ln of x minus x, now when you integrate dx equal to x plus constant, because there's no limit. So we can multiply that out, because this is the end of the question, but sometimes you don't know your final answer in exam, so simplify as far as you can. So this is going to be, let's multiply that out. It's going to be x ln of x squared, multiply this and minus x ln x, and then this one also is going to be minus x ln of x plus x minus x. Oh no, wait, this is minus x, but this minus and this must be plus. So this must be plus. When you put this is minus, but this is going to be plus. So this is going to be plus. So this is going to be what? It's going to be plus. So negative ln of x plus x. Oh no, these give us this. Okay, I'll get confused. Okay, negative ln of x, negative ln x. This plus x. Okay, this is going to be plus x. Yes, plus x. And then this we say is plus, so it's going to be another plus x plus constant. Okay, you can just take that just in case you may have made a mistake with the signs, but I believe you understand how I do. So this is 2x, so say x ln of x squared minus x ln x, x ln x, x ln x. Okay, plus and minus, x ln x, x ln x. So this plus and this minus, they're going to cancel. So cancel, so these two they're going to cancel, this and this one cancel. So then we're going to be left with plus x and plus x, 2x. 2x plus c. Plus c. Okay, now let's go to the next question. Next question, this one right here. Okay, now okay, this one is very easy. This one is way easy. Now let's go. So we have integral 3 2x squared dx. So this is like same as if somebody give you integral of a function of x dx equal to, okay, somebody give you integral, let's say a g of x or f of x dx. This I may say phase, when you have integration, make sure you integrate your function here, which is going to give us g prime, and then for this case, write exactly what you have here over ln of your a plus your constant, because we don't have a limit. So now, 1 over derivative function, derivate this, is going to give 4x. 1 over 4x, 1 over, and then write exactly, and then ln of a means only that number, plus constant. Whenever you have a ln, you must write your absolute. Okay, done. Same with the question number 12. It's not question number 12 because now we finished 15, like I said. There was another one we did already. So, integrate of 2/6x dx equal to, okay, derivate 6x, you're gonna get 6, and then you say ln, no, write exactly 2/6x over ln of 2 absolute, and then plus your constant. See, now we go for the last one. For the last one, it's not last one like for the face question, for the face loop for question, for the face 15 question. I'll show you for now. Okay, it's weight. Okay, it's better right now. So now we have sine, integral sine, power 4m, and then so this is more the integration, but there's a power. So what you have to pay attention when I'm solving, you have to learn from me. See, there's a power, so you have to look the format of the integral. Okay, so now this is power 4m, and this is cos 3m dm. So what I'm going to do, I'll break this one now. So this is say equal integral power 4m, and this is going to be cos square m, and this is going to be cos, just cos m dm. I'm going to let these, no, these we know. Okay, so integral of sine 4m, this is identity integral, so cos 1 minus sine square. If it's cos square 1 minus sine square, and then cos m dm, let equal to any letter. So let's say u equal to sine m. So du equal to, when you differentiate sine, you get cos m dm. So cos m dm equal to u. So now this is going to become integral. Okay, u equal to sine m, so this is going to be u power 4, and then 1 minus u square, and then cos m dm equal to du. So now this is going to become, multiply that, it's going to be u power 4, but then when you integrate also 4 plus 1 equal to 5. Let me just do slow, just in case for some people don't know. Okay, u power 4, and then u minus u power 6 du integral. So when you integrate the first one, it's going to be u5, it's going to be u5 over 5 minus u7 over 7 plus constant. Okay, now we know the value of u. What is the value of sine? Power 5 m over 5 minus sine 7 over 7 plus c. Done. So this loop is done. Okay, another question here. This will be number 16 now. Integral of cos 3x dx. So this number 16. So this let me say 1 over derivative function. When you derivate 3x, you get 3. Now, so cos, when you integrate, you get sine. And the right exactly. Okay, we're done 16 question. Now we go for another loop. Okay, now let me clear. I'll use my hand again, you know, because we go to another round now. And then I'll write here 20 question. I think I can just take one by one, so maybe I can write all of them on the board. And then we go like how I did it. Okay, cool. Sorry guys, I have to clean the whiteboard because if I'm not doing it, then you might not see clear. So I have to make sure it's clean. Like I said, I use water, and then I use this handy. See, I got some buckets here. It's crazy if you see me what I do. Let me show you. See this buckets here? So I got some water here. This is dirty water. So not like dirty like the face dirty water, and I have another bucket with another clean water. Okay, cool. Let's go. This is what I do here. It's 2 a.m. now, almost 2 a.m. in the morning. I'm just this one for you. I'm doing this one for you. Because I don't have a good tools, so I just do it in traditional way. Like in Africa, how we do always. Okay, cool. So we're done here. Now let me go into another question. I'm gonna write list of questions again and start to solve them again. I think I can just solve them straight, and I don't have to write them and start to solve one by one. Let me do them straight. Oh, should I write this out? Let me think. Now let me just solve it straight. Okay, now let's go. We have the question right here now. The question say, let me see. Oh, this one done already. Okay. Now integral dx, and they say here. Trying to check what question. Yeah. 7 minus 36. 36? Oh, it's not. Okay, still wait. Oh, it's better wait. That's why I can't do wipe. Let me wipe again. Okay, so integral dx 7 minus 36x. Okay, now how are we going to do this? This is, and then we have a root here, square root. So it kind of looked like tan, but no, tan, we know it must be plus, and there's no root. Okay, now let's go for cosh, hyperbolic. No, this is not hyperbolic, because for hyperbolic, we know it must be plus here. And yes, there's a root. So since there's a minus, then this is sinh. See how crazy it is. So now we say for sinh, let's write the right format. So this let me say integral of d dx, and then 7 means 7 square root to square, and then we minus this gonna be 6x square, because 36 gonna be 36. Okay, now we go. You see now, because look, if you say 7 square root and then square, this let me say 7, and the reason I write like this so that it's gonna be easy for me to substitute in the formula. So for sinh formula, this is how you say 1 over derivative function, and they say arc sinh sine. This is not sinh, it's sine for this case because minus, and then write your function here, and then you over a, then you plus constant. So for this case, 1 over derivative function, derivative 6 is going to give you 6x, will give you 6, and then arc sinh or sine, and then function 6x over a. Our a is a square root of 7, and then we plus constant. We're done. Now we go for the next one. For the next one, it's integral dx. Oh, this is question number 17, 18. Okay, integral of 5 plus 8x squared. So this is tan because there's no root and it's plus. So this is, let me say, integral of d dx, and then this can be 5 square root and then square plus, and this also, you see, is not in the right form. So we'll say square root of 80 and then x and then square. Look, if you square this, you're going to get 80, because square of the 8 is 8, and square root of x, square root of x, square of x equal to x squared. So this is same with that. So this is tan inverse. So for tan, we know it must be 1 over a. For tan, only for tan, 1 over a. So a equals square root of 5. And then also you must derivate this. So for tan, you do double thing, a and a derivate this. But for the race, it's just f prime, like only f prime, f prime, f prime. So this is going to be derivate 8x, because it's going to give you square root of 8, and then we're going to say arc tan, or you can say tan inverse or arc tan, is the same thing. Okay, and then write your function, and then over our square root of 5, and then we plus constant. Done. Now let's go to question number 19. So question number 19, I need to go more faster now. They give you 19. Yeah, this is the last one for this type. Okay, integral. Okay, integral of 9 plus 64x squared, and then you got root and let's say dx. So this is same with that. Or let's say this is 5. Let's say 5. So I'll take negative 5 face out, and then integral dx, and then this is 3 squared plus. Okay, 64x squared means 8x squared, and then we have our root still. Okay, so this is sin because there's a plus here. So for that case, I'll say this is equal to negative 5, it's just negative 5, and then we say, okay, right up bracket. Now, for sin, we don't do this a, no. Only for term. Even for sine, we don't do this a, no, only for term. So say 1 over derivative of 8x. We give you 8, and then we say arc sin sh. So you can say sin inverse. Oh, my pen, come on now. Sin inverse of our function, which is 8x over what? A equal to 3 means this number here, 3, bracket plus constant. If you want, you can just say negative 5. This time say negative 5 over 8, and then write exactly what you have here. Sin it's not sine. Sin sorry, this is sin or arc sin. If you don't want to write like this, you can say arc sin. Either this or that. And they can write exactly what you have here, 8x over 3 plus a constant. Okay, now this is done already. Put it outside. Now we go for this one here. You know, something that I like to do. I don't just do like baby integral stuff. I just show you the weight that I put in, so you can fashion this word. Okay. Now I go to my water. Come to my water here. The problem is I try to go to the stationery, and then I had this other white body razor, but it wasn't clean at all. I appreciate your patience. I appreciate your pain. Just now, we come back and do the ratio equation, okay? Just now. Alright, go to the clean water. Clean water. Okay, cool. We're ready to go. So that was question number. How many questions did we do? 18, 19. Let's see. I think 19. Yeah, I think so. 19. Okay, let's just assume 19. No problem. Let me see. I can remember. Okay. Yeah, it's 19. Okay, cool. 19. Now we go here. This is another story now. Okay, see? Okay, cool. Now they give you here. Let me dry it quick. Just say, okay, cool. You know what? Let me write this question so I don't forget the numbers here quick. Okay. Question 20. Question 20 is integral. Integral sine 4x cos 5x dx. 21. So do to 50. 21 equal to integral cos 3x cos 7x dx. 22 integral x 49 plus x power 4 d4. 23 integral 1 9 minus 16 x squared. 24. Okay, 24 equal to integral dx 7 minus 30, 6, x squared, 25, 25, 25, 25. Cool, no problem. And then we'll come back here again. Integral dx 5 plus 16 x squared 26. Okay, cool. 26. I'll come back now. And then I'll do it. Yeah. So it's equal to integral dx 9 plus 4x squared dx. Okay, cool. And then I'll come back for the more soon. Okay, now we go. I think that's the best way, so I know it's there. Now we go. So the first one here, that's a factor theorem. So factor theorem of trigonometry. So now let me show you first how the factor theorem come about, so that you can understand. Now, so your intention, you have to break that one. How I want to break? You have to know the factor theorem. And factor theorem comes from compound formula. Let me show you quick how it comes about. If somebody give you sine of A cos B, sine of A plus, can I say plus? Sine of A plus B from the compound formula. This is equal to sine of A cos B. I believe everybody knows this. And then if it's plus, it's going to be plus. So now you switch. You say this cos A sine B. So you do the same thing for minus. Sine A minus B equal to sine A cos B minus must be minus and then cos A means you switch this. This is going to be cos, this is going to be sine now. Sine of B. So what you do now, you plus and then you minus. Let's plus first. If you plus, means it's going to be this plus this and this plus this. But when you plus means, you remember this plus and minus means this is going to disappear because cos A cos B, cos A cos B, they're going to disappear because plus and minus. So this is going to be two of them, 2 sine A cos B. So say 2 sine A cos B equal 2 sine A plus B plus, right? Plus, yes. Sine A minus B. So sine A minus B. You see what I'm saying? And then divide by 2, divide by 2. So divided by 2, divided by 2, this is going to be 1 over 2. Okay, so this is the first group. So I don't need this one. Sine A cos B. Sine A cos B. Can you see? So for that case now, this is going to be, what is the A? A equal to 4x. So sine of 4x and then cos of 5x equal to 1 over 2 sine of A plus B means sine A plus B, 4x plus 5x equal to 9x plus A minus B means 4x minus 5x, which is going to be sine negative x. But remember, this is an odd function. If you have a sine negative theta equal to negative sine theta, this is an odd function called odd function. And the sine for tan also is going to be the same thing. Tan, let's say negative x equal to negative tan x. So these two are odd function. Odd function. But for cos is different thing. Let's say cos of negative theta equal to cos theta. It becomes positive because the even function. This is even function, family. So for that case now, this negative is going to come back because this odd function. So this negative is going to come back. This is going to be negative sine x. So now I'm going to take this and replace that. So instead of writing sine x cos 5x is going to be a half sine 9x and then a half negative sine x. So that one I'm going to rewrite it. I'll say integral. So I'm not going to say this a half can go back. I'm going to say a half. And then instead of saying sine for x cos 5x, I'll replace this. See what I'm saying? This a half can go back behind integral. Or if you don't understand what I'm saying, okay, let's start with a half. Let's write exactly. I'm not going to write this anymore, which is that. I'll write this, sine of 9x minus sine of x dx. You see what I'm saying? But this a half is for both. So I can separate this integral. So this is equal to a half, but for both, right? A half integral sine of 9x dx minus a half again integral sine x dx. And then what's going to happen is going to be 1 over 2. When you integrate any trigonometric integral, you must differentiate your function, which is in the number right underneath. When you integrate sine, you get negative cos. Negative part is our angle is negative. Our angle is 9x, okay, minus 1 over 2. Differentiate this just you get 1, and then it's going to be negative cos. Plus constant. So this is going to be 1 over 18 negative, but negative plus, or cos, excuse me, cos of 9x. Negative plus, or a half, and then you say cos of x plus our constant. Or you can start with this and then write negative. It's the best way of writing. You start always with positive. It's not must, but I prefer that. We're done. Now we go to the question number what? Which one? Oh, number 2. So number 2 is going to be the same thing because it's cos. Oh, this is cos. Okay, cos. Okay, so for cos, we have to know also the factor theorem, how we get cos, or sin. Okay, so now for cos, and now to get cos, I know it comes from the compound formula of the cos compound formula. Oh, still wait. Cos compound formula. Let's go to cos compound formula. Okay, cos compound formula is like somebody give you cos A plus B. We know it's cos A, cos B. And if this is plus, it's going to be minus here. Sine of the first angle and the sine of the second angle. Oh, it's better wait. That's why I kind of do this. Second of the angle, the second angle. And then here you go cos of A. Can you see that? Yeah, I believe you can see cos of A minus B. This is let me say cos of A, cos of B. If it's minus here, it's going to be plus. Sine of A, sine of B. So you come here, you want to get cos. How are you going to get this cos? Meaning this must go. So how plus and minus is going to go? Plus and minus is going to go if you have a plus here. Because it's going to be negative, same thing, plus, same thing. So these, they're going to disappear. Now we go. So this is going to be 2 of them. So it's going to be 2 cos A, cos B equal 2 of these. No, it's not 2. This is this plus this. So it's going to be cos of A plus B. So you just have to memorize the compound formula plus cos of A minus B. So what we're going to do now, divide by 2, divide by 2. So it's going to be 1 over 2, and this is going to disappear. So see, cos. Oh, so for that case, it's going to be cos. What is cos? Cos over 3x, cos of what of 7x. It's going to be 1 over 2 cos 7 plus 3 equal 10x plus cos A minus B. 3x minus 7x equal to negative 4x. It's going to be negative 4x. But cos of negative 4x is like a positive 4x because this is an even function. So for that case, now I'm going to substitute this in there. So that portion is going to become equal to, I'll take a half outside in the integral, and then I'll say cos 10x dx plus integral of the second one, cos of 4x dx. So this is going to be a half, and then when you integrate this, it's going to give you function is going to give you 10 because 10x you get 10, and then you say when you integrate cos of a function, you get sine of a function. Or it's a function 10x plus, okay, this is going to be 1, differentiate this is going to give you 4, and this is going to give you sine of 4x plus a constant. But don't forget this negative for both. So multiply that out, it's going to be 20, so 1 over 20 sine 10x plus, this is going to be 8, 1 over 8 sine 4x plus our constant. So we're done with this question. Now we go to question number 22. I think there's a good way. Let me write all the question aside and then I just do it. Because looking at a paper sometimes, it consumes a lot of time. So I believe it's essential for me to write all the question aside so it's going to be easy for me to follow up. Okay, you understand? Yeah, that's going to be very easy for me to follow up. Okay, now we go to question number. The next question. So which one should I? Oh, still wait. Let me pop a little bit his weight. Okay, cool. So question about the next one is this one here. Okay, so integral, this is a very good question, trick. 49 plus x power 4 dx. Okay, this is 22. 23, this is 24 now. Let me say, this is 26, right? 27, let me try 27. Similar question like this. X, this is 4 plus, let's say u power 4. No, let me say y. Let me use y every time I use x. And this is y also. dy. Okay, let's do them both. So that's going to be 27 if I finish all this. Okay, now we go. So I'm going to say right now, I'm going to have to write this x power 4 is the same as say x square power square. So I'm going to let u equal to x squared. Equal to x squared. And then I'm going to say, when you differentiate this, it's going to give you du. When you differentiate, it's going to give you 2x dx. X dx. So I can just divide by 2 because I want to get x dx. So just divide by 2. So x dx is equal to du over 2. And all this stuff equal to u. Okay, so now this question is going to become integral. Let me use that pen just a little bit. Integral. X dx equal to du over 2. So it's going to be du over 2. So I can say over 2, like over 2. So this 1 over 2 is going to go back. It's going to be 1 over, this is u. So this is like a 1 over 2, but this is ln of absolute of u plus constant. We know u. What is a u? X squared. So u equal to x squared. So this is going to become 1 over 2 ln of, what is a u? U equal to x squared. Plus constant we know. Now let's go for that 127. So we got, okay, y power square. I was meant to say y, just a y. And then 2 square. No, I'm wrong. I apologize. I did something wrong here. I did something very wrong. I say, no, I did wrong. I did something wrong. My apologies, people. They are apologize, sincere apologize. This is the wrong question I did here. Only this. Let me correct my mistake. Okay, so this is going to be integral. Okay, this is going to be, we say u, right? So when you differentiate u, it's going to be du equal to 2x dx divided by 2 divided by 2. So this is going to become, look, it's going to be x dx du over 2. So 1 over 2 du. This is going to be 49 means 7 square plus u square. So this is tan, trigonometric tan substitution. So this is going to be 1 over 2, okay? And then it's going to be 1 over a. For tan we know we must write our a, 1 over a. And then differentiate this function is going to give us 1. And they say add tan of our function. Our function is u over 7 plus constant. So this is say 1 over 14 add tan. Our u, we know what is our u? U equal to x squared over 7 plus constant. Sorry, I'm gonna just switch off my phone because it kind of vibrates and make a lot of noise. Now let's go. So this is going to be, no, we're done already. Wait, make noise. Apologies, my phone is just vibrating, making noise. Yeah, it's off. It's off. Okay. So we're done. So now we're gonna go for the next question, which is we say this one here. So question 27. Okay. Now, so I'll do the same thing here. So the integral of y, and this is gonna be 2 square plus let's say this is y square dy. So let m equal to y square, dm equal to over 2 equal to y dy, y dy. Okay, so I'll come and substitute. So okay, this integral y dy dm over 2. So 1 over 2 is going to go to the back, and this is going to be dm 1 over 2 square plus m square. This is tan also, add tan. So say 1 over 2 is just r, and they say 1 over a. What is a? A2 again. And then when you differentiate your function, it will give you 1, and they say add tan, or you can say tan inverse. It's the same thing. Tan inverse of our function. Function is m over our number is 2 plus our constant plus our constant. So now we know the value of m. We can substitute what the value of m equal to y squared. So this is going to become 1 over 4, and they say tan inverse or add tan. Okay, our m. What is our m equal to y squared over 2 plus our constant. We're done. Now let's go to question number 23. Question number 23. So this is going to be 27. When I finish all this 27, because there's a 27 just right there. So you see, family, let's go. It's the weight. Okay, cool. Still, Okay, cool. Now the next question they say is this one here. So integral of dx, and they got 7. So I know this is going to be substitution tricky, so I can just say 7 square root 10 square, and then minus this is going to be 6x square. Okay, cool. So this one also we know this is a sign of tricky because there's a minus and there's a root. It's going to be 1 over our differentiate. This is going to give us 6. Then it's going to be sine inverse of our function over a plus c. Done. Now let's go to this question number, the next one, which is almost the same sign because I want to say, oh, this is the one I did. I didn't do that, which is going to be the same. Okay, now that's going to be integral dx 9 square minus 4x square root. So there's a minus, so this is sinus. 1 over derivative function, you get 4, and then arcsine. Okay, our function is 4x over a equal to 3 with plus constant c, and then we're done. Now we go to question number there. That's a tan substitution. Okay, tan substitution, this is going to be dx, and then this is going to be 5 square root and then square, because this is still going to be 5 plus 4x 1 over, for tan we're going to say 1 over a first, and then differentiate this only for tan, like I said, you get 4, and then add tan our function 4x over a plus constant c. Okay, now another one we go for this one here, same game, integral dx. Okay, 9 means 3 square plus 2x square, so this is going to give us 1 over a. It's tan, right? It must be a, and then derivative 2x, you get 2, and then add tan, you can say tan inverse, whatever you prefer. Our function is 2x over 3. Okay, done. So at 27 we're done. Remember there was a 7 question. Okay, now I'm going to write another one, and there we go. I'm going to write question up to 50 now. Let me check if it's a record. Yes, it does record. It does record. Integral sine pi theta cos theta d theta. 29 integral of sine 8x and then sine 5x dx. 30 excuse me, integral cos m cos 7m dm. 31 integral e for x dx. 32 integral of sine 2x dx. 33 okay, integral 149 plus 16 x squared. 34 integral of theta cos theta d theta. 35 integral of cos square for x dx. 36 integral of cos m square m dm. 37, so let's write here 37 equal to cos sine square 2x sine square 2x. Did I write? Yeah, I wrote it already. Okay. No, I know. Okay. integral of tan 5x dx. 38 integral of cot e x dx, ex squared dx. 39 integral of sec square 2x squared minus 1. 40 integral of 81 minus 25 x squared. 41 integral of sin x 1 plus cos x dx. 42 integral of x 27 minus 6x minus x squared dx. So this is 42, 43. Okay, let's do this and then we'll make a space and then we'll write some more. Okay, cool. Now, let me start with the question. If I finish this means I'm in 42. Okay, now let me start with the question number, anyone, it doesn't matter, whichever I can take, okay. Question, let me finish this so make space, okay. Let me start with this question for the one. Okay, so I'm gonna let u equal to 1 plus cos x. Differentiate this is gonna be du. When you differentiate 1 you get 0, and then differentiate cos you get sinh dx. So sinh dx equal to du. So I'm gonna say integral of du 1 over, this is u we said. U is equal to ln absolute of u, but this gonna be ln our u we know 1 plus cos x. So 1 plus cos x plus c. Okay, so we're done there. Now we go to question number, this one here, 39. So this one is done. Okay. So when you integrate sec square, you get tan. So I'm going to say 1 over, okay, let me just do here. When you integrate sec square of a function, dx, you get 1 over function, derivative, and then you write your tan of a function. This is a rule, mathematical rule, okay, from the different integration table. So I'm going to say 1 over derivative function. What is a function of function equal to? This. Let's differentiate. It's going to be 4x minus 0. It's going to be 4x minus 0, just 4x. 4x, and they say tan of a function. What is a function exactly? 2x squared minus 1 with plus constant because we don't have a limit. So this and this done. So let's make a space. I feel hot now. Take this off. Oh man, the problem is on the whiteboard is very, very wet, so every time. Okay, cool. Now, let's go. Okay, now, yeah. Let's go to that one. Question number 37. 37, say integral of tan of a function. Integral tan of function. When you derive tan, you get ln of sec of a function plus constant, but you must say 1 over function derivative. So tan of that, so derivate your function right under 1 over, when you derive 5x you get 5, and they say ln of sec of a function. Now function is 5x plus c. Now let's go for question number 38. So 38 we're going to say, okay, so you derivate cot, you get 1 over derivative of a function, and then ln of sine of a function. So for this case, it's going to become 1 over derivative function. When you derivate this, you're going to get 2x e x squared, and this is ln absolute sine of a function. A function is exactly the same. Now we go to this question here. Okay, this one is the tricky substitution. So how we do, we say we know how we're going to solve. This is going to be integral 1, 1 means 9 square minus, this is going to be 5x square, but we have a root dx. Let me check if it's recording, because sometimes it does stop. And then, yeah, it does record. Okay, so now we will say, this is minus. It's sinh, and for trigonometric, we know how we can do. Let me do them both. So for the first one, it's going to be sinh. So for sinh, we have to derivate 5x. You're going to get 5, means it's hyperbolic. So for hyperbolic function, if they say, okay, do using hyperbolic, it's going to be 1 over 5, and then I'm going to say here, ln, and then I'll write my bracket, and then I'll write whatever I have here, in this one here. And then we plus write exactly what you have, especially the one with the gap to you, which is this, I'll write. Okay, I'll say bracket 1, 81 minus 25 x squared, and then you close the bracket plus constant. Why plus constant? Because we don't have no limit. Now let's come for this one. Oh, that's a very tricky, I think. This is a very tricky question. So I need to space it. Okay, so okay. Okay, cool. Now, yeah, it's cool now. Okay, cool. So they gave us this question here, so which is integral, whatever. So what I'm going to do, look, let me show you something. Okay, let me write here on top, and then I'll raise that one. So this one we cannot do like how we've been doing stuff like this, where you can say, oh, this is a tricky substitution, whatever, because you know why? We have an x on top. So this kind of look like substitution, but the problem is we have, if I derivate this, like for example, you cannot get the one on top. So I have to introduce something. What I'm to have to introduce? Because look, if I derivate the denominator, it's going to give me 2x. Look, when you derivate, it's going to give you 2x, and this is going to be 6. Because negative 6. When you derivate, this is going to be 0. And then when you derivate, it's going to be negative 6. And this is going to be negative 2. So I'm going to have to introduce something on top, which is going to look like this. So that when the derivative is going to give the one on top. So now I'm going to say, let me rewrite this. So this I can rewrite as an integral. Okay, so I'm going to say negative 2x, because I want to introduce something which is derivative of the denominator, and then minus 6. But what happened? Also, I have to rewrite something that is not going to change the meaning, because our question they give us x. So we shouldn't introduce something or some sort of the variable where it's going to distract our given question. So what I'm going to say, look, negative 6 plus 6, right? Minus 6, let me plus 6. So it's like there's nothing here. It did not change the meaning, because if you plus 6, this is going to be like 2x negative. But so it's like only we have a negative 2x. But it's not negative 2x, it's x. So to make it x, I'm going to say divide by negative 2. Can you see? So it's like 0 divided by negative 2 is still x. So it did not change any meaning. And now we're going to say our integral. Now this is going to be 27, and then minus 6x, and this is going to be minus x squared dx. You see what I'm saying? Okay, you see? Now let's go. So now we're going to say, oh man, it's wet. Please advise me, like, what tools can I use for me to, because it's kind of challenge for me only when it's wet. So it means I have to wait for a few minutes to get dry, and I have to check if it's dry. Yeah, it's dry now. So this is what I have now. So what I'm going to do, I want to separate. I'll separate this with a face on, like this is going to be the first group. So it's going to be integral of the first group, which is 2x minus 6 over negative 2, 27 minus 6x minus x squared dx. And I'll say plus integral of 6 over negative 2, which is going to give us negative 3. So here I can just say negative 3, and then I'll write 1 over 27 minus 6x minus x squared and then dx. So this is substitution. And I know for a fix, the final answer here when you integrate is going to give you negative square root of 27 minus 6x minus x squared minus 3. But let me just show you how it comes about, because for me I know it's going to be negative whatever you have. So now let me show you how it comes about. Let me okay, so this is, I'll tell you if this is true when you integrate. Okay, let me let u equal to this one here, 27 minus 6x minus x squared. So du equal to, this going to be 0, this going to be negative 6, and this going to be negative 2x, but this is dx. So this is replaced by du. So all this stuff equal to du. Look, all this stuff here. Well, negative 2x, negative 6 minus 6, okay, du. So say integral of du, and then over negative 2. So I can say negative 1 over 2. And then, so it's going to be what? Square root of u. Square root of u, because it's going to be square root of u. Square root of u is like u a half. So this let me say negative a half. Okay, I can take u to the top, negative a half integral du. And this is going to be negative 1 over 2. You add a half because this is a power rule of integration. When you add a half, it's going to be u a half. This like u squared. And then because it's going to be add 1, it's going to be u a half over half. So over 1 over 2. This 2 into 2 cancel. So like negative square root of u. What is u? Our u equal to 27 minus 2x, 6x more 6x minus x squared. That's why I say if I integrate this, I'm going to get that, which is true. You see what I'm saying? But I show this in exam, just in case of the exam. So I'll just erase this, but that's how you do. Make sure you do that in exam, because that's how you're going to get marks. For me, I know I can do straight away because I'm trying to do shortcut. So like I said, I do integral inside the integral. So this side here is going to be integral. Okay, now I have to do this by completing the square. How am I going to complete the square? Look, it's negative. I can take negative out to be left with x squared, and then this is going to be plus 6x, and this is going to be negative 27. Let me separate here because I want to do negative 27. Okay, so complete the square means I'm going to have to add, take this number divided by 2 squared. 6 divided by 2 equal to 3, 2 equal to 9. If you plus here, you must minus. So it's like it did not change. I mean, plus or minus 0. Okay, so now this is going to be x plus 3 square with this one when you perfect square minus 36. Okay, this is going to be negative x plus 3 square plus 6 square, which is 36. So now I can replace that with this 1 over square root of 6 square, such to the 6 square, such to the 6 minus x plus 3 dx. So this is sine. This is sine inverse of a function. Why we say that? Because I have a and a function square and is a root a minus. So this is sine inverse of integration. So this one here we know 27 minus 6x minus x squared minus 3. Okay, this is going to be 1 over derivative function. So we'll give you what? It's going to give you 1, because when you derivate this you get just a 1. And then what we do, arc sine, because this is sine. Is arc sine or arc sinh? Is arc sinh. For minus is arc, no, is arc sine. Come on, arc sine. Okay, arc sine, and then write your function over our a equal to 6. See, now I'm trying to act like a zombie plus our c. Now you can put this in, so it's going to be negative 27 minus 6x minus x squared minus 3 arc sine, or you can say sine inverse. If you don't want to write arc sine, you can say sine inverse. Doesn't make any difference, the same. Sine inverse, you say x plus 3 over 6, and you plus your constant. We're done with that equation. So this is done, we come here. Does it record? Let's check and make sure. Yeah, it does record. Yes, it does record. Okay, cool. Now we go. Yeah, it's right. Okay, the first question is easy because that's a factor theorem. So it's like sine cos. Sine cos, I'm going to start with the Okay, for me I know. Let me just show you. So if somebody gives sine A plus B equal to sine A cos B, you know, if it's plus must be plus also sine, and then you have cos A, you replace this with the cos, and then leave your A, and replace this sine B. Now you come here. This is going to be sine A minus B equal to sine A cos B. If it's minus, it's going to be minus still. And they say cos A plus this cos A, and this is cos of B. No, this cos is going to be sine. Okay, so what you do now, you can add them and then you can subtract. Add and subtract. So what is the tension? You want to get what? Sine cos. So if you add this, let's add them. So this is going to be sine cos, means this group, that's what we need. Sine cos. So what we're going to do, I'll just add them, because if I add them, this is going to be sine cos. So now, if you add this, the same thing, sine cos, it's going to be 2 sine cos. 2 sine A cos B. I do that because I need sine cos equal to this, the first group plus the second group. Sine A plus B plus sine A minus B. So I don't need this 2 because I need sine cos. So divided by 2 is like 1 over 2. And then this I don't need because I divided by 2 divided by 2. Now, but what is our A? Equal to 5 angle, and this is theta. So it's a sine 5 theta cos theta equal to 1 over 2. Okay, 5 plus theta equal to 6A plus sine. Now we go 5 minus 1, 5 theta minus 1 theta equal to 4 theta. So I'm going to replace that with this. Oh, so the integral of sine theta cos theta d theta is going to become integral for half, but let me take a half out, and then I can write this because I replace all of this with this, but a half went out, and there'll be sine 6 theta. So let me just do this, 6 theta d theta. Okay, let me do this. Okay, d theta, and then plus integral of sine 4 theta d theta. A half. Okay, when you integrate this, let's start to the first group, means differentiate this, going to give you 6, and then when you integrate sine, you get negative cos. Now we go for the second one, plus we still have a half above. Now you differentiate down and you give you 4, and then when you differentiate sine, you get negative cos 4 theta. Okay, we plus constant because we don't have a limit, so you can just put together negative 1 over 12, and then cos 6 theta, and then minus, okay, minus 18 1 cos of 4 theta plus c. Done. Now let's go to the question number next one. Sine cos, sine cos. Okay, so sine and cos, whenever they say sine and cos, then you use compound formula for cos when it's like sine cos. Okay, cool. Okay, so we say sine cos. So we're going to come to compound formula of cos. Compound formula of cos for trig, let's say A plus B. So use cos equal to cos A cos B. Plus must be minus sine A sine B. Okay, cos A minus B. This same say cos A. I want to check if it's recording, right? Because I did a big mistake today. I record almost 2 hours. A series of 200 integral, and the camera was not recording. Just imagine. Whew. So it's going to be cos A cos B minus going to be plus sine A sine B. So now look, what do you want? You want to get sine. So how are you going to get sine? If you get sine, if I say plus here, this and this is going to disappear. But since I want to get sine, means for me to get this must go. So it must be minus. Because look, negative sine whatever, minus plus. Okay. So I'm going to use this for now. But if I want to cos, I'm going to use the face one. For a reason, you know, plus minus. Okay, now let's go. Negative sine AB minus plus negative sine B. Oh, this is going to give us negative 2 sine A sine B equal to cos A plus B minus cos A minus B. Now what we're going to do, now we say divide by negative 2 divided by, so 1 over 2 negative, so this is going to cancel. Okay, so sine, what is the angle? Sine 8x, and then sine 5x is equal to negative 1 over 2 cos, okay, AB means 8x plus 5x is going to give us 13x. Yeah, minus 8x plus 5x. 13. I kind of forgot. Now we say this is going to be cos. Hey, what is 8? 8x minus 5x is going to be 3x. So this is what we have. Or you can just put it in. You can say this is equal to, this is going to be positive. So you can say 1 over 2 cos of 3x, and then minus this one, which is 1 over 2 cos of 13x. So I can replace that with this. So it's going to be integral, which they give us, sine x equal to sine 5x dx equal to a half integral cos of 3. So I can take a half outside. 1 over 2 r dx, and then minus 1 over 2 integral cos 13x dx. Okay, now we go 1 over 2. Okay, when you integrate cos, you get negative sign, so it's going to be negative, but you must differentiate. This is going to give you 3 negative what sine 3x, and then we minus 1 over 2. Okay, when you differentiate 13, you get 13, 13x, you get 13, you write under, and then differentiate cos, you get negative sign. So negative and negative will give us positive sine of 13x plus our constant, because we don't have no limit. So this is the final answer here. It's going to be, this will be 6, and this will be 26. Easy. So I rather start to the positive face. I prefer right to the positive. X, and then go to minus 1 over 2 sine 3x, and then we plus constant. Easy. Now we go to question number cos. So for cos, I'm going to use the same one. I'm not going to erase that. We don't want to erase that. Okay, cool. Okay, now, so for cos means I don't need this now. So for cos I know I must plus. You know why? Because if I plus this and this, I'll get this and this is going to disappear, because plus, minus, plus is going to go away. And it's cos, so I must use the cos. Okay, so say this is going to give us 2 cos A cos B equal to, so I'll remove 2, I'll say 1 over 2. Okay, it's going to be cos A. What is A plus B? So I can do straight away. A plus B means 8x plus 5x. No. M plus this is going to be 8m, and this is going to be m, and this is going to be what? 7m. You see what I'm saying? Now we go. Okay, now we plus cos A minus B means m minus 7m is going to be negative 6m. Okay, but negative is going to be positive because this is an even function. So we're not going to have a negative, it's going to be positive for cos. So what I'm going to do is replace that. So say, okay, so integral cos 7m, cos of m, cos of 7m dm equal to a half is a half. It's like a half for the first one and a half for the second one. So half of integral of the cos 8m dm plus a half integral of the cos of m dm. A half, when you this is you differentiate, you get 80, integrate, that's negative sine 8m. We minus again, this is going to be 1 over 2. When you differentiate, this is going to give you 1, and then it's like 2 times 1 equal 2, and then sine, okay, sine of m plus constant. So I can start with the positive face. No, everything is negative here, right? Yeah, everything negative. So that's how you do. Why does everything negative? Yeah, everything negative. Yeah. This is going to be 16 here. Okay, now we go to question number 3. Question number 3. My whiteboard kind of getting dirty. Maybe I can use my hand to hand. I don't know if you guys can see if it's clear, or should I use hand to hand? Yeah, it's dirty. Use hand to hand a little bit. Okay, now we go for the next one. Still wet. Let me get something here that's gonna help me to dry it. Okay, this is gonna help us for drying. Okay, cool. Now we go to question number this one here. So if somebody gives you integral of e function of x dx, what you do is say 1 over derivative function right underneath, and then write exactly what it gives to you. We plus constant because we do not have a limit. So we're going to do the same here. Derivative function, when you derivate 4x, you get 4. And then write exactly. E 4x plus your constant because there's no limit. Now we come for this. Question 32. So this one, you have to know the double angle of trigonometry. So double angle of trigonometry is say, if you have a cos 2 angle equal to either cos, excuse me, 2 angle equal to, oh my god, sorry, equal to 1 minus, double angle equal to 1 minus 2 sine square angle, or it could be cos a double angle equal to 2 cos minus 1. So you can use either of the two, you see? But for this case, since I have a sine double, means this is the one. You see, sine square means I have to use this. If it was cos square, I was going to use this formula. So means I have to extract this from here. So it's like 1 minus 2 sine square 2x. So I'm just trying to place exactly. So for the new one, who don't know, 2 sine square plus, and then you see if this is 2, means this is going to become 4 because it's going to be cos. This is not theta, so it is 2x. So this is going to become like this angle is 2x. If I put 2x, it's going to be 4x. 4x. You understand what I'm saying? And then my intention, I want to place this here. So I have to make this subject. This is going to come back. It's going to be 2 sine 2x equal to 1. This is going to come here. It's going to become positive, and this is going to come here. It's going to become minus cos of 4x divided by 2 divided by 2. This and this cancel. So sine square 2x equal to 1 cos 4x over 2. Look, I'm just doing it for you, but I mean I can just replace straight away. You know what I'm saying? So now I'm going to plug this instead of that. It's going to be integral of these 2 is going to go behind. Okay, so 1 minus cos 4x over 2 dx. So this question has become that. So see 2 go to the back, 1 because 1 of 2 go to the back in the integral of 1, you say 1 dx minus integral of the second one, cos of 4x dx. I can erase this. So I'm going to do another one for sine. So for people. Okay, so now this is going to become 1 over 2. When you integrate d theta equal to theta, when you integrate dm equal to m, when you integrate dx, it's going to give you x minus a half is just a half. Okay, now when you integrate this, you have to differentiate whatever is in here. It's going to give us 4. You write underneath, and then when you integrate cos, you get negative sign. So it's going to be negative, so positive sign, because with that negative here, 4x plus our constant. We're done now. So this is okay. Like I said, when you finish, it's going to be 42, right? 43 actually, because with this 3. Now let's make it cos there. So it's going to be 44 now. Question number 44. Let's make it cos now. Same question, but let's make it cos. And then let's put that 3x. Say cos 3x. Let's say. So the same question, I will make a cos, okay? I'm gonna wipe it a little bit. Okay. Now, okay, so we say we kind of change it. So we say cos integral, and then we say this is 2. It's 2, yeah. 2 3x dx. So I want to go to the tricky double angle. So it's cos now, right? So it's like cos double angle. Let's say theta equals minus 2 cos minus 1. So this is what we want to get because it's square. But our angle 3x here, so it's like 2 cos square of 3x. If this 3x, look, this is 3x now. It's going to be cos of what of? 2 times 3, 6x minus 1. But I want to get this. So 1 go over is going to be cos of 6x plus 1 over 2 equal cos square 3x. You see? So that's how you get it. Take this one substitute right here. So it's going to be 1 over 2 is going to go to the back. And they'll be left with 6x. So it's like integral of cos of 6x plus 1 means integral of 4 to 1 dx. I hope that clear. Means 6x plus 1. This 1 over 2 which went out. So it's like integral of 6x and integral of the 1. So this 1 over 2 went out. Because you can separate. Now, so this is 1 over 2. And then let's differentiate this. Going to give us 6 out. Because this must go underneath. Differentiate this, you get 6. And then when you integrate cos of something, okay, means it's going to give you negative. It's going to be the negative side of the same thing. Now, this is going to be a half again. Okay, when you integrate, this is going to be x plus a constant. So this is 1 over 12. 12 is equal to 12, and then we're done. Now, let's count for that one. So for that one, it's easy. So this is for a 3 equation. So that one is easy. Okay, now they say integral 149 and then they say plus 16x squared. So this time they say integral 1, this is going to be 7 squared plus 4x squared, but we have a root. Okay, this could be hyperbolic or sinh because there's a plus here, but the problem, it cannot be tan inverse because there's a square root. So this time we say either hyperbolic or it could be trigonometric. Let's start with the hyperbolic. So for hyperbolic, if it's hyperbolic function, hyperbolic integral, this is how it's going to become 1 over differentiate this will give us 4, and then write your absolute and then write exactly for x or whatever is in here, and they say plus, and that should plus oh my god, this must be long here. Long. You write your long, don't forget, and then you write exactly here what you have, which is this one. 49 plus 16 x squared plus constant. Exactly. So start with the long and then over the number, or you can say 1 over the number, which is the derivative of that one, and then we continue. Now we're done with that. Now we count for this one. This is integration by part. Integration by part. Show you how we can do integration by part. No, I'll show you how somehow a little bit. So it's a different form of integration by parts. This is one of the by parts. Okay, integral theta and then cos theta d theta. So this is u and this is dv. Because the formula say u dv uv integral v d u. Okay, now how are we going to do? Our u equal to theta. So let u equal to theta. So du equal to d theta. Now we come here. Dv equal to cos theta d theta. So integrate and here you integrate. V equal to, when you integrate, this is going to give us negative sign. No, it's just positive sign. Positive sign. Okay, now we go. We have to substitute in the formula. So that equal to uv. So integral theta cos theta d theta equal to uv. U times v means theta sine theta minus u times v, and then v. What is a v? V equal to sine theta, and then you go for du. What is it du? D theta. So this time we say theta. Okay, you can just say here theta sine theta minus. When you integrate sine, you get negative cos. So this will become positive cos theta plus constant. So that's our final answer. Now we go to question number this one here. Okay. So cos, oh, this is similar to what I did. Integral of cos 4x, let's say 4 theta, let's say 4 theta, or 4x, it doesn't matter what. Okay, since I wrote theta, okay, let's say 4x, dx. So this is a compound formula. No, is a tricky double angle. So now I'm going to say, okay, so since we have a cos square, so come to the double angle. I know cos double of my angle always, but since it's cos square, means it's going to be 2 cos minus 1. But if you choose sine, I was going to use this 1 minus 2 sine square my angle. This is the same with that, this is the same with that. But for now, they asked me for cos, so I'm going to use the face one. So I'm going to say this is that. So it's like 2 cos square. What is my angle? 4x. So my angle for 4x minus 1. Okay. Now this is going to be cos 2 times angle. What is my angle? 4x. So 2 times 4x is going to be 8x. But my intention, I want to get cos square 4x. So I need this to be a long. So take 1 over, it's going to be cos 8x plus 1 over 2. Because it's going to be cos 8x plus 1 and then over 2 equal to cos square 4x. You see what I'm saying? And then so I will replace this with that. So integral and they say dx. 2 go to the back and then it's going to be 8x dx plus integral of 1 dx. 1 dx is like dx. 1 over 2. Okay. When you just differentiate 8x, you get 8. 2 times 8 equals 16. And then when you integrate cos, you get sine. Plus, this is going to be x, plus constant. A half also, don't forget your half. Done. Now we go for this one. Okay, now let's go for this one here. Cos, integral cos, this is easy, just like the one I did before. Let me say sine square. Sine square m dm. So what I'm going to do, just go to the compound formula, same. So compound formula say cos, double angle, okay, 1 minus, I'm going to use this now. For sine, I use this, for sine. Okay, so this similar to that. So it's like cos 2m is m now. Equal to 1 minus 2 sine. So I don't have to change anything. So I want to get this alone. So all this is going to go to the back. It's going to be 2 sine square m equal to 1 minus this go over cos 2m over 2 divided by 2. So I'll say this is the same as say integral. I have to replace that with this. So I'll say 1 minus cos 2m over 2. So this 2 is going to go to the back. So it's like say 1 over 2 dm. So I can separate. I can say this equal to integral. I have integral of 1 dm minus a half also because for both integral of cos 2m dm. So this is going to be 1 over 2. When you integrate dm equal to m. Okay, this is going to be a half. Differentiate to whatever you have here. When you differentiate 2m, you get 2. 2 times 2 equal to 4. Excuse me. Okay. And then when you integrate cos, you get sine 2m plus our constant. We're done. Okay, this is going to be 44 now. Question, let me do that one now. Sure that, or you understand? Okay, let me just do one for the people like, so it's going to be 44, 44, 45, 44, 45, okay. Cool, let's just do that one for fun, okay? So that's question 44 now. Okay, cos dm. Okay, so it's cos 2m now equal to 2 cos minus 1 from the formula. Okay, so now this is what I want to get. So say cos 2m plus 1 over this 2 go to cos square m rho. So I can replace this. It's going to be integral cos 2m plus 1 over 2, and this is going to be d. What I'm going to go to the back. Half go to the back, you say integral of cos 2m plus 1 over 2. 2 went into the back, d m. So what we're going to do now, we can separate a half integral cos of 2m dm, a half for the second one plus a half for the second one integral of 1 dm is like dm. So this is equal to 1/2. When you differentiate, it's going to give you 2, and then right here 2 times 2 equal to 4. You see, it's 4 for the first one, and then when you integrate cos, you get sine. What I just said, 2m plus 1/2. Integrate dm, you get m plus our constant. We're done. 45. Okay, question number 45. So this one, we're done. Question 45 question. Now let's go to the other more questions. Okay, cool. Now let's get serious for more question here. Let's get down with this, man. This one is done already. I'm checking some question, guys, okay? Okay, this one is done already. This one is not done. Did I do this? Not yet. This not yet, okay. Okay. Okay, there's all this question for you. I'm getting the question, right? Some more question here. I kind of misplaced. Oh, I got it. Okay. Now, let's go. Okay. Okay, let me just do straight away here. So we got integral here. Okay, 135 minus 12x minus 4x squared. Okay, dx. Okay. That's 47. Okay, and 48. 40. This is 40. 5, 6, 5. Okay, let's make 5. I can't remember. Okay, this 46. Okay, 46 is going to be integral x 32 minus 42x minus 9x squared dx. Okay, now we go down. Okay, this is going to be down already. Yeah, there's another one here. 47 integral. Okay, let me start with this so I can have a space, because sometimes it's hard for me to get a space here. Okay, I do this and then after that, okay, see 135, 135. Okay, now we go. So if you differentiate, okay, see, just a second, did I correct this? Okay, this when you complete the square, it's going to be 144 minus 2x plus 3. Okay, go and do different, complete the square, then you're gonna get this. Or you can even expand this, you see, look, okay, 2x squared is gonna give you 4x, and this is gonna give us 12, 12 is gonna be, 6 is gonna be 12x, and this is gonna be 9, look, 144 minus. If you minus this, look, this and this is gonna give you 135, positive 135, negative 4x square, excuse me, negative 4x squared minus 12x, which is there. So you can complete the square and you can get there. See? So if you don't know how to complete the square, you can go to my previous video to see how to complete the square. Just search completing the square. Okay, cool. Now, so now we're gonna say this is sine now, sine inverse, because there's a minus here, so it's gonna be 1 over derivative function. When you derivative this function, it's gonna give you 2, because it's okay. Sine, we always see integral of d x, and then you have a square minus function square dx. So the same is 1, and then derivative function, and then we're going to say sine inverse of a function, and then divide over a, and then plus our constant c. So we're going to do the same thing here. 1 over, okay, when you derivate this, you're going to get 2. Okay, now say arcsine or sine inverse is the same thing. Arcsine, get your function here, over a. A is like 12 square, this is 12 square, over 12 plus a constant. So we're done with that one. Now we go for question number that one. Okay. Okay, now this, when you do complete the square, it's going to be 81 minus 3x plus 7 dx. You can expand this. See, look, 3x squared equal to 9x. You can expand this, so you get the same thing here. So the next step, look. So first and foremost, you see there's an x here. So I'm going to have to do the same trick I do previously if you've been watching from the beginning. Because there's an x, so I cannot use sine inverse, cosine, or trigonometric or hyperbolic substitution, because there's an x here. So now I'm gonna have to think. Okay, I'm gonna have to think like how I'm gonna take this, and when I differentiate, it's gonna give me the one on top. Let me just do it. So it's gonna be x. Now, look, if you differentiate, it's gonna be 0. This is gonna give me 42, and this is gonna give us 18x. So I have to introduce this. Like when I differentiate, I have to get something on top. So how I'm going to introduce that on top? Let me write exactly. So negative 18x minus 42. So also at the same time, I introduce it, right? I have to introduce. It's like write something, it has to take it off, and it has to be x at the same time. So if you minus 42, I'll say plus 42 also. So this is like a 0. Now there's a negative 18. We don't need 18 here, okay? Because 18 was no part of the equation. So I'll say over negative 18 also. So can't you see, if you divide by negative 10, it's going to be positive x, 0, just a positive x you have. See, and then write your square root, which is 32 minus 42x minus 9x squared. Okay? Now we go. So now, we're going to say, I have to separate now. So the integral of the first group, which is negative 18, x minus 42, and then we over 18, negative, and then we root 32 minus 42x minus 9x squared. Okay, then we want to add what? 42 over negative 18. So you say negative 42. Okay, so 42 like this over negative 18. We can get, okay, we'll calculate now. 42 over negative 18. 42 over negative 18. It's going to give us what? Negative 7 over 2. Negative 7 over 2. So plus and minus going to be negative what? 7 over? Negative 7 over 3 over 3. 7 over 3. Oh yeah, okay. And then we're going to integrate what? This one, because it's going to be over 32 minus 42x minus 9x squared. Let's do this. Okay, so what I want to do dx here. Let me start with this, but we know from the beginning, I told you, whenever I introduce this is going to give us negative of this. 32 minus 42x minus 9x squared. See, and then we're going to minus 7 over 3, and then I replace that with this. because I know this is the same with that for a reason. So integral, so here we got this equal to that one, so it's going to be 9 squared minus 3x plus 7 by completing the square. Because there's nothing here, so it's going to be substitution 3, which is going to be sine. So another thing also, look, how did I get here? I think I explained to you before, but like I said, I'm just doing this stuff just for you, so let me take a little moment to explain to you. But me, I could just go straight because I know this is going to be that. But let me show you. For example, let u equal to this, 32 minus 42x, and then minus 9x squared. When you do this, it's going to give you du. When you do this, it's going to be 0, and this is going to give you negative 42, and this will give you negative 18x. All this is dx. So I'll take this and replace that with a du. It's going to be integral of du 1 over negative 18, so it's going to be 1 over negative 18 u squared, because it's going to be u. U squared is like a u a half. So negative 1 over 18, I'll take this to the top as a power rule, negative a half, and then I'm going to add by 1. Same thing right to the denominator, so it's going to be positive a half. But half and negative is going to be just positive a half. Okay, so these two and this could give us what? 9. Now I was wrong, I was actually wrong. So it's give me what? 9. So it's going to be 1 over 9. 1 over 9, yes, but negative, and then square root of u. What is a u? Our u equals 32 minus 42x minus 9x squared. 1 over 9 negative. So this must be 1 over 9 negative. Negative 1 over 9. Yes, I was wrong. Negative 1 over 9. So negative 1 over 9. Okay, now, so it's very good to do it. So now this is sine inverse, so it's okay, minus, so negative 1 over 9, and they say square root of 32, 42x minus 9x squared, and this minus 7 over 3, this is gonna be sine inverse. Differentiate whatever you have here is gonna be 1 over 3, because when you differentiate you get 3, and they say sine inverse, okay, it's arc sine. Okay, write your function, 3x plus 7 over our number, and then we plus our c. If you want, you can put it in. So this is going to be the same thing right here, and the minus is going to be 7 over 9, 3 times 3, and they say arc sine, and they can write exactly plus 7 over 9 plus our constant c. We're done. Okay, so let's go to question number 47. Let's see if it's recording. Let's see if it's recording. Yes, it does record. Can I please use the bathroom just for a second, please? I've got a problem with my tummy. Oh my god. Just a second, I'll be back now, guys. Thank you so much, guys. I apologize. I'm back. Thank you so much for your patience. Okay, now let's go. Let's continue. So now we got some more question here. The question say, yeah, it takes a lot of commitment, this stuff. You know, sometimes, you know, we continue. You know, thankful for the 3 minutes break. 3-4 minutes break. 4, 5. You can write down in the comments how many minutes did I take a break for. It's not like I should take a break because I had a problem. I don't want to explain more. Okay, especially when I drink milk or when I drink a lot of water, I go bathroom, I take number 1 every time I urinate and stuff. So okay, cool. Now let's go to the next question. Now this one, did I finish this? Yeah, this one I finished already. Oh yeah, we finished this. Now we go for Oh my god. I'll finish now, man. I'm left with see. Oh man, just second guys. This one's done. This one's done. This one's done. This one's done. Let's see. Yeah, this one's done. Okay. Now. Okay, let's just run this question now. Okay. For 8. Question for 8. For 8, they say integral cot 4 x squared dx 49 integral of cosec square ex 15 integral of e x squared dx 51 integral of tan 2x squared minus 4x plus 1 52 integral of 1 2x minus 5 dx 53 integral of sine 54 integral of sine I was meant to say 2 here. Integral of sine square 3x dx 55. This one down here, okay. Integral of sine 5x cos 3 just 2x here. $56 integral of cos 3x dx 57 integral 57 integral of tan inverse x dx 58 integral of sinh dx 59 integral of x cubed ln of 2x dx 16 integral of ln 2x dx and then yeah, let's do this up to 60. Okay, cool. Okay, now we go. So if I do all this, I'll be 60. Let me start with this one. So this is by parts. This one here is by parts. So look, you let this is a u and this is going to be dv. So the formula say integral of u dv equal to uv integral of v du. Okay, now, so we're going to say u equal to, let u equal to ln of 2x. du equal to, when you differentiate, this is going to give you 2 over 2x dx, 1 and this one. So it's going to be 1 over x dx. So just 1 over x dx, 1 over x dx. So now dv equal to dx. Integrate and integrate. So v equal to x. So v equal to x. Now what we do? Substitute in question here. So this integral is going to be equal, this equal to, this is this, equal to uv. Okay, let's write it. So integral of ln of 2 dx equal to u times v. What is u? This is u and this is v. Will be x ln of 2x minus v. V just x du. What is a du? 1 over x by 2. 1 by 1 1. So it's like integral of x, which is x. When you integrate dx equal to x. So this is x and this will be x ln of 2. This question is done. Now we go to the previous one. So for poison, for this, yeah, say the poison. Okay. So now we go to this question here. So this is more easy. This also by parts. So I'm gonna say integral, but this will do difference now. Look, whenever you have a loan with something, make sure you differentiate the loan by parts. So if you have this, is also by parts. But you can go to my video, check only integration by parts. You see all this stuff I explained. So this is integral, negative x dx. So for this case, this is gonna be u, and this is gonna be dv. So what is a u? But for this case, this is u. So you have to know if it's long integration with nothing, then this is u. But if it's inverse of trigonometry, then this one here, integral inverse, is u. So let u equal to sin inverse of x. And then you differentiate, this is going to give you 1 over 1 minus x squared dx. You know what I'm saying? Okay, because this is 1, so you write your a just a 1 minus this is x, is a fx square, and then when you differentiate this x, you get to 1. Okay, dx. Now we go for dv. dv equal dx. So dv equal to dx. Integrate and integrate. v equal to x. So now we go uv. So all this stuff which is integral sin x dx equal to uv. What is a u? This is a u. This is our u and this is our v. So u times v means x times sine inverse minus integral minus integral v. What is our v? V equal to x times du. What is a du? Du equal to, this stuff must be written here. It's going to be 1 minus x squared dx. You see what I'm saying? So now this one here, x times 1 is just x. So this is going to be tricky substitution itself. So let me call this a star equation, and let me deal with this, and then I'll come back and substitute. So let's let here u equal to 1 minus x squared. So when you differentiate, it's going to be du equal to, this is going to be 0, negative 2x dx. X dx, I can just divide by negative 2. So x dx divided by negative 2 divided by negative 2. X dx equal to du over negative 2. Du over negative 2. U. So this du over negative 2 is going to come here. So say, okay, I can say minus negative 1 over 2, because this negative 2 is going to go back, and there's the integral x dx. What is x dx? X dx equal to du over negative 2 means this. Okay, let me write like this so you can see. Du over negative 2. And this dx, and this going to be 1 over square root. But this one here equal to u. You see what I'm saying? So negative 2 can go back. So negative 2 can come back here. Can be 1 over negative 2. And this u, negative u squared is going to be u a half. I can take to the top, it's going to be u negative a half. But I make sure you show all your steps. You see what I'm saying? And then what I'm going to do when I integrate, it's going to be negative, negative, positive. Because it's going to be negative, and this negative is going to be positive. So half. And this is going to be u. Negative half plus a half is just a half, which is going to be positive. And here's going to be also a half. 22 cancel, so square root of u. But what is our u? We know the value of u equal to 1 minus x. So it's like square root of 1 minus x squared. When you integrate all this, let me see if it's recording. Does it record? Oh yes, it does record. So it's going to be square root of 1 minus x squared. Square root of 1 minus x squared. 1 minus x squared square root. You see what I'm saying? So if you integrate this one, you get that one. But there's no limit, so we just have to plus c. We're done with that question. Now we go to question number. So this done, this done. Let's come here. Okay, when you integrate chord, when you integrate chord, you get ln sine, I believe. Yeah. When you go to get ln of sine, so by, okay, look, when you integrate cot function, so it's going to be derivative function, and it's a ln of your cot, of your ln of cot sine function. So this is going to be 1 over, okay, derivative is going to give us 8x, and this is going to be ln of sine of a function. What is a function? 4x squared plus constant, because we don't have no limits. Now let's come there. 49. 49. Okay, when you integrate cosec squared, you get negative cot. So it's going to be 1 over differentiate that. It's going to give you the same thing, and it's going to be negative cot of a function plus constant. Okay. Now let me come and do this one here. Okay, so what I'm going to do, this is by parts also. So this is going to be u, and no, this is u because it's ln, and this is going to be dv. So the ln always going to be u. Ln is something u, and this is by parts. When you have a, let me see if my light is okay. Just a second, guys. So yeah, my light is fine. Let me see. Maybe I can try to shift like this. Yeah, I believe you can see. Let me see. Closer, more closer. Can you see? Yeah, I believe you can see. Let's try to put here other angle. It's much better. Okay. So now I'm gonna say whenever I have a ln of something, this is u. So say let u equal to ln of 2x, and then dv equal to x cubed means this. So I can read what I say. This is the same as say ln of 2x and then x cubed dx. So this is dv, this is u. U is this, and this is dv. The rest, u. Okay, dv. Our dv equal to x cubed dx. Now we integrate here, and here we differentiate. When you differentiate, you get du. When you differentiate, this is going to give us 2 over 2x dx by 2 1 by 2 1. So it's like 1 over x. When you integrate dv, you get v, and when you integrate, this is going to be x 4 over 4. Now we come and substitute in the formula. So when you integrate all of that, which is integral of x cubed ln of 2x equal dx equal to uv. What is a u? U equal to ln of 2x times v equal to this one. So you can say I'll start with the x power 4 over 4 is a good word, right? And ln follow after. Minus integral v. What is up with v? This one here. X4 over 4. So I can take over 4 at the back. Okay? And then here just be x4, and then you multiply by du. What is that du? Du equal to 1 over x. So 1 over x by dx. Okay, 1x going to 1x go, so it's going to be only x3 here. And this go, because you cancel x3. x3 times 1 is just x3, so it's 3 dx. So this is going to be x power 4 over 4 ln of 2x minus 1 over 4 power rule. Add by 1, and this is going to be 4 over 4. So x power 4 over 4, 4 times 4 equals 16 plus constant. We're done. So now we come to here. Come here. Okay, cool. So here is easy. So what I'm going to do, I'll go to question number. If I finish this, means I'm in 60, like I said. Because, okay, integral of e, negative x squared, is negative 4. So, okay, let's make negative, no problem. I mean, it's positive, negative, okay. Now, when you differentiate function, it's going to be 1 over, differentiate what we have, is going to give you negative 2x, and then write exactly. Plus constant, because we don't have a limit. Let's go to the next one. This is for 15. Okay, now let's go to the next one. Integral of tan 2x minus 4x, and then plus 1. dx. So just know the formula. Like when you integrate tan, what do you get? When you differentiate tan, you're going to get ln sec. So about 1 over derivative your function, which is going to be 4x. Okay, minus, when you derivate 4x, you get 4. And then you can derivate 1, you get 0. And then it's going to be ln bracket sec of your function, which is 2x minus 4x plus 1 plus constant, because we don't have no limit. Now let's go to question number 52. Question number 52. Okay, question number 52. Integral 1 to x minus 5 dx. So this time, say if somebody gave you 1 over function dx. So this time, say 1 derivate your whatever you have here. So 1 over f prime, and they say ln of this function plus constant, because no limit. If you have a limit, you substitute for. So for this case, you say 1 over derivate this. When you derivate, you get only 2, because 2x you get 2, 5 you get 0. So just 2. And the ln of absolute, you write your function. You plus your constant. Now, let's come to this. With that one, we did already. We say, if somebody gave you cos of, let's say, 2x, this MSA is sine here, right? So let's use a sine formula. 2 sine x. So this is what we need to substitute there. So let me take this, make subjects 2 sine, go to 1 minus cos, make a subject 2, so divided by 2 out, so divided by 2, this 2 cancel. So okay, so now I can just say, I can replace that, so it's going to become, instead of writing this, which is this, equal to that, so 1 minus cos 2x over 2, so I can take this 2 back, dx. So 2 goes back, it's going to be 1 over 2, and then I can say integral of the first one, which is just 1 dx. 1 dx is like a dx, minus integral of cos of 2x dx. These are half for both. So I can say 1 over 2, this is going to give me x, minus this is a half, we still have a half. Derivate this is going to give us 2. 2 times 2 equals 4, because it's going to be 2. And then when you integrate cos, you get negative sign. So negative sign is going to be positive. Sine 2x. 2 times 2 equals 4. Plus constant. Done. So now we go to question number 54. Question number 54. Okay, question number 54. Question number 54, this one right here. Oh my god, it is the same question, but now 3x. So I'll say, okay, integral. Let me substitute straight if I say, if I can remember. Okay, sure. Also, it's like cos, double angle. What is my angle? My angle 3x. Because, okay, now this equal to 1 minus 2 cos sine, excuse me, square of 3x. Now, to make these subjects is going to be, okay, it's going to be 1 minus cos of 6x over 2 dx. You can just make subjects slowly like how I did in previous question. Let me show slowly so you know. Okay, so it's supposed to be x cos 2 theta equal to 1 minus, since this is sine, so it's like 1 minus 2 sine square of your angle. What is the angle? Our angle is 3x, so it's like 3x square sine 2 minus 1 equal 2 times angle. This angle 3x, so 2 times angle is going to be 6x, so cos of 6x. And then you want to make subjects that. So cos of, no, we make subjects this because we must go back here. So if you must go back, it's going to be what? It's going to be 2 sine square 3x equal to 1. This go over minus cos of 6x divided by 2 divided by 2. So sine of this equal to 1 minus cos 6x, that's 1 minus cos 6 over 2 over 2. That's what I say there. So this equal to that. Okay, dx. Now take 1/2 outside, this is going to be integral of 1 dx minus integral of cos 6x dx. 1 over 2. When you integrate dx, you get x minus a half. Okay, this is going to give you sine. When you differentiate, this will give you 6. Sine of 6x plus constant. Now this is going to be 1 over 2 minus 2. 6 times 2 equal to 12. You're done. Now we go to question number 55. 55. Okay, let's go to question number 55. 55 is going to be integral. Okay, sine 5x cos square x dx. Okay, so what I'm going to do, I think the one which is prime number, but odd number, is the one that I'm going to split it. So let me take this one here and this one here. So the even number, don't worry about this. Okay, so this is going to be sine square x square, and then it's going to be sine x dx, because it's going to be sine x, you know what I'm saying, which is called sine 4x, sine 5x. Does that make sense a little bit? And this is for a reason I do that. So this let me say, okay fine. So now this is going to be let's make everything cos. So this is going to be cos, okay, sine square x like 1 minus, means this 1 minus cos square x, but we have a square, and then sine, just sine x dx. So now let's let, since everything here is cos, let u equal to cos x. Differential is going to be du, differential is going to be negative sine x dx. So this is sine x dx. So take negative this side. So I can substitute everything in terms of u. So this question is going to become integral for u square, 1 minus u square, and then square, and this sine x dx equal to negative du. So take negative out, and then right here du. So it's the matter of simplification now. So now I have to start with this from the bottom. As you start with the bracket. Okay, now let's simplify. So 1 minus u square times square means the same thing, minus u square. Now 1 and 1 and 1, and then 1 is going to be negative u square, negative 2, negative 2u square, and then this and this is going to be plus u power 4. U power 4, and then also we must multiply by u square. It's u square. Let's multiply now. So when you multiply, it's going to be u power square to u power 4 plus u power 6. Okay, so integral. So I can just write here, say this stuff is going to become integral of u square minus 2u power 4 plus u power 6 du. Okay, now, so this is going to become, okay, now we can power draw. It's going to be u, 2 plus 1 equal to 3 over the same thing, 3 minus 2, 4 plus 1 equal to 5 over the same thing, 5. U power 5, excuse me, u power 5 plus u, 6 plus 1 equals 7, because this power over 7, because you must integrate for each one. So now we know our u. What is our u? Our u equals to cos x, so we can substitute it there. Cos, it's going to be power 3. 3x over 3 minus 2 cos 5x over 5, and then plus cos 7x over 7 plus constant c. Now we're done with that question. Now we go for this one. Now we go to question number, which question number? Can't remember. Okay, question number 56. This one here. But is a 61. Okay, if I finish, it's going to be 60, but there's another one at 61. But she's not in the right order because we did that one. The number 661, they were here. Now let's go. Integral. Okay, cos q. So I'm going to put square x, and I'll put just cos of x dx. So I'm going to say this is same as say integral 1 minus sine square x cos x dx, and this is going to be our let now. Let's say m equal to sine x dm equal to cos x dx, which is this one dm. So this is going to become 1 minus m, we use m now, square, and this is going to be dm. All this is dm. So now this is going to become, when you integrate 1 dm is like you get m minus m cubed over 3, because you can expand it slowly. Because it's going to be when you, okay, let me just, so for some people to know, integral of dm, integral of m square dm. So this is going to give us m, and this is going to be plus 1 3 plus 1 3 plus us m cubed plus our constant. But we know the value of m equals sine x. Sine x minus sine cube x over 3 plus c. Okay, now we go to which question? We go to this one here. So integral, this is by parts. So this is going to be what? U. So I'll let u equal to tan inverse of x, and dv is going to be this, dx. Okay, so now integrate, differentiate, when differentiate is going to give you a du. When you differentiate, this is going to give you, because you differentiate the x, will give you 1, and this is going to be 1 plus, so this is 1 plus, and then square that dx. So after you differentiate, now you come here, we integrate, so v equal to x, substituting the formula. Okay, we substitute the formula, it's going to be integral of tan dx equal to uv. What is that u? U equal to this, and this is equal to v. So it means it's going to be x tan minus integral v equal to x times du. What is that du? Is 1 over x, 1 plus x squared dx. So what we can do, x times 1 is just x. Okay, so now we have to come here and do substitution. So substitution, this is easy because I'm going to say let. So this is, we know it's going to be the same, but here. So let me bring the entire so I can have some space. Okay, so I'm going to let, because I don't know if this space is going to be enough. So let u equal to 1 plus x squared. So differentiate get du, and this one differentiate will give 2x dx. Okay, so x dx is x dx. I can just divide by 2, is going to be equal to d over 2. That's the x dx. You see what I'm saying? And then this 1 plus x squared equal to u. So I can just say, for this part here, is going to become x dx equal to u over 2. It's like the u over 2. But this 2 can come back, so it's 1 over 2. Because it's going to be 2 is going to come back, because the u over 2 is like 1 over 2. It went back, so I'm not going to write this 2 anymore. Okay? Because this is x dx, x dx. Okay, let me write slowly for some people to know. U over 2. 1 over, this is u. Because x dx, u over 2, and this is 1 over u. Okay? Takes 2 to the back, 1 over 2, and the integral of 1 u du. So it's like 1 over 2 ln of u, absolute plus constant. But we know the value of u, 1 over 2. What is that value of u? U equal to tan inverse. So I can say ln bracket tan inverse plus constant c. Okay, so now this is going to become x ln x tan ln tan of x minus, okay, all this stuff we got a half ln absolute tan inverse x plus constant c. We're done. So all this question are done. 61 with those 3, with those 4, 61. Now let me use my handy and clean up the whole board, and we continue. You want to check if it record? Yeah, it does record. Okay, cool. 62 integral of cos x ln x dx. Okay, integral 2x dx okay, and then integral m cos of m dm, and this is let's not do all of this. Okay, now we come here. Integral x squared ln of x dx. Integral 0 pi x cubed cos of x dx. Integral of p power 5 ln of p dp integral of t sine mt dt. 67. Let me see. Just if it okay, cool. 7. Okay, 68. Integral of e 69 integral for 9 ln of y integral integral (72) integral okay, cool. Let me start this first. Sin x dx. Okay, now let me start with this. Here we go. So now I can start with the other one, doesn't matter. Okay, let me go with the number now, because at first I was not going with the number. Sometimes it kind of get people confused. Okay, 62. So 62, they give us integral cos x, and they say ln of sine dx. Okay, now look, this me based on what I'm gonna do. This is kind of substitution, and then I'm gonna say first, let me rearrange. I'll take this right here for a reason. So I'm gonna say cos x here. It's the same thing, but I'd rather say, but I can just leave it like this, doesn't matter. Okay, oh, let me write cos x after for a reason. Like they give me like that, but I'm gonna write cos x after. You see why I do it. So I'm gonna let u equal to sine x. When you differentiate, it's gonna be u cos x. So cos x. So instead of cos x dx equal to du. Okay, so this question here is gonna become integral ln sine of x equal to u, and then cos x dx equal to du. See now, this is integration by parts. So let's use another letter for a reason. Let's say this is k. Because in by parts I have to use u, that's why. So let's say this is what is k. Okay, let's use what? Do by parts. So when you do by parts, we know the formula for by part is always say integral u dv equal to uv minus integral v du. So now, whenever you have a ln of k or ln of anything, then this is going to be u. This is going to be u right here. You see what I'm saying? So I'm going to say let my u equal to ln of k, and then my dv, for this case, is going to be this, because look, u and then dv. So if this is u, this is going to be dv. dv equal to dk. So when you differentiate, this is going to be du equal to 1 over k dk. And then when you integrate, v equal to k. So this stuff, it must come in here inside. So when you integrate this, I want to make sure the space must be enough. Equal means when you integrate this ln of k dk equal to uv. What is the u? U equal to ln of k times v equal to k. So I'll start with the k and they say ln of k minus integral v. What is the v? V equal to k times du. What is the du? Du equal to 1 over k, and then dk. This one. So k and k cancel, so it's like integral of dk. Integral dk equal to k. K here. So minus k. Okay. So all this equal to there. But in exam they did not give us k. They give us everything in terms of xx. But what's the k? K means sine of x. It's gonna be sine of x. Ln of k means ln of sine of x minus k. What is k? K meaning sine of x. So that's how you do it. With plus constant because there's no limit. So the first one we're done. Now let's go to the next question here. Okay, cool. So now the second question, they say integral of 2x plus 3 and then e power x dx. So this is going to be u and this is going to be dv. See, so I'm going to let u equal to 2x plus 3 and then dv equal to ex dx. When you differentiate, it's going to be d u equal to 2 dx, 2 dx, yeah, 2 dx. And then when you integrate this, v equal to ex, the same thing. Let's substitute in the question. The question says integral or by parts u dv equal to uv minus v du. Okay, so u means you write the same thing here. U dv means this. Equal u. What is a u? U equal to 2x times v. V equal to e power x minus v e power x multiplied by du. What is a du? Du equal to 2 dx. So I can write here 2 dx, but I can take 2 to the back. Okay, so when you integrate this, you're going to get the same thing. Integral of ex is es. You say this is ex, e power x. So 2 e power x minus 2 e power x. We plus the constant. Finish. Now we go for the next one. 64. Question number 64. Okay, question number 64. You say integral of m cos of m dm. Okay, m cos of m dm, m cos of m. So this is also by parts because it's going to be like integral of u dv equal to uv minus v du. Okay, so now we're going to say here, very easy. We're going to say I'll let this equal to u. Let u equal to m and dv equal to cos m dm. Now differentiate is going to be du equal to differentiate m is going to be d dm. Now let's come here, this is going to be v. When you integrate, and then we integrate, this is going to be sine. Okay, let's substitute back. So substitute u dv means this is this equal u times v. U times v. So m sine of m minus integral v. What is that? V sine of m. V is sine of m. And then we say times du. Du equal to dm. So finally equal to m sine of m minus, okay, when you integrate sine of m, you get negative cos of m. Negative, positive cos of m plus constant. We're done. Now let's go to question number 65. Question number 65. Man, I didn't sleep last night. Yeah. Okay, question number 65. Question number 65, they give you an integral of x squared ln of x dx. So what I'm going to show, this is by parts also, so I'll let, this is going to be u. I told you whenever you have a ln, and then the other one is going to be u. So this is going to be u, and this is going to be d dv. So I'm going to say x squared, okay, let's put it like this. So ln of x, x squared. I'm going to rearrange. Okay, nobody going to arrange for you in exam. You have usually common sense. So say ln of x, and then I'm going to come here and say x squared is x squared, yeah, x squared dx. So this is going to be my u, and this is going to be dv. So u, u equal to ln of x, so u equal to ln of x. Differentiation will give you du, when you differentiate this will give you 1 over x dx. Okay, integrate this is going to give you x cubed over 3. So v equal to x cubed over 3, because it's going to be like this, look, dv equal to x squared dx. So integrate, this could be x cubed over 3. And this when you integrate dv, you get v. So substituting the equation, it's going to be uv, because it's going to be integral of u dv, uv minus integral v du. Okay, uv means u times by v. It's going to be x cubed over 3 ln of x minus integral. Now we go v. What is a v? V equal to x cubed over 3. So I can just put the 3 out, and then we're going to say multiply by du. This is du. Du is so 1 over x dx. Okay, 1x and 1x goes, so it's like x squared dx. So it's like you integrate x squared dx. So when you integrate, you're going to add by 1, and then you add by 3 over 3 also. 3. So I can say this is going to be x3 over 3. So when you integrate this, it's going to be 3 over 3. Over 3, so it's going to be x3 over 3. 3 times 3 equals to 9. So it's going to be x cubed plus 9 plus constant. Finish. Now we go to question number. Which question? 67. Oh man, I did an equation here, sin x. Okay, no problem. I'll remember sin inverse of x. Okay, cool. Now we go. So now 73. Now we go to question number, which one? This one here. So integral p power 5, and then you go ln of p dp. So this is just like a previous, but they asked another way. So like I said, rearrange this. I'll say integral of ln of p, and then multiply by p power 5 dp. So this is my u here, and this is going to be my dv. Okay, so I'll do straight away. I'm not going to write integral, whatever that formula, because I know. Okay, u equal to ln of p. Differentiation is going to be du equal to 1 over p dp. Now, integrate that. When you integrate, this is going to give you v equal to p power 6 over 6. Let's substitute. uv, what is a u? U times v, 6 ln of p minus v. So it's going to be v equal to p power 6. But this is 1 over 6 must go back. du is 1 over p dp. 1p and 1p cancel, so like p5. p5 plus 1 equal p6 over 6. So p6 over 6. So this is going to be 6 over 6. And 6 times 6 equals 36. So p6 over 36. Plus constant, we're done. Now we go to question number 67. Question number 67. Let me see if you're recording. Yeah, question number 67. Yeah, 67. So it's an integral. Oh my god, I don't need this. Okay, so integral t sin, okay, t sin mt dt. So this is going to be u and this is going to be dv. So u equal to t is by parts also. dv equal to sin mt. Now dt. Now we go. Differentiate this is going to be du equal to dt. When you integrate, it's going to be v equal to. When you integrate since you get cosh, but it's going to be 1 over. You must differentiate mt, which is going to give you m, and it's going to give you cosh mt. Okay, substitute. So when you substitute, you know uv. So all this equal to uv. What is a u? Equal to t from by part formula times 1 over m. So it's like over m, and there's a cosh mt minus integral. Okay, now v equal to 1 over m, but 1 over m is constant, so I can take this out, and this will be cosh mt multiplied by du equal to dt. So this is going to be t over m cosh mt minus, okay, we have to differentiate. This is going to give you only m, so m is going to come at the bottom again, going to be 1 over, because look, you differentiate mt, you're going to get m times m squared. Now when you integrate cosh, you get sinh. Okay, so we're done with this part. We go there to the top. So this is done already. Okay, let me use my handy. That seems like the deadness don't want to go away. Okay, cool. Now we go. Let's go, man. So now we have this one right here. It's easy. So what I'm going to do, this is going to be my u, this is going to be dv. So I'm going to say u dv equal to uv minus integral v du. Okay? So now we say, what is our u? U equal to tt. Okay, u. Okay, let u equal to t. Differentiate u is going to be du, and this is going to give you 2, just a 2d du dt. You see what I'm saying? Now, we come for the next one, dv equal to this one, cos 3t dt. Okay, when you integrate, here you didn't integrate, v equal to, it's going to be 1 over differentiate, that one is going to give 3. When you integrate cos 3t, you get sin 3t. Okay, sin 3t. And then what we're going to do? We're going to substitute here back. So all of these, which one am I doing? I forgot. This one, right? Which question? Yeah, this one. Yeah, okay. 2t cos 3t dt equal to uv. What is the u? 2t times 1 over 3. So I can say over 3, and they say sine minus v. What is a v? V equal to 1 over 3. 1 over 3 sine 2t. Okay, multiply by du. What is a du? 2 dt. So I can take 2 out, and then this is going to be dt. It's finished. So this is going to be 2 over 3, and they say t sine 3t minus 2 over 3. Now, when you integrate sine of a function, differentiate this, is going to give us 2. 2 times 3 equals 6. Okay, now when you integrate sine, you get negative cos. It's going to be cos 2t, but negative. So negative is going to make it positive. 2 over 6 equal to 1 over 3. Okay, and then you plus constant because we don't have a limit. We don't have a limit. So now we go to this one here. So 7.3, let's go 7.3. Now let's start the rest of the question, then we're going to go to 7.3. Okay, now let's go for that one. So we're going to do the same thing. This is going to be u, and this is going to be dv. So when you let u equal to e to theta. So the u equal to, when you differentiate this, going to give you 2. When you differentiate right, you take a function, differentiate right behind, then e to theta d theta. That's the difference between integrate. When you differentiate, you write your function derivative at the back. See? So we got that one. Now we say dv equal to sine 3 theta d theta. So we do integrate, and then we integrate v equal to 1 over 3. 1 over 3, and then when you integrate that, so you need to differentiate to get 3, another 3. Okay, and then when it's going to be negative cos 3 theta. So what you're going to do right now, when you take this and substitute back in u dv. So this is going to be u times v. What is the u? This times that. So negative 1 over 3, and then negative 1 over 9, and this is going to be e 2 theta multiplied cos 3 theta minus integral. You see what I'm saying? Now you go v 1 over 9. So 1 over 9 negative, so it's going to make 1 over 9 outside, and then cos of 3 theta. Now you go times du. Du is this 2 whatever, so 2 is going to go to the back, and there's going to be e 2 theta d theta. Okay, cool. Now we have to take this and do another by part again. So let's call this type equation. You see what I'm saying? So all this stuff equal to this. So I can write here integral e 2 theta sine 3 theta d theta. Okay, now what we're going to do now? Let me take this and solve it separately by parts. See what I'm saying? I can solve this by parts. Okay, so let me write e to theta first. E to theta. Okay, let's do this by parts separately. So I'm going to say, and then I'll come and substitute here. Okay, now we say integral, let u equal to e to theta, and then dv equal to cos 3 theta. Okay, differentiate this will give you du equal to 2e 2 theta d theta, Integrate is going to be v equals to integrate is going to be 1 over 3. When you integrate cos, you're going to get sine 3 theta. Okay. Yeah. Cool. Now we're going to say uv e 2 theta, v 1 over 3, so 1 over 3 sine of 3 theta, and then minus v this one 1 over 3, so 1 over 3 must go back, and this going to be sine 3 theta dv du equal to this one 2e whatever, so I can take 2 out, 2, and they'll say e 2 theta d theta. So this you see is similar to that, so we're going to do moving back. So first and foremost, let me take this and substitute right there. So because of the space, so I'm going to say, okay, so I'm going to erase this and substitute this one right there. All of this in there. But an exam, make sure you say, okay, substituting it, star equation, sub into, for this case, this equation. So the question is going to become, excuse me, so this question here, instead of writing this, I'm going to write all of this inside here. So this is going to become 1 over 3 e 2 theta sine 3 theta, okay, minus, okay, this and this is going to give us 2 over 27. That's right, 2 over 27. Okay, now we go choose 2 over 9. No, let me go step by step. It chose 2 over 9 here, step by step. Don't do a lot of things once. 2 over 9, okay. 2 over 9. And this will be 1 over 3. Okay, sine, okay, minus 2 over 3. Integral sine 3 theta e 2 theta d theta. Yeah, so what we're going to do, we're going to multiply that out. We're going to multiply that, it's going to be 2 over 27 here. Okay, 2 times 9 is going to be 4 over 27 also. Oh, no. 4 over 27, yeah, 4 over 27. 4 over 27, 4 over 27. So what we're going to do now, the question is finished. Look how I'm going to do. Okay, so what we're going to do, you see, this and this are similar thing. Can't you see? Integral sine and e 2 theta and sine. Or I can read like this. I say e 2 theta and sine. Like e 2 theta sine 3 theta. So it's like, look, can't you see this is the same? You there? Look alike. So this is negative. We'll take over is going to be plus. So it's going to be e integral of e 2 theta sine 3 theta d theta plus 4 over 27 e 2 theta integral, and this is sine 3 theta d theta equal to this and that, which is 1 over 9 e 2 theta cos 3 theta plus 2 over 27 e 2 theta sine of 3 theta. So what I'm going to do, okay, now this is like a 1 plus 4 over 27, 1 plus 4 over 27, 1 plus 4 over 27. It's going to give us what? 31 over 27. So this is going to give us 31 over 27 of what? Because I put them together. Integral of what? Of e 2 theta sine 3 theta d theta equal to that, which is 1 over 9 e 2 theta cos 3 theta plus 2 over 27 e 2 theta sine 3 theta. Okay, now what we want to do, divide by 31 over 27. So each one divide by 31 over 27 divided by 21 over 27 divided by 31 over 27. So just divide these two and give us the answer, and give the answer here and then write exactly. Okay, now we go. 1 over 9 divided by 31 over 27. Okay. 1 over 9 divided by 31 over 27. 3 over 31. 3 over 31. So this one here is going to give us 3 over 31 together. 3 over 31. Now you do the same thing here. 3 over 31, 3 over 31. Three over 31. You see what I'm saying? That one you got. Okay, so you see the question is done. It was easy like that. Now we go to this one and this one and that one. Okay, cool. Let me see for the code. Let's see for the code. Let's see for the code. Yeah, it does record. Yeah, I think it's record. Okay, now let's continue. So now, this one is done already. So let me just erase it, all of it. Okay, let me just do that. Use this. Okay, let's just put in the water a little bit quick. So hold it. Just a second, man. Just a second. Be done. Okay, cool. Oh, sorry, I apologize. Just almost deleted the question. Is sine inverse, okay. Okay. Okay, this is better now. Okay, now I'm gonna go faster so I can just get make sure like everything's. Yeah, I'm just checking, make sure, you know. Sometimes I say record and then does it record? Yeah, it does record. Guys, you know why I do it every time? I'm so sensitive because yesterday I was solving 200 integral and then I finished everything and realized I was not recording. I was very upset. I swear to God. I was so upset. Okay, cool. Okay, cool. Let's go. So I'm gonna go question number 69. 69. So they give us integral and they say 4 to 9 and they give us ln of y. So what I'm gonna do, I'm gonna separate because I know this is gonna be by part. And then dy. So what I'm gonna do, let me reciprocate. So this is gonna say integral 4 to 9, 4 to 9, and this is gonna be y a half, negative a half. Take it to the top, and this is ln of y, dy. So from by part integral, our integral of u dv equal to uv integral v du. Okay, so what is our u? Our dv, our u is going to be ln. Whenever we have a ln of something, that's going to be your u. So I'm going to say let u equal to ln of y. So du equal to, when you integrate, this is going to be 1 over y dy. Okay? Now dv equal to the other one, which is going to be y a half, negative a half d dy. You see what I'm saying? Whenever you have a ln, you let it equal to. Okay, now integrate. This is going to be integrate this side and this side is going to be equal to. You just add by 1. Okay, add by 1 is going to be y positive a half, which is square root of a half, and then divided by half, which is 2, is going to come there. That's all. So we got u and v. So now in substitute right there. When you substitute, this is going to give us the integral of that 4 to 9 1 square root of y ln of y dy equal to uv. uv is going to be 2 square root of y ln of y integral v equal to 2 square root of y. So say 2 square root of y, and then du 1 over y, and then dy. So we can put these together. Okay, so it's like y a half over y. This time we say y negative a half. Yeah, y negative a half. And then we're going to add 1 when you integrate. Okay, so this one here is like integral of y negative a half. So when you integrate means we add 1 to the top, add 1 and then also add 1, same thing at the bottom, which is going to be a half. So y a half and 2. So after we integrate this, it's going to give us y2, y a half, okay. 2 and a half and this 2 is going to give us 4 because there's a 2 here. It's going to be 4 square root of y, 4 square root of y. So all this half is going to give us 4 square root of y. 4 square root of y, and then we plus, no, we don't have a constant. We're going to have to put our limit here. Limit, lower limit, and upper limit. So since this is a definite integral, means you have to take upper limit, substitute all throughout, and then minus lower limit. So this is going to be 2 y. What is a y? Y equal to 9, and the ln of 9 also, then minus 4 square root of 9. Take this 9, substitute here, whenever there's a y, and then minus, take the lower limit, substitute throughout this expression. So we say minus, and then substitute with the lower limit, which is 2 square root of 4, and then this can give us ln of 4 minus 4, and then 4. Put this in the calculator, I can get 7 value. This is 2 times 3 equal to 6 ln of 9. Ln of 9 minus, if you want, you can simplify this one. You can say, okay, 93 squared, so it's going to be 3 square, bring it to the back, so 6 times 2 equal to 12, and then you minus 4, this is going to be 3, which is going to give us 12. This is going to give us 12, and then you minus, okay, this is 2 times 2 equal to 4, because this is 2. 4, 4, and then 2, this is going to be 2 square, 8. It's going to give us 8 ln of 2, and then minus 4 times 2, because this is 2 is going to be equal to 8, okay. So you can put this together, and then that's all. So you can say, okay, 12. I think you can finish here, and then it's fine. Put a calculator, simplify, and then you can get it, because it's going to be negative 12 plus 80, negative 4. So for the numbers going to be negative 4, and then you take this one together, 12 ln of 3 minus 8 ln of 2. That's all. You see what I'm saying? So we done this question, now we go to the next one. So question number 70. Okay, question 70. Question 70 now. Okay, let's go to question 70 now. As far as you see, this is also by parts because I have a ln and there's nothing here. So I'm going to say this is going to be u and this is going to be dot L dv. So it's an integral of u dv equal to uv minus v du. Okay, let u equal to ln of 2x plus 1. Okay, differentiate du equal to, okay, this one we know. We have to differentiate the function, which is going to give it to over exactly what I have to give to you. Because this is a ln of a function, okay? And then dx. It's like somebody give ln of a function. If you differentiate, this is going to give you function derivative and then over function given here, which is this one here. So derivative whatever you have, and then, so just like here, derivative this, you get 2 right over exactly. Okay, now, dv equal to dx. So when you integrate is going to be equal to x. Okay, now, so we got everything. So substitute in the equation. So now we say integral of u dv, which is this one, integral of ln of 2x plus 1 dx equal to uv. What is that u? U equal to this one times v. So I'd rather start with the x. Ln always come after everything. That's a good way. Don't write times x because it's going to look like they are together, which is not right. So better write like this, something in the ln minus integral v. V equal to x times du. Our du equal to this one, which is 2 over 2x plus 1, and then dx. These two can go to the back, which is going to be 2. And then, okay. This one here, how are we going to do it? Okay, so we got x, okay. V dv equal to 2 to take to the back, so now we have this one. How are we going to conquer this one? Okay. Okay, just a second, how are we going to go for this one? Which method I can use for this one? Just a second. Is this a question? Okay, but okay, cool. Let's go here for so long. Just an example. We don't want it to a lot of time. So ln 2x plus 1 and then minus these. How are you going to solve this? Okay. Okay. X plus 1. How am I going to solve that? It's crazy. Okay. 2x. Okay. So Maybe somebody can remember. Okay, so you get 2 and then integral of that. How I'm going to do? Because I cannot do substitution. If I substitute this was go, maybe I can just do by, okay, let's say x. Okay, divide by 2x plus 1. X divided by x, you get x divided by 2x. You get a half. Yeah, you get a half. A half times 2x, you get equal to? Okay, half times 2x equal to x. So give us x, yes. And then you say a half times 1 equal to a half. If we subtract this, it's going to give us nothing. Negative what? Negative a half. So if I take this divided by this, it's going to give me a half. I want to do like a partial fraction. Plus, left to the negative a half over everything, which is what is 2x plus 1. Yeah, so I can do something like this. So I can separate these two. Oh yes, I'll do like that. It's personal, right? But somebody could have done the method. So I'll say 2, and then this integral is going to be integral of a half dx, and then minus. But I think if somebody watch this video, you can tell me what is your opinion on this. Okay, it's simple, but I don't know how. Okay, now negative half is going to go back. So negative half is going to go back. Okay. Oh, plus and minus minus. So I don't need negative again because it's supposed to be. Okay, a half plus and minus, and then this a half, and there's an integral of 1. Because like if you take this one divide by that, instead of writing that, we get a half, which is a half, plus negative a half, which is the remainder over everything. So now replace all of these with these two. That's say a half here, and then dx, and then I go my negative a half, and then 1 over 2x, 1 over 2x plus 1. Very interesting question, this one. Okay, plus 1. So now we don't need this. Okay, I don't need that. Okay, I don't need that one. And I'm going to say, okay, plus 1 dx. Okay, now the question is finished because this is going to be x ln 2x plus 1, and then minus 2. Okay, okay, let's do 2 in the, okay, 2 and 2, 1. 2 and 2, 1. Negative plus. So now I'm not gonna have a 2 anymore. And when you integrate these dx, you get x, and then no bracket anymore. Negative is gonna be plus. This is gonna be just a 1. Okay, this is gonna be ln. It's gonna be 1 over 2 ln of 2x plus 1. Yes, I'm sure, boy. Okay. Yeah, cool. So this is what we got. So if we integrate this, that's what we have. Okay, so this is your final answer. Okay, that's our final answer, and this is the long here. Let me write clear. So that's my final answer. I'm gonna have to write this question aside, just that part, just in case later I want to recheck if I did right or wrong, especially that part of integral of x 2x plus 1 dx. Okay, so I say I have. I want to check, guys. So later, if I go and then I know. Okay, partial fraction. Okay, cool. Now let's continue. So now that question is done. Now we go to question number 71. Question number 71. Man, I'm not supposed to raise the formula because this one also seems to be by parts. Okay, so you see, I just got confused a little bit. It started confused like a lame student. Come on now. Okay, no more confusion. Let's get it done. Question number 71. 71, yeah. 71. This one seems also by parts, so integral of x squared and the sine pi x dx. By parts, if you have something with a sine or something with a ln, something with a sine, like angle or whatever with a trig. You see, ln with something with a sine, like integral. That's how you do by part. If there's a trig with, let's say something with a trig. Or something with a ln, and then you know that's a by parts. Or inverse of trig. So now let's come for this. Oh, this by part too, because the structure say here, right? X squared and sine of something. So the formula we know. Okay. So I'll just start with u. What is a u? U equal to x squared, and then dv equal to sine pi x. Okay. Now differentiate this du equal to 2x, and then v. When you integrate here, you get v, and then when you integrate this, gonna be 1, and then what you do, you differentiate this pi x. Which is going to give you pi. You see? It's going to give you pi. And then you see, when you integrate sine, you get negative cos. So it's going to be negative cos pi x. So we have everything. So now we're going to say, substitute in the formula. This one equal to uv. U times v means take this one multiplied by that. So we have a negative x squared, and the right back cos pi x over pi minus v. What is my v? My v, this one right here. this is a constant. So I'm going to say v equal to negative. It's going to come out, it's going to be positive. So you got cos pi x. This pi is underneath, but pi is constant, so it's going to go to the back. So 1 over pi, and then multiply by du, 2x. So all this multiplied by 2x. So I can write 2x here. Before, I prefer to write 2x, and then that one follow. Okay, 2x. So rather write 2x, and then I can write cos pi x. Okay, cool. This one went back, and this negative became positive. So we have this dx. But even this one also is the constant. Hold on, face. Hold on. No. 2x. So du is 2x. Okay, du. Okay, again. du. Because they say integral v du. V. What is a v? V. This one here. Negative cos. Take back. Negative in pi. Negative pi. Remember. So pi cos x. And then time du. du equal to 2x. 2x dx. 2x dx. 2x dx. But 2 can go to the back. But this one alone itself is another by part. So all of this, which is x squared sine of pi x dx, it gives us and then we got another by part. So let's do this by parts separately. So we say tag. Okay, so we got integral x. So let me do this. This could be our style question. And then I'll come back here. Okay, so I can say, okay, let me do straight away. U, what is our u? U equal to x, and dv equal to cos pi x dx. Okay, differentiate du equal to dx, and then when you integrate the v, when you integrate this, you get 1 over pi, and then this is going to give us sine pi x. Okay, so now let's put together, put in the formula. Let me just put here quickly. Okay, so I'm gonna say plug in the formula. Okay, let's come here. Okay, all this stuff here equal, or let me just say this integral of x cos pi x dx equal to uv x over pi sine x. Okay, so it's gonna be x over pi sine x sine pi x minus minus integral v. What is a v? V 1 over pi. So it's going to go to the back. So 1 over pi. Okay. Sine x. Okay, right. Pi x. Okay. Times du. What is it? Du equal dx. Dx. Okay. So here we can simplify because now this is going to give us equal to pi x over pi sine pi x, which is this one. We rewrote it. 1 over pi. Okay. Now let's integrate. There. So when you integrate that, it's going to give us, when you integrate pi, because you have to differentiate what we have there, which is going to give us pi, and then when you integrate sine, you get negative cos. Negative positive, so it's going to be cos pi x. Okay, so now we're going to take this and then substitute back here. You see what I'm saying? So if you substitute back, so this is going to become, okay, so it's going to become, let me use a red pen quickly, so it's going to become, okay, let's just take this 2 over pi and then put it in there. 2 over pi, put it in there, so it's going to be, I can just take and put it in here. Or if you, okay, let's put it in because at the end of the day, I'm the one who got to do for you. I have to do for you. Okay, now let's go. So it's going to be pi x negative. Let me write here. Okay, so this is equal to negative x squared, Let me see if I don't want to write under the whiteboard. Yeah, it's written right there. Okay, so this is going to be equal to negative x, okay, cos pi x over pi, and then minus. Now 2 times x is 2x. Pi times pi squared. Or I can take all those pi out. I think the best way to take the pi's out. So it means I'm going to take, we have a pi and pi, they can go out. So this is going to be pi squared. So I can just say 2 pi squared. You see what I'm saying? And then this stuff right here is there. So say x sine pi x, and then plus, remember I took pi and pi out, so it's going to be cos, only 1 pi at the bottom, right? So this 1 over pi, so cos pi x. So this is going to be our final answer. Okay, do you have a limit? You don't have a limit? No limit. So since there's no limit, so we can just plus c constant. And that's the end of this question. You understand what I'm saying? Now, let's go to the next question. which is question number, which one did I do now? Sine x. I think I did this. I believe so. Yeah. So now we go to question number 73. Question number 73 until morning time. See, the sun rises almost there. From midnight to almost there in Annabeth's morning time. It's morning. Okay. Okay. So that gives us here integral of sine inverse of x dx. So what I want to do, this also is by parts. If you have the integral sine inverse, then it's by part. Tan inverse by parts. So what you're going to have to do, I'm going to say, is easy. So I'm going to say, okay, so this is going to be u and this is going to be dv. So you see what I'm saying, this is going to be dv. So now the formula, say integral of u dv equal to uv integral v du. Okay, what is a u? Our u equal to, let u equal to sine inverse x. Du equal to, okay, so when you differentiate, let me write here. When you differentiate sine inverse or sine, or sometimes you can call it arc sine. Let's say f of x. Let's call it f of x. Even g of x, okay, it's fine. When you say sine inverse, arc sine is the same thing. So now when you differentiate this one, it will give you f prime. And then over, write exactly the sine, you know, it has to be 1 minus function square. So that's what you got. So we do the same thing. Let's differentiate. Means you have to differentiate the function here, which is going to give us 1. You write on top. If you want to show all your solution exam, you do this. You say x differentiate. This means differentiate, and you say square root for sine 1 minus. Take a function square. What is the function? This one here, which is x for this case. You see what I'm saying? Dx. Okay. When you differentiate x, or derivative of x is equal to 1. Equal to 1. So du equal to 1 minus x square dx. Okay. Now let's go for this one. dv. Okay. Okay, now so we're gonna have to integrate dx equal to dv. Integrate x equal to v. Now substitute the formula. So all this stuff equal this equal to this equal to uv. So we have uv. What is a u? Our u equal to sine inverse times v equal to x. So what I write x and then sine inverse. X sine inverse of x minus minus integral v. What is a v? Or v equal to x. And then du, what is that? Du equal to du. Oh, this one here, which is going to be like 1 times. So 1 times x is just x. Okay, over 1 minus x squared. Okay, dx. Okay, so this is substitution right here. This is a substitution. Okay, so let's do substitution. So I can just let let u equal to 1 minus x squared, differentiate this d, u equal to, and this is going to give us negative 2 xd dx. But this x dx equal to x dx, I can just divide by negative 2. So divide by negative 2 means negative 2 is going to come this side. So x dx means divide by negative 2. X dx equal to du over negative 2. So now I can replace this. I can just say, okay, so this is going to become, I'll just do it here. So this is going to become like minus integral, okay. X dx means this is going to be u over negative 2. So du, negative 2 underneath means it can go to the back. It's a 1 over negative 2. But negative and negative is going to be plus. Here you have x, okay, sine, negative x plus. Okay, half du, okay? Because the u over negative 2 is going to come here. But negative is going to make it positive. Now, 1 over. This is like square root of u. Because square root of u now. Because this is equal to u. Now, we can integrate this. Okay, this is like u negative a half. Negative, because it's going to be a half. Go to the top, negative a half. Du, and then plus 1 because integration is going to be u a half is square root, and then that same half is going to come at the bottom, which is going to make 2u. So 2u means like, okay, so I can just come and plug here. So if you say 2u, okay, so all this stuff is going to be 2 and the square root of u. But we know our u. What is the u? Our u equal to 1 minus x squared. So it's like 1 minus x squared. 2 and 2 is going to cancel. This and this cancels. So it's like 1. So it's like this is what we have. Okay, so when do you have a limit? No limit. There is no limit. But if they say, for example, 0 to 1, you substitute here 1. Let's say 0 to 1. Let's say, for example, say 0 to 1 means I'm going to say 0 to 1, and then upper limit minus lower limit. That means upper limit minus lower limit, meaning, okay, so then I'm going to say upper limit means 1 substitute everywhere, upper limit throughout. It's going to be 1 sine 1 plus, okay, 1 minus 1 square is 1 equal to 1 minus 1 equal to 0 square to 0 equal to 0. Okay, so this is upper limit, okay, minus lower limit. Lower limit takes 0, so 0 substitute 0, 0. 0 times anything equal to 0. Plus 1 minus 0, 1. Square to 1 equal to 1. So all this has to give us 1. Okay, sine inverse of 1, go to sine of inverse of 1, which changes there? Sine inverse of 1 equal to 90, or you can say power 2. So it's going to be power 2 minus 1. Final answer. So we done with the question. Now, okay, let's go to another new page, because I want to be done with it. Okay, so we done with this. Yeah, we done with everything. Question number 73. We go question number 74. Let me see if it's recording. Like I said, I'm checking all the time. I'm so sensitive with this. Yeah, it does. Okay. 74 question. You know, I'm not picking the question like, oh, let me do this question because they're easy and then come. I'll just give you the stuff which is, you know, you make a lot of sense and you can see like, oh, you getting some knowledge, you know? Like they always say, you don't pick the fights. I'm not picking the fight, it is a fight, no? It's one tech, we do one intake, all this stuff. I'll do all this just for you, okay? Okay? Yeah, I think this is fine. You just go, okay, cool. Take it in right now. Okay, cool. Now let me get another page here. Okay. Okay, 74 now. So we go to question number 74. Okay. Let me write the question again here. Okay. So question number 74. They say integral of cos x, and then we got sine 5x dx. Okay. 75. 75 again. Now 75. They say integral sine 6x cos 3x dx. 76, we got integral sine 2x cos 2x cos square x dx. Okay, now 77, let me do here 77 integral sec 9x times 5x dx. 78 integral of sec dx. Okay, and then 79 integral of sine 2x over 2 plus cos x dx. 80 okay, question repeat. Okay, cool. This one is done. Copy the question, right? Okay, now this is okay tan. Okay, this is arc integral of arc tan. Okay, arc tan 4x dx. Okay, 81. Okay, integral tan inverse of 6x dx. 82. Okay, integral of cos inverse, or you can say cos, the same thing, cos inverse. Okay, cos inverse of let's say x squared dx. Okay, 83 integral of arc cot ex dx. Let's say ex 2x, ex power 2x. Yeah, ex power 2x. Okay, 84. Okay, 84. Arcsine. 3x. 3x, arcsine. Okay, yeah, arcsine 3x. 3x, okay. 85. 85. Okay, integral of t sec square 2t. Okay, 86. Actually, right here, our space is coming enough. Oh, let me write here. 86. Oh my God, the space is coming enough for real. My concern, the space might be enough, might not be enough. Okay, 86. Let me just write only 186. Okay, 86 tan x cubed integral of tan x cubed dx. Okay, 87. 87. So this question 87, say okay, integral sec square ex dx. Okay, now 88. Okay. Let me just do this one first because the space is the problem is the space. Okay, now let's go. So this question here is easy. So if I finish this means I'm in question number 88, 87, 87. So if I finish this, let me write here so I will remember 87. Sometimes I don't go in order. Okay, so if I finish all this question means I'm in question number 87. Now let's go. So I can start with whichever. Let me start with 87 so I can have some enough here. Okay, enough question. Okay, integral of sec square ex dx. So just remember, if you integrate sec square of a function dx, this give us tan. Give us one of a derivative of a function. Means you must derivate this function, then right under, and then you get tan of exactly the same function. No limit, so you plus constant. So same here. Means someone said this is 1 over derivate this function. You derivate ex, okay, let's say 2x for example. If you derivate this, it's going to give you 2e to x, and then when you integrate the sec you get tan. So I don't need this one because 1 times anything is just 1. Tan of e to x plus constant. So we're done with this question. Let's go to the previous one. 86. Question 86. So tan x cubed. Okay, so if you integrate tan of a function, let's say g of x dx. Okay, this is 1 over derivate this function, and then you get x prime, g of x prime, and then when you derivate tan, what do you get? Sec square. Yeah, when you derivate this, it's going to give you sec square of a function plus c. Okay, plus c. So now this will become 1 over derivative function. What is it? Tan. This one. Derivative x cubed, you get 3x squared. 3x squared, and then you're going to get sec of your function. What is the function? Our function is x cubed plus constant. So we're done with these two, and then we move. So I'll just make a space here. I did that for a reason, so I can have some space here. Okay. See if it record. Yes, it does record. Okay. Now let's go. Okay, now I'm gonna do this all question in 7 minutes. I'll be done with them, all of them. Quick, I'll be speed now because I never show you my speed before. Okay, cool. Now, whichever one you want me to start with. Okay, let me go with the flow now. Okay, 77. Question number 77. No, let me start with this one. Okay, 74. It doesn't matter. When I finish this, and I'm in question number 87. Okay. Now, integrate this. So what I'm gonna do? Nobody tell me, but I have to use a common sense. I'm gonna have to separate this because I know. Okay. This is okay. I see. So nobody teach you, but you gotta use a common sense. So I know I'm gonna put this cos x dx, and then take this sine 5x before. You know why? Because I know if I let u equal to sine x, and if I differentiate, this is gonna give me when you differentiate sine, you get cos x dx, which is this. It's going to become du. So this time we say integral, we know sine equal to u now. So it's going to be u power 5, and then all this equal to du, because du equal to cos x dx. So this is going to be du. So now when you integrate, you add 1, and then the same thing right at the bottom, which is going to be 6. So it's going to say u power 6 over 6 plus constant, because there's no limit. So what is our u? Our u integral sine. So say sine power 6, 6x over 6, and then plus our constant. We're done. We go to the next question. So that question is done. We go to the next question. You see what I'm saying? We go to the next one. Next question. So the next question, not all the time you must do the same trick. Every time you have to look at it. The more question you do in regular. So when you do on a regular, means you get used to the question, because they always flip around the question. Okay. Now integral of that. So nobody tell you now. I'm thinking, okay, how am I gonna split that one? I can do the same trick. I'm gonna use sine 6x. This one I'm gonna take 1 cos from 3, 1 cos dx, and then I'm gonna let you 2 cos, means cos square x. But from trig identity, I know cos square x equal to 1 minus sine square x, and then here we have a sine power 6 what? X, and then we got our integral in the dx. Oh, cos x dx. So if I let again, like how I did u equal to sine x, so du equal to cos x dx. So this will become du and everything u here. So this will become integral u power 6, and this will be 1 minus u square, and then this will be du now. Put it in, so this will be equal to, okay, u times 6 is u6. u6, if you integrate, means you add 1, it's going to be u7 over 7, and then there's a minus. This going to be u6 times u6 and u, because you multiply this same base, you add, it's going to be 80. When you integrate plus 1, it's going to be u power 9 over 9 with plus constant, because there's no limit. U will not part of equal to sine. So sine 7x over 7, and the minus sine 8x 10, 9x over 9 plus constant. We're done with that question. Now we go to the question number 76. You understand what I'm saying? So now we go to question number what? Number 76. Okay, like I said, now I'm going to be going speed. Okay, 76 is the same again. Okay, 76. So now, oh, this is another one now. So if they give you both even, you see here is like even, odd, even, odd, even. So you do that tricky. But now you see the both even power. Sine, integral of sine, and then I give you cos x dx. So how I'm gonna go for this? So this you have to know double angle of sine and cos. So now I know for effects, if somebody give me, so there's another pen here. If somebody give me, let's say cos, double of my angle, this let me say, if I want everything else to be cos, this let me say 2 cos x minus 1. Okay, 2 cos square x. So if I have to replace this cos square x, means let me make this subject so I can make it, so I want to make this subject so I can replace. So cos square x, take this one here, it's going to become cos 2x plus 1, and then over 2 equal to cos square x, make subjects. So I can replace this with that. Same with sine. This formula, which is cos double angle, sometimes you can write it as 1 minus 2 sine square x. So I want to replace this sine square x. So you did not replace for the previous one because these are odd number, like this is odd number, this is odd number, you cannot. But for square, yes, you can. So what I want to do, and let me add a question here. This question is very, very important. Let me say integral of sine 4x dx. Let's say this is 3. Let me say something like this, because this one also will come, this power 4. Okay, cool. I'm gonna come in do this. Let me see if I see the space is enough there. Yeah. Okay, cool. I can write here under a little bit. So say integral. So this is going to be 788 now. Question 88. Question 88. Very important question. So say integral sine 4 3x dx. Let's say. Okay, cool. So now I'm going to do, let me make a subject was sine of sine x. If I make subject, means this is going to come over. It's going to become sine square x 2, and this is going to be 1 minus cos double angle. Divided by 2 means divided by 2. So this is not there. So let's replace both. So meaning this is going to become integral sine square is going to be 1 minus cos double angle over 2, and then for the other one, which is cos, what is that cos? So cos equal to, cos square equal to cos double angle plus 1 over 2 dx. 2 times 2 equal to 4. So this one's going to go to the back. 1 over 4. So what I'm going to do now, man, it's crazy. Okay. Let's multiply that out. So it's going to be 1 over 4 integral. Okay, 1 times 1. Oh man, let's say, no, this is a difference of 2 square. If difference 2 square means it's going to be, oh no, let's say 1 minus cos square, I can say 1 plus 2x. Okay, 1 plus 2x. Like other one, 1 plus what? Cos double angle. So this let me say 1 minus cos square of my double angle. I can say that. Acceptable dx. Then I can separate. You see what I'm saying? I can say 1 over 4 is just 1 over 4, and then I can say integral of dx, because this for 1 is like 1 dx, minus integral of cos square, double angle, and then dx. But this also have to do the same approach I did it, because cos square, whenever there's a square, I can do the same thing. So cos square, what's cos square? Cos square equal to that. So now look how I'm gonna place it. So see, look, when you integrate 1 dx, or 1 dx is like dx, integral dx equal to x minus. So look, this is cos square. If it's cos 2x square, means I must put 2 here. If this it was x, here it was 2x, means if this is 2, this can be 4x now. Does it make sense? Look, 2x. It was x, here it was x. It was 2x, excuse me, at first. X, 2x. So if this is 2x, this must be 4x. So then I'm going to say integral. Instead of that, it's going to be cos of 4x plus 1 over 2. See what I'm saying? dx. Okay, 2 can go back, so this is going to come here, 1 over 2. And then what we're going to do? Let's hammer that one. So now we say, after that, it's going to be 1 over 4x, and then this is going to be plus 1 over 18. Now, so now we can separate this integral of cos. I can do shortcut, but I just do this for you. Plus integral of 1 dx, which is just like dx, okay? So this is going to give us 1 over 4x plus, okay, when you integrate cos of 4x means integrate that, which is, and then we're going to write 1 over, we still have 1 over 8 here. It's going to be 1 over, differentiate this is going to give us 4, and then when you integrate cos, you get sine, but at the same angle, and then we plus, integrate that one, you get x, plus constant, or you can multiply that out, and then we finish. So this is going to be 1 over 4, x plus 1 over 32, sine of 4x plus 1 over 8, x plus c, if you want to expand. So now we're done. Let's go to question 88. So like I said, when you finish this, is going to be question number 88. So, okay, remember, no problem. Is this one here. I'm not supposed to raise that one because I'm going to use for this same question here. I mean the blue, whatever double angle. Okay, now let's do question number 88 here. Question 88 is easy. So sine, so I'm saying this, let me say sine is power 4, right? So I'm going to say power 2, 3x, and then here I'm going to put square dx. Let's put 6 for example. Let's put 6. So if it's 6, means here I'm going to put 2, I'm going to put 2, and then here I'm going to put 3 for a reason, because I know this one, I can get it. You see what I'm saying? So now I go to my double angle. Double angle says I want double angle cos. Double angle, it comes from cos double angle. So if I want to replace sine, it means it's going to be 1 minus 2 sine double my angle. You see what I'm saying? Double my angle. See? But now it's not x, is 3x. You see, square, 3x, here x. So I'm going to put here 3. If this 3, this is going to be twice of this, which is going to be 6. So now I want to make subjects that, so I can come and replace. So this is going to become over, it's going to be 2 sine square 3x equal to 1 minus cos 6x divided by 2 divided by 2. So this is going to replace. So now integral, instead of writing there, I'm going to say 1 minus cos, this question is big, man. And then power 3 dx. You see what I'm saying? So now let's make 2, because 3 is going to be so big. You know, it's going to be so big. Let's make 2. So it's like power 4. Let's take 2 power 4. So this is just like how we did before. So it's going to be integral. This is going to be 4 because 2 squared 4. So it's 1 over 4. And then here's going to be 1 minus cos 6x and then dx. Square. This is square. So if you square that, it's going to give us, okay, let me square straight away so we can see the space, okay? Okay, so now this is going to be 1 and then this is going to be negative 2 cos 6x and then we plus cos 6x, but here there's a square because you're going to have to multiply the same thing. Okay, dx. So what we're going to do now, we can separate all of them. So say 1 over 4, okay, integral, and this is integral of the first one, 1 dx, which is going to give us x, minus 2 integral of cos 6x dx. Now we go for the last one, plus, and this one can get it too, because I can just do straight away, because when you integrate this, it's going to give us 6 at the bottom. And then when you integrate cos, you get sine 6x. So it's going to be just sine 6x. Sine 6x. 2 over 1, 2 over this is 1 over 3. Okay, now plus. So we're going to have to do the same thing here. But this is cos now. So we can now use this formula. It's cos square. So for cos square, almost the same formula, but now it's not going to be like that. So for cos, it must be 2 cos square x minus 1. You know what I'm saying? And this is 2 for cos. Double angle tricky. Everything in my head mean I'm not looking at the paper, okay? So now this one here, we know we can just replace it. Cos square 6x. Cos square, so this not x is 6x. If this it was x, it was 2x. If 6x, this must be 12x. So I want to make subject to cos square 6x at a place. So this is going to be cos. You get this from trig identity plus 1 over 2 equal to cos square 6x. So I'm going to replace cos square 6x. Means it must be integral. Instead of say because integral the last one. So instead of say integral that, I'll replace this with it, which is going to be 1 of 2 is going to go at the back, 1 of 2, and then we'll write cos 12x and then plus 1 dx. And then this is going to give us 1 over 4x minus 1 over 12, 6x. Now, this is going to be 1 over 8. Now, we can separate this. Now, integral of this one, say cos, I can do straight. Let me just do straight. Okay. Integral of cos 12x will be 1 over 12 and then sine 12x. Okay. Now, integral of this will be just x. Just x. So plus x. So this is 1 over 4x minus 1 over 12 sine 6x, and this is going to be 1 over 32. 1 over 8. 1 over 8, x over 8 plus constant c. So that's how you do. So we're done with the question 8. Now let's move down. I'm going to this one right there. Okay. Okay. I want to know this question. This is a very, very important question for later. Okay, sine for 3x, I say. Okay, dx. Okay, cool. Now let's go to the next question. Okay. Okay, cool. Now, let's go. So now, we go to question number 77. Question number 77. So now, they give us, okay, so easy. Integral. What I'm going to do, I'm going to play the same tricky. Let me show you something. Okay, let's recopy the question. Let's say sec power 9x, and then you got tan power 5x dx. So what we're going to do here, look, this is very, very important. This is very, very important, family. Okay, this is very important. Okay, now, this you have to know this. When somebody give you sine, okay, let's say sine square theta or x, because we use x for now. Okay, x plus cos square x equal to 1. If I want to get sec and tan, okay, I want to get the relationship between sec and tan. So what I'm going to do then, look, if I want to get sec, means I have to divide by cos. So divide by cos square x throughout, divide by cos square throughout, divide by cos square throughout. When you take cos and cos, you get 1 plus 1 divided by cos, you get it's equal to 1 divided by cos, you get sec. Okay, now here, this is going to give us 1 plus sine divided equal to tan square. Also, this is the identity of sec. So I'm going to play with this to solve this question. Okay, I can't even write a side here. So, okay, so I know tan. Let me write here. Let me use a blue pen. So I'm going to say my tan square x plus 1 equal to sec square x, because I'm going to use it for this question. Okay, and then I'm going to raise this one here, because I know how to get. So you don't have to memorize as long as you know sine square plus cos square, and then you know how to get that. Okay, now let's go. So with this question here, look what I'm going to do. Oh, nobody jump, I'm going to have to think, oh, well, let me do this. Because if I can take sine and sec here, and they'll be done. Okay, look, I'm going to try the fix on this, okay? If I differentiate tan, I get sec tan. So I'm going to say in when, okay, let me do straight away, because most of you guys, you understand what is happening here. So let me do straight away. So it's okay, this let me say, take one sec, take one tan here. So it's going to be tan x and then sec x dx. And then here I'm going to be left with how many sec? 8 sec. And here I'm going to be left with how many tan? 4 tan x. And this one I take 1 and 1 here and then integral. So what I'm going to do, I'm going to have to say, hold on. I'm going to have to replace this with tan. Because sec equal to tan plus 1. So I'm going to say this is equal to integral. Instead of say sec, I'm going to say, okay, sec equal to tan plus, okay. Instead of say sec, I say tan plus 1, okay. But sec square. So means I can say this, let me say square, and this is going to be power 4. Still power 8. Because I know sec square equal to tan plus 1. So say tan x, tan square x plus 1, and then power 4. And then here tan 4x, and then this is going to be, okay. And this half here, tan x sec x dx. Okay, now let's let, if I let tan equal to u, okay, so I'm going to let u equal to tan x. Differentiate, if I differentiate tan, I get, no, I made a mistake. I apologize, I made a mistake because now, if I differentiate tan, I get sec square, so wrong substitution. I was supposed to do the other way around. Okay, my apologize. Or if I take sec, and differentiate, and then I get sec tan. Hold on. If I take tan and differentiate, I get sec square x dx, and it's not here. You know what I'm saying? So let me do this. I did other one wrong just a little bit. So go back and see. Okay, cool. Let's look careful. So for that case now, let me say, okay, sorry for that. Let me say, crazy. I know the question, but just okay. So now, let me say, you're gonna be laughing at me like, oh, come on, that question right there. Okay, it's okay, come on, I see it. He's always like, okay, cool. So now, let me say, just a second. Time is running. Okay. Let me say, for the time here, okay, just a second. If I let, okay. If I, okay, let's put everything here in sec for that case. Okay, so this is gonna be sec 9x, and this is gonna be, okay. Instead of say tan, we're gonna say sec square minus 1. It's gonna be sec square x minus 1. Okay, but okay, it's like saying this. Okay, let's put, okay, let me go slow. Let's take one tan aside here. Okay, let's put everything in sec, and then, okay, if I say, I appreciate your patience, right? If I say sec, and then if I take, okay, if I differentiate tan, it gets sec square x dx. Okay, let's make this 7. Excuse me. Make this 7. Take 2 sec here, sec square x dx, and then and this tan here. Okay, and the tan. Come on, man. Okay, if I take second tan, okay. Easy question. Come on, guys. I appreciate your patience. Just a second, right? I get it done. It come from here. Okay, come from here, man. Okay. It's very easy question. I don't know how I lose this. How I lose sight of it. Okay. Now, if I say sec square, okay. If I say. Let me do question number 7, 8, and then I'll come back. Okay, just a second. Integrate sec. When you integrate sec, integrate sec of a function dx. When you integrate sec of a function of dx, what I'm thinking, right? When you integrate sec of a function, you get sec of a function. Sec of a function. You get long? And you differentiate sec of a function. This question, it pissed me off. I'm going back and I'm coming. Okay, you see that it can't distract me even from solving another question, but I'll get it right. Okay, now integrate sec of a function. Integrate sec of a function, you get sec. No. If you no, you don't get straight away. If you integrate sec, okay, then I'll come back for that one. Oh, okay. No, sec is easy. I'll show you now how to solve sec. Let me solve this one. Sec I got it. Or let me show you sec. You see it's a start. Okay, integrate sec. So what I want to do here, look, I want to do something. I want to say sec x plus tan x, and I'll say over sec x plus tan x for a reason, dx. Because I know if I differentiate this, it's going to give me the one on top. So let's say m equal to sec x plus tan x. Okay, when you differentiate, it's going to give, when you differentiate sec, when you differentiate, you get sec tan. You get sec what? Sec x tan x. So when you differentiate sec, you get sec tan. Yes, but when you differentiate tan, you get tan. You get sec square. When you differentiate tan, you get sec square. You differentiate tan, you get sec square. Okay, sec what? When you differentiate tan, you get sec square x dx. So now we're going to have to replace this. You know why? Because look, if you expand it, look, it's going to be sec square, integral of sec square, and there's going to be plus sec tan. Sec x tan x dx, and then over sec x tan x. Sec x plus tan x. So this is m. So it's like, say, integral of m. And then this half here, equal to dm, which is equal to ln of m. So ln, we know what m. What is our m? M equal to sec x tan x. Sec x plus tan x plus constant. So when you differentiate sec, you get what? Sec tan. You get sec tan, tan equals sec squared. Okay, now let's go to the question. Okay, now let's go to that previous question. Sorry, guys. Let me go to the previous question. I want to get done with that one. Is this a question? I don't know why I'm losing sight of it. Okay. I hate this. I hate, cause me, I'm not there. Okay, now let's go to that question now. Say, okay. Okay. If I leave here sec and then tan. Look, now let me do it like this. So like before now. Let's put everything tan. Okay. So this is going to be, let me take 1 sec and 1 tan. Okay. So tan, okay. Tan x from here and then 1 sec from here. So this is going to be sec power 8 x and this is going to be tan power 4. Tan x power 4. Now dx. Now I'm thinking now, I got to put this in tan. No, it's not let. Meaning, if sec, okay, we know sec square equal to that. Meaning this is going to be sec, okay, let me write here, it's going to be sec power 4, sec square x, power 4, which is going to be power 8. So this is going to become, I'll say sec, okay, sec square x power 4. Okay, yep, I got it. So, but I know this one. Okay, let me write slowly. Okay, sec square x power 4, and this is going to be tan 4x, and this is going to be tan x, sec x. See, it's coming now, dx. Okay, so now, but I'm going to have to replace because everything must be tan except this one. So sec square x, tan square plus 1. So there's going to be integral tan square x plus 1, and here we have a tan, but here it's going to be power 4. You see, power 4. That's square plus power 4. Because this is only sec square, but we got power 4. And then tan power 4x. But this, okay, and also write tan x sec x dx. So if I let u equal to tan x and the differentiate du is going to be sec, differentiate tan and get sec squared. So I need to let something with sec, so when I differentiate, so this must be sec all of this. Okay, I got it. Okay, easy. So what I'm going to do, look, I'm going to have to let sec, and then replace all this with a sec. So this is equal to sec x. So when the differentiation is going to be sec x tan x, which is going to give me what? That. But this I have to replace now with a sec. So for that case, this was fine as a sec. Look, I see. So this fine was as a sec, but this must be sec. I got it, man. It's easy. Don't play with me. Okay. Got it. Okay. So this sec is fine. This must be sec. So it's going to be square. So I'm going to put here 2 and here what? 2. You see what I'm saying? But a tan x square, tan square x, what is tan square x equal to sec square minus 1? It's going to be sec square minus 1. Now look, if we let u equal to sec, and then differentiate, okay, see, it's done already. I can do it again if you want, but okay, let me just finish up and then I'll do it again. So you see it's going to be integral, what is the sec? Sec equal to u square times what 4, and this is going to be u minus 1, and then this is du because tan sec equal to du. See, I got it. And they can multiply that out. Okay, let me do it for you, and they can understand. So everything here must be tan sec. Okay, cool, I got it. Let me do it again for you. I apologize, guys, they were handling this situation. Okay, now, so we're going to say integral. So I'm going to turn all this stuff to sec because I figure. So sometimes you play around, like left, right. So I'm going to say this is going to be sec. I'm going to leave only one sec. It must come here, sec. 8x. So, and then this is going to be tan what? Square x power 2, which is power 4. And then one sec, I'll take it here. And then one tan, I'll take it there also. You see what I'm saying? So turn this to sec. So we know sec, you know. So say sec, tan square, what is tan square? Tan square equal to sec square minus 1. It's going to be sec minus 1. And this is going to be sec square power x power x. And then this is going to be sec x tan x. Tan x. So I like now tan, okay, let u equal to sec. Because if you differentiate this, it's going to give us what? Sec tan. Sec x tan x dx. So this equal to du. So it's an integral, and this equal to u. So it's going to be u square, and this going to be u square. This going to be u square. Oh, power 4. Yes, power 4. So u square power 4 means this is. Yep, u square power 4 equal to power 8 means. Because it's going to be u square times 4, 2 times 4 equal to 80, u, and then it's going to be u square minus 1 and then power square. And all of this equal to du. So now the question is finished because it's a power of integral. So integral, now I can do straight away. No, you cannot do here first. Okay, this is going to be u. Okay, now let's expand. Okay, this is going to be u power 4 and then minus 2u power 2 plus 1 and then du. Now, this and this is going to be 12. Power 12, but since you integrate, okay, let's just show some people who know. So it's going to be u power multiply 12 du, and then minus 2u. Okay, this is 16. No. This and this is going to be 32. Woo. 32. Oh yeah, 32. 32. No, you add them. Come on, you don't multiply them. This is 12. Here, this is going to be 2. U. Okay, that's in there. 10 plus 1, 11. Du. And then we plus integral u power 8. Okay, du. So now let's integrate power of plus 1 is going to be u power 13 over 13 minus 2 u power plus 1 is going to be 12 over 12, and then plus u plus 1 is going to be 9 over 9 plus c. Now we know the value of u. What is the value of u? U equal to sec. So this is equal to sec what? X, but a power 13 over 13 minus. This is going to be 1 over 6. 1 over 6. And this is going to be sec 12x over 12. 12x over 6. This one is just 12x. So this 6. Okay, minus. Okay, this is going to be sec power 9x over 9. And then we plus. Plus or c. So we're done. That's how you do. I appreciate your patience. Okay, now we continue. question. If we finish all this, it's going to be 8, 8, right? Okay, cool. Let's go. Okay, let me go quicker, because we need to go quick with this, okay? Oh my god, okay? Okay, cool, let's go. Okay, now we go to question number, this one we're done already, now we go for this one. 7, 8, integral of sec, let's say 2x dx. So what we're going to do, okay, we're going to do the same game here, okay? So I'm going to introduce here and say integral, but this I think I did already. Yes, I did. You want me to do it again or not? Nah, let's just skip it. But if you want me to do it, I can do. Since it has a 2, okay, let's do if it has a 2. So I'm going to do the same thing. I'm going to introduce now. But it's the same thing. I just did it. I say I introduce. So I introduce sec x, okay. Introduce sec x plus tan x dx, and the same thing. Top and bottom. Sec x plus tan x. So it's like, look, it's like nothing because this and this is equal to 1. So it's like you need not change anything. So this, let me say, if you multiply that out, it's going to be integral sec square x plus sec tan x, tan x dx, and then over sec x plus tan x dx. So I can let this equal to m. So let u equal to sec x plus tan x du. Okay, this is going to be sec. If you integrate sec, you get sec tan. So sec x tan x, and then this is going to be tan. This is going to be sec squared. When you integrate tan, when you differentiate tan, you get sec squared. Okay, so this is this. We say du. So du, okay. And this is going to be equal to u, so over u. And that's going to give us ln of u equal to ln, we know u. U equals sec x plus tan x. Absolute plus constant. We're done. Now let's go to question number 79. Okay, go to question number 79 right now. Let me see if you're recording. Does it record? Is it recording? Oh yes, it records. Okay. Cool. Okay, 79. Okay, sine, integral sine 2x, and then we got 2 plus cos x dx. Okay, so what we're going to do now, okay, I'm going to break down. So this is the integral of 2 sine. So I take 2, this is double angle, 2 sine x cos x. So take 2 out here. Okay, and this is going to be 2 plus cos x dx. So I want to let u equal to the denominator. So let u equal to 2 plus cos x. So du 0, and this is going to give us negative sine x dx. So I can take negative 2 this side. You see what I'm saying? So then I can come and substitute some stuff. Sine x dx equal to negative du means sine, this sine x and cos x. I can flip it actually so you can see clear. Sine x and dx equal to negative du. Or this you see, you can say cos x sine x is acceptable. I can start writing as a cos x. So you can see. So sine x cos x equal to negative du. So I'm going to say that question become integral. We have a 2 is negative, right? Negative go out. So this sine x dx equal to negative du. Okay, negative, no, just negative went out, so du. You see what I'm saying? And then, so the problem here, what about the cos? Okay, I'll substitute now. So 2 plus cos x equal to u. It's equal to u, but what about this cos? You can get a cos equal to u minus 2. Look, cos equal to, if you come, it's going to be u minus 2. So it's going to be u minus 2. Okay, so this is easy because now you're going to say, there's a negative 2 here, right? It's negative 2, yeah. So say negative 2, I can say u integral of u divided by u, du, minus, there's a 2, you separate integral of du over u. See what I'm saying? It means integral of the face of the u and then 2 also with the u. Or you can write here. So just in case you don't know. 2 over u. And there's a minus. Take 2 out, 2 go back. So now we're going to say this is equal to 1. So equal to negative 2. Okay, now when you integrate integral of du because it's 1. It's like 1 times the u du integral equal to u minus. And this is going to be 2. Okay, this is ln of u. Okay, so now we're going to say this equal to negative u. What is a u? We know our u. U equal to 2 plus cos x. Okay, you know what I'm saying? I don't know I'm writing this. I can just put like this because it's bright. Minus plus 4. Isn't this 4? Isn't this just 2u plus 4 because this is 4 and then ln. So say ln and then absolute since there's a ln. We know u. What is a u? U equal 2 plus cos of x. Plus cos. Okay, now we go for the next one. The next one is going to be question number 10. Okay, question number 80. So when you finish this, you say in 88, okay? When you finish this question, means question 88. So when you finish this, is going to be question number 88. Okay, now let's go question number 80. So integral of tan, add tan of 4x. If somebody say add tan of 4x, is same as say integral of tan inverse of 4x, same thing. So don't just guess, how did it come or what happened? So now let's go, easy. So this is by parts. So I can say this is 1 and this is u and this is dv. So say let u equal to, because in by part we use this formula, u dv equal to uv minus integral v du. Okay, now u equal to tan inverse of 4x, differentiate du equal to, when you differentiate tan of a function, what you do, you differentiate whatever we have here. Let me write like this. Differentiate and then over 1 plus square of your function. Just like that. And then dx, because you differentiate with respect to dx. Du equal to, this is going to give us 4, and then it's going to be 1 plus 16x squared. Dx, okay? Now you come here, integrate there, because this is u, and then dv equal to dx. So now dv equal to dx, integrate, v equal to x. Okay, so we got all the, okay, so now equal, this one, integral u dv means the one they gave to you. Equal, so I can rewrite this here, but no time wasting, equal to uv, what is a u? U equal to this times v. So I can start with the x first and then go to tan inverse of 4x, the minus integral v, what is a v? V equal to x. And then multiply by du. What is a d? It's a du. 4 or whatever. So I can take my 4 out and I can write 1 plus 16x squared dx. So this is easy. So what I'm going to do, I can just do, if you want, I can do substitution slowly, but with me, I know the answer, but I can just show you how it's done. Okay, now with that, you can just let u equal to the denominator, because I know if I differentiate this, I get the one on top. U equal to 1 plus 16x squared. Square, and then if you differentiate this, will give you du equal to, this is going to be 32x dx. X dx means, so divided by 32 divided by 32, this side means 32 is going to come here. So x dx equal to du over 32. So this is going to become this one only here. So this one is going to become, okay, it's going to become integral, okay, x dx equal to du over 32. Du over 32. So I take 32 at the back. Now this is going to be 1 over u. So it's going to become 1 over 32 ln of u plus constant. But I want the value of u. What is the value of u? Equal to 1 plus 16x squared. See? 1 plus 16x squared plus constant. So with me, I was going to do straight away. You know what I was going to do? If I find out, if I differentiate this is x squared, right? Just x squared. It gave me x. And then I can just say straight away, okay? This and say, this and this is going to give us 32. So 1 over 32. Differentiate whatever you have here, 32. And they say ln of the denominator. That's the easy way of doing it. But I was just doing it to show you. You see what I'm saying? So now, we know how we got there. Even if I delete it, but I know exactly what the answer which is there. You see? I definitely know what the answer which is there. So it's very essential for you to know. Okay. So this is going to be minus 4. Okay, now all this stuff, since when I differentiate this, I get x squared, get x. That's what you have to know. So multiply, differentiate this is going to give 32 right at the bottom. And they say ln 1 plus 16x squared plus constant. Now, this is going to give us 1 over 8. 1 over 8, and then we write exactly x tan inverse of 4x. So when you integrate that, which integral of tan inverse of 4x, so you can say at tan, same thing, equal to all of this. Done. Now, there's no limit, that's all. Okay, now we go to question number, the same approach. Question number 81, 82, okay, let's go. I'll show you how it's done. Okay, question 88, like I said, we want to finish it. I'll finish 8 question if we finish this. Okay, cool, let's go. Let me see if it record. Yes, it does record, okay. I need 3 minutes quick and finish this question because like I'm doing, but I explain it loud and sometimes you guys, the thing is me, I can just do them quick, but it's you, man, you might not catch everything. So now let's go to question number 81. So it's almost the same approach. So I'm gonna know this equal to, this is gonna be the part. So integral of tan inverse dx. So I know this is gonna be by part, this is gonna be u and this is gonna be dv. Okay, so this u and this dv. Okay, now let u equal to tan inverse of, look, I'm going to do a shortcut. This is going to be du equal to, differential is going to give you 6, and then this is going to be 1 plus 6x squared dx. Now, integrate that one, it's going to be dv equal to dx. V equal to x. Now, let's substitute uv. What is the u? This and this. X tan inverse of 6x minus. Okay, now, v, x, okay, multiplied by 6. 6 is going to go to the back, and then right here, plus 6x squared dx. So, this is like 6x squared, it's like 6x squared. Now, x tan inverse of 6x minus 6. You see this one, I know if I differentiate 6x, I get x. Like 6x squared, look at 36x squared. If I differentiate this, I'm going to get x. Means if I differentiate this, it's going to give me that one. So it's going to be, so it's like 36x squared. When you differentiate, it's going to give us 72. And they say ln, write exactly what you have here, plus 36x squared, done. And then you plus your constant, we're done. Okay, now let's go for the next one. 82. Okay, 82. So this is cosh. So for cosh face, okay, now we do the same strategy. Okay, let me just make a space here. Okay, cool. Now we go to question number 82. 82. Okay, so question number 2, integral cosh dx. Cosh dx. So we say now cosh dx. Now let's go. So we do the same strategy, but if we put x is 9. Oh, x squared. Thank you. I don't like when it's x. X alone is easy. They should not give you only x. They must give you something. Okay. Now let's say differentiate that one. Let's put here 2. Okay, make it big a little. Let's say 3x squared. Let's say dx. So it's also by parts. If you have any trigonometric inverse here, means by part. So say, so I know this is going to be part integral of u dv equal to uv minus v du. Okay, now let u equal to this one, cosh inverse of 3x squared. Okay, let's differentiate du. Okay, equal to, differentiate what you have here. It's going to give us 6x right on top. But for cosh, it's like this. So for cosh, you always say, it's cosh, right? Okay, it's cosh. Okay, so for cosh, okay, let me show you here. When you differentiate, add cosh arc cosh of fx. So this is what you got. It's cosh, right? Arc cosh. This is what you got. Differentiate your function, and then say 1 minus your function square. No. Function square minus 1 square. Minus 1 or 1 square. So I'm going to do the same thing here. Differentiate and then write your function square. What is your function square? This one here. And this square, say 3x square and then square minus 1 dx. Cosh. Okay, cool. Let's go. So for that case now, and then when you integrate now, dx equal to dv. Dx equal to dv, integrate x equal to v. Okay, now integral of everything they give to us, which is this equal to this, equal u times v, u times v. You start to the x equal to x, and then equal to times cosh inverse of 3x squared minus integral v. Here we go. Oh, this is gonna be a long question. So what I'm going to do, I'm going to have to remove, it's going to be a very long question. Let's just put 3x. Sorry, let's just put 3x is fine. So it's going to be 3x. For a reason, I know why I tell you that. We're not going to finish it today. Okay, let's make 3x. Okay? Now, so it's going to be 3x. Yeah, let's make 3x. 3x make a lot of sense. Otherwise, it's going to be very, very long. Okay, integral of, okay, now let's go. V, what is that? V equal to x? And then du, what is that du? Du, okay, this is gonna be just if you differentiate 3x you get 3, so it's 3 now. It's no more like how it was. Okay, so it's gonna be 3. So this 3 I'll take it back and then write this one. So it's gonna be okay. Okay. That's gonna be 3x squared minus 1 dx. So this one here is a substitution. Substitution, right? So substitution I can let okay, this is 9x squared is like a 9. Let u, because here we find only here. Let u equal to 9x squared minus 1. This du equal to come here. It's gonna be 18x minus 18x dx. So x dx equal to du over 18. Okay, so this is gonna become integral only that this stuff here. Okay, 3 x dx equal to du over 18. So 1 over 18 go to the back, and this is gonna be du over square root of u. Because this is u. Because 9x squared equal to square root of u. So it's like u a half. Take to the top. U a half is going to be u negative a half. Okay, so now let's integrate this negative a half. Let's integrate. When you integrate, it means you add 1. It's going to be 1 over 18. Okay, negative half plus 1 equal to half positive, which is like square root of, and then divide by a half again. This is going to be 9. So this is the denominator is going to become 9. Okay, so but we know u, so this is going to be 1 over 9. We know the value of u. What is the u? U equal to 9x squared minus 1. 9x squared, so 9x squared minus 1. Okay. So all this stuff when you integrate these, we get 9x. Okay, so I can replace that one. So I'll replace this with okay, see, integral of 9 x squared minus 1 over 9. Okay, by 3, 1 by 3, 3. So now this is going to be x cosh minus, okay, 9x minus 1 over 3 plus constants over 3 plus 1. Now we go to the question number 83. Is also by parts as far as I see, but it's tricky also because you need to know all those formulas, okay, of integral inverse of trigonometry. Okay, now question 83. Integral of arc chord. Arc chord is like chord. It's like chord inverse of e 2x dx. So what we're going to do first, we need to, okay, this is by parts. This is going to be u and this is going to be dv. How do you know by parts? Because it's trig inverse. Easy. So what I'm going to do, do I really want to put it like that? I feel like it's going to be big. Okay, let's put small number here. Call this, let me see. Let's put 2x for a reason I know. The thing is, okay, you might get double bypass and then another bypass and then double bypass and then we might not finish now. See what I'm saying? But let me go. But I know you might get double. Cool. U equal to that one. So let u equal to cot inverse of e to x. Differentiate d, u equal to, when you differentiate this means you have to derivate whatever you have here. So you're going to give it e to x. And then, okay, for cot, okay, this is what you do for cot. When you derivate cot inverse of a function, it become derivative function, but here must be minus, and then it's going to be 1 plus f of x squared. This is for cot. So I'm going to say derivative, you got that, and they say 1 plus square of the function. So function, hey man, let's just put this just on the x. You see, that's what say, better put like small number. This is, let's say x. So this is going to be just ex, same thing. When you differentiate x, you get es. 1 plus, and this is going to become ex or square. It's like es 2x dx. Okay, this is going to be big. Okay, cool, let's go. And then, okay, now, and then we integrate this one. It's going to be v equal to x. We integrate dv equal to dx, v equal to, okay, now, u times v. It's going to be x times cot inverse of ex minus v x times, you see, that's what we're saying, times du. It's going to be e x, and then we got 1 plus e. Yeah, that's why I say, well, I shouldn't take a bigger number for a reason, because this is very big. This is not a work itself. See what I'm saying? So you can just take small number. The important things that I think you know, you just need to know this one. That's all. But when they give an exam or whatever, they don't want to give something bigger, like you gotta give again, you have to integrate again, integrate, no, want to give again. You know what I'm saying? So yeah, so the problem is here, and you don't want to waste a lot of time in exam. Now let's go to the next one. So you can take any number, let's say 2x, for example. Let's say, okay, integral of cot, let's say inverse of, say 2x dx. So I'm gonna say, okay, uv, okay, u equal to cot inverse of 2x du equal to, differentiation is going to give you 2 over 1, but it must be minus here. For cot, it must be minus. For tan, no minus. You plus square, this is going to give you 4x squared dx. Okay, when you integrate this, because dv must be equal to dx, so v equal to x. So put in the formula uv. So say u, all of this equal to uv. What is our u? U equal to that one times vx. X times cot negative 2x minus integral v. What is a v? V equal to x, and then negative 2 is going to come to the back, means it's going to be positive 2, and this is going to give us 1 plus 4x squared. You see, now it's easy, because this is a long, we know. And then this is going to write the same thing here, and then we plus 2. This, excuse me, we know if I differentiate this is going to give me x equal to x. So what I'm going to do, I'll just say 1 over, it's like 2 over 8x. Just 8, not 8x. It's 8, and that's a ln of this denominator, 1 plus 4x squared plus constant. You see, that's how they're going to give to you, not like the first one. Okay, now we go to question number 84. Question number 84, you say integral arc sine 3x dx. So just like the same, but for sine now, we say, okay, this is going to be our u and the dv equal to dx. Okay, let u equal to arc sine or sine inverse, in other you can say 3x. Okay, let's differentiate d, u equal to differentiate whatever here, you can give 3, but for sine this, what you do, say 1 minus square of a function, which is going to give us 9x squared. So this, and then this dx. That's how you do for sine. Differentiate right at the top and the 1 minus square of a function. You see what I'm saying? Now, dv equal dx. V equal to x. Plug it in the formula, because since by part uv. u times v. X times sine inverse of 3x minus integral vx times du. 3 is going to go to the back. 1 minus 9x squared dx. Okay, so this you can do substitution next. So here is okay. So we want to come here. So it's going to be the same thing, minus 3. So let's see, this is equal to u. So it's going to be u square root, and this is going to be du. Man, think what about it. Okay, this is so let. Okay, I'll just keep this pending, right? Let u equal to 1 minus 9x squared. Okay, du equal to negative 18 x squared. So divided by negative 18 divided by negative 18. So this is going to be du over negative 18. So means here is going to be negative 18. See what I'm saying? And then this is the u over negative 18, and then this is going to be square root of u. Yes. So now we're going to have, okay, when you integrate, it's going to be, okay, this is going to be negative 3 square root of u. You can do slowly, and this is going to be 18 over 1 over 2. This is going to give us 9. Okay, 1 over 3, negative 1 over 3 u. I'm going to make a mistake here. I think I'm doing right, but just in case of, let me make sure. Okay, so I'm going to say, take to the top, it's going to be u negative a half plus 1, same thing, and this is going to be half. It's going to be square root of u. I was right, square root of u, square root of u, and it's going to be 2 a half. Yeah, true. So a half, because we integrate. Okay, let's go. So this will take to the top, it's going to be u a half, and then over 18 times that is going to be equal to 9. 9 and 1 over 3. Okay, you can do slowly. Do you really want me to do like slow, like a baby or something? Because now you know what is happening. Okay, let's go slowly, so you understand. Okay, so this is going to be a half, and this is going to be, it's going to be a half 2, and this is going to be 18, and this is going to be 9, but we still have 3. This is going to be 1 over 3. 1 over 3, this minus or plus. Oh, so it's going to make it plus. Yes, it's going to make it plus. Because it will take to the top, it's going to be u nil. It's plus or minus? Come on now, always a little time I'm made. Where does 18 come from? Okay, let u equal to this. So it's going to be u, and this is going to be, okay, u equal to that one, 1 minus 9x squared. Yeah, it's negative, yeah, so it's going to make it plus, it's true. And this is going to be 1 over 3, and this is going to be square root of u. Yeah, it's true. Great, okay. So raise all this stuff here. Okay, but I will know the value of u. What is u? 1 minus 9x squared. 1 minus 9x squared. Plus constant, because we don't have no limit. So this is going to be x sine. Done. The plus 9x squared plus c. Now we go to the question number 85. So like I said, when you finish this, we 8 because we start with the 8 question number 8. Okay, let's go. Okay, cool. Now let's go. So integral of t sec square to t dt. So this is also a big part. So this is going to be dv, and this is going to be v u. Like I say, do a lot of in this form. If you have a t or x and then trig, and then this is going to be u and this is dv. Okay, let u equal to t, so du equal to dt. Okay, we integrate now because dv equal to sec square 2t dt. Now integrate, v equal to, when you integrate this, is going to get 1 over differentiate whatever you had there, you're going to give it 2. Now when you integrate sec square, you get tan. So you get tan what? Tan 2t. Now let's substitute in the formula. Formula we know is going to be all of this equal to uv integral v du. Okay, uv t times that. T times this is going to be over 2 tan 2t minus v. That's all v, a half whatever. So I'll put my half out, multiply by that. It's going to be, okay, it's going to be tan 2t, and then multiply du. What is it, du? dt. And then it's finished now. So t over 2 tan of 2t minus a half. Differentiate this is going to give you 2. 2 times equal to 4. Okay, now when you integrate tan, you get sec squared. So it's going to be sec square 2t. So 1 times anything, just 1. It's x squared t plus c. Okay. So you can say all this divided by 4. Okay, done. Now let's go to question number 8 and 9 now. Because we finished this. Question number 8 and 9. Okay, let's go. Okay, it's a 9. Okay, cool. Let's go question number, get a paper and get a question now. Okay, it's a 9. It's a 9. Here I go. 2, 3, 1, and there you go. X squared minus 1 dx. 90. Okay, here I go. X minus 1. X cubed, x squared plus 3x plus 2 dx. 91. Integral tan 3x dx. 92. Let's put here 92. Integral of x cubed plus 4 x squared plus 4 dx. 93. Integral of e x squared dx. 94. Integral of 1 over y plus 2 y plus 3. Yeah, dy. 95. Okay, let's continue here because of the space there. 95 cos 15x cos 4x dx. 96. Integral of sec 9x tan x dx. 97. Integral of tan x. 98. Integral of dp. Number 99. You must be laughing when you see that. Okay, and then Okay, there's another one, integral sec 4x 10 power x and then x dx. 100 integral sec square 5x dx. 101 integral cot 3x dx. 101 and 2 integral of tan 4x cubed dx. 102 integral 0 to 1 tan inverse of 7x dx. 102 102 integral arc sine 5x dx. Okay, it's 103 integral. Who's out the pen quick? Integral 1 over 49 plus 16 x square and this is square of dx. 104. I'll don't worry about it, the space can be enough. I know how I'm going to handle this. Integral okay 1 9 plus 25x dx. 105 integral 1 9 plus 6x squared dx. Okay, I think we stop there. Yeah, cool. 105. Let's go. So for now, let's stop this. Let me see if it record. Does it record? Yeah, it does record. Cool. Let's go. So first and foremost, let me start here. So if I finish all this stuff, means I'm done with the 105 question. Let me see here. Let me write here. Let me write here 105. It's gonna be done. Okay. Let me start with this one right here, and then I'll finish all of them. Okay. So this let me say, whenever you have a square root and then there's a plus here, this meaning you can solve in two ways. A, they can be hyperbolic, or it could be tricky. So in exam they might tell you, oh, anywhere solve is hyperbolic because it's root. It looks like a tan, but it is a plus. So I have to write as a square root. How am I going to do the log? 6 is like square root of 6 x square log. When you square root 6, square root of 6 times square is going to get you 6 alone. X squared. So I'll rewrite this. I'm going to say, let me rewrite, it's going to be square root of 6x. So this let me say, integral of 3 square plus square root of 6x, and then both of them square dx. And then I'll say, and then I'm going to say dx. Okay. Okay. So this let me say now. Let me start with a hyperbolic. For hyperbolic, this is excuse me. This is square. This is sinh. So say 1 over derivative function. When you derivate this, it's going to give you square root of 6 alone. Means square root of 6x. When you derivate this alone, it's going to give you square root of 6. And then say sinh inverse, or you can say arcsinh. Sinh, arcsinh is the same thing. Take your function which you have here, which is square root of 6, and x over a number which is here, which is 3. You plus constant. So this is for hyperbolic. But the same question I could write is trigonometry. So for trigonometry, only is in this format. There's a different format. There's sinh, cos, tan, sin, cos, all of them. Okay, now we go. So for trig, it's supposed to be like this. So 1 over derivative function. When you derivate, you get square root of 6. And then say ln. So I don't need this 1 times anything, just 1. Ln, and then I'm going to write my absolute. Take your function exactly right here. and then you put a plus, exactly what you have here, the one that gave to you, is better to take the one that gave to you. Put here. Even if you put this one, but rather take that one. Square root, this could be 9 plus 6x squared. And then I plus my constant because there's no limit. I must put my absolute because there's a limit, there's a ln here. So we put my absolute. So we're done with that question. So we go to the top. So even question 104, we go for the same approach because there's a root and there's a plus. Okay, there's a root and plus, so this is going to become, okay, let me do for hyperbolic first. It's going to be 1 over, this is going to be 5x squared. Because it's on 5x, so it's like 5x squared. So it's like over 5, and then I say arc, sinh, and they'll say, put my function is going to be 5x because 5x squared. So it's like 5x over 3, because when you square this 3, when you square this, it's going to be 5x, and this is like a 3 squared plus. Okay, and then plus your c because there's no limit. Or if I want to write as a trigonometric, I'm going to say 1 over derivative of 5x, which is going to give you 5, and then here write ln, so you can say all this is like 1 times ln absolute. Write your function, which is 5x, plus exactly 9 plus 25x squared, sometimes plus constant because there's no limit. Sometimes they write this 5 here under everything, and they can remove this. So it's optional. So we're done with that one. So even question 103, the same approach. Because there's a root and there's a plus. Okay, so how I'm going to do that one is easy. So, let me do this one, then come for this. Let me do this one. We gotta go with the flow. Now, no, 3, 2, 3 first. Okay, so I'm going to say this is 7 squared plus 4x squared, bracket squared. So I'll say 1 over, in trigonometric, 1 over 4, because I derivate this on 4, and then say ln, so I can write ln, and then write everything one line throughout. Absolute 4x, plus exactly what they gave to me, 4, 9, plus 16x squared, and then I got my root, absolute plus constant. For hyperbolic, because it's root and plus, if it's minus, another story. You don't do like this, okay? So now we're going to say, let's go. Okay, arc. So 1 over derivative function is going to give you 4. So arc, sinh, and then 4x over a. What is it? A equals 7. And then plus our c. So we're done with the question. Go number 102. So I go back to back. Okay, 102, there we go. So 102, we're going to say, okay, now let's go. You ready, guys? 102. So this is, okay, so I'm going to say this equal to u and this dv. So u equal to arc sinh. So it's like arc sinh, arc sine of 5x, and then dv equal to dx. So when you differentiate, this will give you du equal to differentiate whatever function you have is going to give you 5. But for sine, it's going to be 1 minus your function square, which is 5x squared equal to 25x squared. Okay, when you integrate dv, you get v. When you integrate dx, you get x. Now, u times v, we know form, bypass u times v, because the formula says u dv equal to uv minus v du. Okay, uv, what is the u? U equal to this one times v. So x times arc sine, or you can say sine inverse. Sine inverse of 5x minus v. What is v? V equal to x times du. This is du. 5. I'll take 5 at the back, and then I'll say over, because I must take 5 at the back. It's going to be, this is over 1 minus 5x squared. That's called dx. So what I'm going to do, or you can say 25, whatever you prefer. 5 or 25x squared. Okay, so I can just okay. So I think I understand here. Okay, let me go. 1. This is going to be 5, and then this is going to be square root of u, if I let it equal to u, and then over 1 over 2, and this equal to negative 50. Yeah, I believe so. But you can do slowly, okay? The plus code. But u we know. What is the value of u? U equal to 1 minus, you can do slowly. Tricky substitution. If you follow me from beginning, then you should be able to know how to do this. Listen this, okay. This is going to be negative 10, okay. By 2, 1 by 2 is going to be 25. By 5, 1 by 5 is going to be 5. Negative, negative, positive, so 1 over 5. Yeah, 1 over 5, positive 1 over 5. But you can do slowly and do substitution. Positive 1 over 5. So this is going to be 1 over 5, positive, and this is going to be x sin 5x. Done. Plus constant because there's no limit. So all of that, you differentiate to get this. This answer. Okay, now we go to question number 102. Okay, cool. Now we go. That question right there. So that question could be the same. Okay, now we go. U equal to this because this is going to be by parts. U and this is going to be dv. I can do straight away now. Look. Let me do it ahead. Okay. Means, okay, what is a u? This is going to be u. Okay, let's differentiate. It's going to give us, okay, du equal to 7. 1 plus, this time, 1 plus 1, 49x squared. Dx, okay. V equal to x. When you integrate this and that one, it's going to be equal to x, okay. Now uv. Okay, so we know uv, uv minus uv du, okay. Okay. This uv, these are u, times v, x. X times time, inverse of 7x minus integral v. What is the v? X. Correct? Yeah. Times du, 7 will go to the back and then we say 1 plus 49x squared dx. Okay, so this minus 7, I'll do straight away. This is going to give us what? 9080. Okay, 9080, yep. 9080, and the ln of the denominator. 1 plus 49x squared plus constant. This is x times inverse of 7x minus. Okay. Okay, do you have anything common? Yeah, 1 and 14. Okay, 1 over 14. 1 over 14 here, so what's going to be 1 over 14? Okay, finish. Now let's go to the question number 90 or 102, and then I repeat. So this is supposed to be 122. So this is supposed to be 106. When I finish this question, I'll be done with the 106 question, not 5, because 102 are repeating. Okay, cool. Okay, question 93. Question 93 is easy goal, man. If you integrate e of a function dx, you say 1 over derivative function, and then write exactly what you have, plus constant. So now, derivative function, 2x, right at the bottom, 1, and then write exactly what it gets to us, x squared. So 1 times anything, that's something, plus, so it's like 1 over, so 1 times anything, it does something, over 2x plus constant. We're done. Now we go to question number 92. 92. Okay, 92 is easy. So 92 we say, first and foremost, look, this x3 and this x2 means the numerator is so big. So this is a partial fraction, but first I have to divide this, divide by the 1 in the denominator. So I'm going to say x cubed plus 4 divide by x squared plus 4. You see what I'm saying? Now we go. X cubed divided by x squared, you get x. X times x squared is going to give you what? X cubed. X times 4 is going to be 4x. See what I'm saying? So now, first and foremost, the best way is to put this in order. We don't have x3, we don't have x. Okay, I'll say it's plus 4, I'll say plus 0x squared plus 0x plus 4. I like to write like this in good order. So say x times x cubed, x times x squared, x cubed. X times, there's no x squared, so it's going to be 0x squared. Now this is 0x, so this and this is going to come here, 0, it's going to be 4x. The one with the x, because 1 times x is 4x, and then plus 0, because there's no number known. So we subtract is going to be 0, and this is going to be 0 also, negative 4x, and this is going to be plus 4. 4 minus 0 is 4. Now, so if we take this numerator divided by denominator, you get the answer equal to x, but are you going to be reminded with this, which is what? Negative 4x plus 4 over the total, which is x squared plus 4. So instead of saying this stuff, I can say this instead. You know what I'm saying? So I can say all of this, let me say integral of the face on dx, and then plus minus, I can just say minus integral of the second one, which is for x plus 4 over, excuse me, so, let me do this. Plus negative 4 plus 4, this is a good way. And this will be plus x plus 4, I'll tell you why. Now you go, when you integrate this, will give you x over 2, now plus, let's separate this with both. It's going to be negative 4 integral of x squared plus 4 dx. So I'm going to write this because I don't need it now. Okay, and then we're going to plus, now come for the 4 with everything. So integral 4, I'll take 4 out, and this is going to be left to the dx over x squared plus 4. You see what I'm saying? So now we go. So this is long, so say x squared over 2 plus and minus. Okay, this is going to be, okay, we got negative 4. This is going to give us 2 over the ln of the denominator. Now you can do slowly if you want. Okay, now this is a tan substitution. We got 4, okay, because this is going to be 2 squared. 4, and then differentiate this is going to be, okay, 4 over, because with the tan, let me show you something. If somebody integral of dx, and they give you, let's say f of x plus a squared. So for tan, you say 1 over a, only for tan, and then f prime, and then you say arc tan inverse. Arc, remember right here? Arc tan. Take your function here, right on top, and then over this a. So here we're going to do the same thing. See? For example, but I got a lot of questions. I think I explained it before, so I don't want to waste a lot of time on this. Let me just keep going. So I'll say 4, just a 4. So now this can be 1 over, when you derivate x, you get to 1, and you must write this a, which is 2 for this case. So 1 times 2, 1 times 2 equal to 2. Okay, then arc tan, we can say tan inverse arc tan. Take your function, which is here, over a plus c. Now you can multiply this, and this is going to give us 2. 4 divided by 2 equal to 2. So that's what we got. So now x squared over 2 minus 2 4 equal to 2 ln absolute x squared plus 4 plus this will be 2 arc tan x divided by 2 plus c. Now we're done. Let's go to the next question. So next question is question number, which question now? Where am I? 92, 91. Okay, cool. Okay, 91. Let's go 91. So 91, let me see if it record. Does it record? Oh yeah, it does record. Okay, 91. This one right here. Okay. Integral of tan cube x dx. Okay, so first and foremost I'll say integral. Okay. Tan cube. So tan cube, I can say this equal to tan cube. Okay, so I'll say this equal to, okay, just a second. Okay, let me see. Okay, I'm just thinking there's a lot of ways I can do this question. For a sec here. Let me say tan square x, and then you put here tan 1 dx, because it's the same thing. Now, if I say 1 minus sec and then take tan, tan is going to give me sec square. Now it's going to give me sec square. Nope. Just a second, just a second. Okay. Okay, but we know this, right? We know, okay, sine square x plus cos square x equal to 1. If I want to get tan cos and tan and sec, I'll say, okay, divided by sine, divided by cos, divided by, if I divide by cos square throughout, 1 divided, okay, divided by cos throughout, divided by cos is going to give us tan, divided by cos square is going to give us 1, divided by cos square is going to give us sec square throughout, like divided by cos square, divided by cos square x divided by cos square. So this is a relationship between tan and sec square. So now if I have to remove this, tan square is going to be sec square minus 1. If I have to remove this, it's going to be sec square minus 1. So it's going to be integral sec x square tan square equal to sec square minus 1, and then here is going to be tan x dx. Now if I let sec equal to u, let me open it. I know. Okay, let's just open it. It's going to be integral of sec x tan x dx, and this is going to be only tan, integral of tan. Okay, integral of tan. So let me. Okay, okay, no problem. And then multiply is going to be integral of tan x dx. Now let me take one sec here. It's going to be integral. It's going to be sec x and then sec tan, sec x tan x dx, minus, when you integrate tan, I'm gonna get ln of sec square. So it's gonna be ln, differentiate x on the right, but when you differentiate x you get 1, so it's like sec square, ln of absolute sec square. No, just a ln of sec, not sec square, ln of sec. When you integrate tan, you just get ln of sec. Okay, now here I'm gonna let u equal to sec. So du equal to sec x tan x dx, which is going to be du, and this is u. So I'm going to say integral of u, because this is sec equal to u, and this is going to be du, and then minus ln of sec x plus constant. So this is going to be u square. So if it's going to be u square over 2. It's like u square over 2. But we know the value of u. Whatever is sec x. So I can say sec square x over 2. Sec square x over 2, and then we plus constant. So I'm done. Now let's go to the question number. Good question. I like this. I love this question, not a lot. Okay, now we go to question number. Okay, this is done. This is done. 91 is done. 90. So we go for those one. Okay. Let's make some space here. Okay, cool. Let's go. Now we go to question number, this one is done, question number 90. Okay, question number 90 is easy. So I'm going to do, let me break this one down. So I'm going to say integral. Okay, this x minus 1, and this is going to be x plus 1. Okay, and then x plus 2, I think so. Isn't this? Yeah, dx. So I have to do partial fraction this one. This is a partial fraction. Let's go partial fraction. So I'm going to say, let me take this and I'll say, okay, x minus 1, and then x plus 1, and then we got x plus 2. So I can say this is equal to A over the first group plus B over the second group. Okay, so let me take this multiply throughout. Take this multiply on the left, and for each individual. So this is going to cancel because I'm going to multiply the same thing here. So this and this is going to cancel. Take this multiply here. The same thing. X plus 1, x plus 2. Look, this and this is going to cancel. So here I'm going to be left with x minus 1, but here is going to be, because this and this cancel, is going to be A x plus 2, and then plus, same thing, take this stuff, multiply here. This and this is going to cancel, so it's going to be b x plus 1. Okay, now, I can do straight away now. So for the x, if you have to compare the coefficients, it's going to be ax, bx. So it's going to be a plus b because they both have an x. With x equal to x, because this has an x and this has an x. So a plus b with the x equal to x. This and this cancels, so a plus b equal to 1. Now for this, the one which doesn't have any x is 2a plus b. 2a plus b equal to the one with have no x, which is negative 1. Now, so we can solve simultaneous. So a plus b solve with 2a plus b, which equal to negative 1. So now what I'm going to do, I can just minus, because you want to get this eliminated. So it's going to be negative a equal to 2a equal to negative a half. A equal to negative a half. So if a equal to negative a half, I can substitute the end of the 2 question. I can put in a there. Okay. If a equal to negative a half, I can put it in this one plus b equal to 1. So even b equal to, this one goes, going to be 3 over 2. b equal to 3 over 2, a equal to negative a half. So I can commonly substitute here now, replace. So now, this stuff here, which equal to this, so same as the value of a, we know what the value of a, negative a half. So instead of say a, I'll say what? Negative a half, and then write x plus 1. And then plus b. What is b? b equal to 3 over 2. So it's going to be 3 over 2. Oh my god, let me write it again. So we said this, which is this, equal to that. By partial fraction, a we know negative a half, and then x plus 1, and then b we know b equal to 3 over 2, and then we go x plus 1, x plus 2, excuse me, x plus 2. Okay, so I can just erase this because we did already partial fraction, so we don't need a lot of deadness here. Okay, cool. So instead of writing this, I'll replace with integral, for say negative a half, right? So negative a half, I can say this equal to negative a half. I'll take negative a half out, and this is going to be a 1 over x plus 1 dx. Now, for the second one, 3 over 2. So I'll say 3 over 2 goes out, and the integral of x plus 2. So dx x plus 2. So now we can say negative a half, this is going to be ln of x plus 1, and then plus 3 over 2 ln of x plus 2 plus constant. So we done with that question. Now we go to question number this one. There's no limit, that's why plus the constant. Okay, cool. Now let's go there. So, how am I supposed to do thinking? Okay. Question 89. Let me see, did I copy this question right? Because there was a question which was, I say, this is second. Man, see, just a second. Yeah, exactly. Okay, so what I'm going to do, I'm going to do different to 2 square. Integral of 0, 3, so this is going to be 1 over x plus 1, x minus 1, dx. So partial fraction again. So this one, this can be, okay, say 1x plus 1, x minus 1, which is this. It's like say, the same as say a over the first one plus b over the first one, over the second one. Okay, now if you take this multiply on the left and right, so this is going to be left with only 1, and then multiply all of this here means this and this because we multiply here. Okay, so this and this is going to cancel. It's going to be a x minus 1, and then plus b is going to be x. Oh, this minus 1, minus 1. X minus 1. I don't know. Okay, now. Okay, now we go ax, bx, nothing. So say a plus b equal to 0 by comparing the coefficient. Now, this can be negative a, and this can be negative b. Negative a, and then negative b equal to 1. Now we go. So we can do simultaneous. Negative a, negative b equal to 1, and then we can just add them. 0, 0, 0. How? Did I make mistakes somewhere? Oh, plus. This is a plus here. it cannot be the same. One must be plus, okay. Multiply here negative, plus plus, okay. Now multiply all these negative, negative. So this must be plus, yes. This must be plus, so bx, okay, let's go. ax, bx, plus positive, now we go. Negative a, plus b, okay, so this must be plus b. Okay, if you add this, so it's going to be 2b equal to 1b equal to 1 over 2. Now, b equal to a half, I can substitute here. So even a is going to be equal to a half. Even a equal to a half. Yeah, a equal to half. So what I'm going to do, a half and b equal to half. So for that case, I know a number b, so I can substitute. But this must be part of your written solution if you write the exam. Okay, it must be part of your written solution. So I know my a half and b equal to a half. Everything is a half. Yeah, I believe so. Okay, so now it's going to be, I'm going to say, instead of writing that, I'll write integral of 2, 3, so a half, so I can say a half 1x plus 1 dx. So plus, for the second one, so it's going to be a half integral 2, 3, and then it's going to be 1x minus 1 dx. So this is going to be 1 over 2 ln of x plus 1 plus also 1 over 2 ln x minus 1 plus your constant. So we're done with the question. Now we go to question number 89. Now we go up. 89. And then, okay, cool. Let's go. No problem. Okay, now we go to question number, okay, up, down, let's go. So number 6, okay, let's go. Question number 102, integral tan 4x cubed dx. When you integrate tan, we get sec squared. But first you must differentiate your function. So this is going to be 1 over derivative of function, which is going to give us 12x squared, and then it's going to give us sec squared of our function. Exactly, it gives us plus constant because there's no limit. Now 101, we go up, integral of cot. So if you integrate cot, you get ln of sine. Okay, we integrate cot of a function. For the function, for this case, 3x squared dx. This let me say 1 over, you must derivate your function, it's going to give us 6x, and then when you derivate the cot alone, it's going to give us a negative ln of a sine. So negative ln of absolute sine of a function given plus constant because there's no limit. Now let's go for 100. Okay, now integral of sec square 5x dx. So when you integrate 5, it's going to give us that tan. So this is going to give us derivative function to give 1 over 5 because 5x in derivative you get 5, and then it's going to give us tan of a function exactly the way how they give it to us. Now we go to question number 99. Okay, 99. Okay, sec whatever you got. Okay, so that one is easy. Okay, 99 we say sec tan. Okay, if somebody give integral of sec of a function, tan of a function dx, this same is say sec, but you must say derivative of a function and then sec of a function plus constant if there's no limit. So for this case I'm going to do the same thing. So 1 over derivative function. Our function is x power 4. No, I copied wrong my part. This is sec power 4x, tan power 4x. I'm wrong. You cannot do like this. Okay, cool. Let me see the time. Let me see if it record. Oh, yes, of course it record. Okay, cool. Let's go. Okay. Which one? Okay, question number 99. Okay, question number 99. They give an integral sec 4x tan power 6x dx. Okay, so what I'm gonna do? Okay. How if I say Okay, the same business like it was before. Okay, now I'm gonna say, okay, see. Okay, I'm gonna say sec power 4x, and this is gonna be okay. So I'm gonna say tan square x minus okay. Tan power 4. Let me say tan power 4. So it's like this, and I'll be left with 2 tan here. No, let me leave tan. Okay, cool, no problem. If I take 1 tan and 1 sec. Okay, just a second. Just a second. 2 minutes, I'm done with this, okay? Yeah, I think I got it. Okay. So now, okay. So these are 4 tan and 2 tan. Yeah. Ah, my goodness. Okay. And let's put 2 tan here, tan square x dx integral. Okay. Now I'm gonna say. Okay. Just a second. Okay, just a second, guys. Just 1 minute, okay. If I say, for example, 1 tan is not make sense because let's see. Okay, if we differentiate tan, you get sec square x. Okay, sec can come there, and this we can change in terms of sec. I know it's not gonna make tan. Okay, change. Okay, I change, for example, this tan. Maybe this is gonna be tan. And this tan, but now you don't want to have a sec. Okay, if I take sec, for example, okay, let me take for example sec. If I take sec equal to sec tan, we probably want to have tan here. Okay, I'll come back. Okay, question 100. Okay, dp equal to p. When you need to equal to p, now you go question number 97. This one 98, 97. I'll come for that one, right? I'll come back for that one. This one, when you integrate tan, you get ln. When you integrate tan, x dx equal to ln sec square. It's just sec plus constant. Now we go for question number 96, okay? I'll come back for that one, no problem, I'll come back for that one. Go to question number 96. Number 96, I'll go 99. 96, they give us integral of sec 9x and then tan x dx. Okay, so what I'm going to do, I'm going to steal 1 sec from here. It's going to be integral. Sec, they're going to be 8x, and then 1 sec is going to come in. It's going to become sec x and then tan x dx. You see what I'm saying? And then I'm going to make this a 1 minus. Oh, no, okay. Let me just make sure. Okay, the relationship between sec, okay. Sine x squared is going to be tan square x plus 1 equal to sec square x. So if I have to replace sec, because this I can say 2 power 4. 2 and then I can say power 4. So I want to replace sec equal to tan square. It's going to be 1 plus tan x square. Tan sec square. Yeah, something like this. And this is going to be what? Power 4 because it's 8. Power 4. And this is going to be sec x tan x dx. So I'm saying? Now we go. So I can let u equal to tan. Okay, sec. So for that case, I was not supposed to change this. I was supposed to leave it as a sec. Sec power 8 for a reason. I'll tell you why. So I'm supposed to leave it as a sec power 8x. Okay, now we go. Let u equal to sec. When you differentiate, it's going to give us sec tan. Sec x tan x dx. So I can replace this with the du, and this one we know. Integral u power 8, and this is sec x tan x equal to du. It's going to be u power 9 over 9 plus constant. But u we know equal to sec x. Sec plus 1, it's going to be 9x over 9 plus constant. So this one is done. So the problem is here, right? We come back. Let's go to question number 15. I'll come back. I don't want to waste a lot of time. I don't want you guys to sit there and they're just watching me like, oh, he's not moving. No. We don't have time for it. I'll come back. Don't worry. I'll come back. I'll get that one right. Okay, cool. Question number 19. Okay, 95. So this is like a factor theorem of integral of the trig. So me personally, since I see cos, I'm gonna go to compound formula of trig, which say cos of a plus b equal to cos a cos b, because I see cos a cos b, and then if it's plus, it's gonna be minus sine a sine b. Okay, same here. It's gonna be cos, but this is gonna be minus for this case. It's gonna be cos a cos b minus gonna be plus sine a sine b. So now plus and minus. Since I want to get cos, which is cos and cos, so I must plus for this case, not minus. So this is going to vanish, and there's going to be 2 cos because we add them. 2 cos A cos B equal to the first one. So if I have to move, this one is going to be cos A plus B plus, right? Yeah, we plus now. So it's going to be cos of A minus B divided by 2 is going to be 1 over 2. Okay, this one move it. Okay, we know A. What is that A? A 15x. So if you say cos 15x x cos 15x cos 4x equal to 1 over 2, and then cos 15 plus 4 equal to 19x plus cos 15 minus 4 equal to 11x. Okay, so what we want to do, instead of say that, I'll replace, so say question number 15 is going to be integral. So I'll take a half back. There's an integral, so I can just put bigger bracket, cos of 19 dx, and then plus cos of cos of what of 11x dx. So this also must be integral dx. So this, let me say, okay, when you integrate, this is going to give you okay, I'm saying this is 2, right? So it's going to be 1 over 2. When you integrate, it's going to be 19 here. 2 times 19 equal to 38. But when you integrate cos, you get sine. It's going to be sine of 19x. For the second one also, it's going to be the same. Plus, okay, now a half times 11, 1 over 22, and this is going to be sine 9x plus constant. So finally, when you integrate that, you're going to get sine of 19x over 38 plus sine 9x over 22. So we're done with that. So now we go to question number 94. I'll go to that question, right? Don't worry about it. This one we're done. The problem is here. Okay, number 9. Oh, we're done. This one we're done. Even this one we're done. Okay, cool. I'll come back there. Don't worry. I'll go back there. No problem. Can't stick to the one question, you know. Time. Come back. Okay, cool. Now, the number 91. I think I did number 91. Of course, yes, I think I did. But I can just do it just in case if you maybe, okay, inner growth, tan cube is like a tan, square x, and then it's going to be tan x. No, I did this question. Definitely, I'm sure. I did this question, I did. But if you want me to do, I can do, but I did it. What do you think? Should I do it again? No, I did this question, so I don't have to do it. Okay. You can check there. I did question number 90. Question number 94 now. So question number 94, we will say, put in first fractions, go 1 over y, and the plus is going to be b over y plus 2, plus c over y minus 3. So these are multiplied by denominator throughout. So this can become a y plus 2 and the y minus 3 plus b y and then y minus 3 plus c y plus 2. So I'm thinking which number. So yeah, so I can just say yeah. So 1, because you must multiply left and right. So when you multiply here, it's going to be only 1 left. Okay, only 1 left. 1. Because you might multiply here. Now you think which number I want to put here is going to eliminate something. If I say y, for example, y equal to 3. If I say y equal to 3, look, because let's say y equal to 3 here. What happened? This is going to be 0. 0 times 0, 0. 0, so I'm left with that one. So it's going to be 1 equal to c 3 times 5 equal to 25. 3 times 5 equal to 15. So my c equal to 1 over 15. So I can say here c equal to 1 over 15. Now we go for the next one. If I assume y equal to negative 2. If I say y equal to negative 2, this is 1. Y equal to negative 2. So what happened? If y equal to negative 2, this is going to be 0 because it's going to be 0 times anything 0, 0. So it's going to be negative 2. This is going to be negative 5. Negative 2 times negative 5, 10. So it's going to be 1 equal to 10b. Our b equal to 1 over 10. So b equal to 1 over 10. Now we want to get a. How are we going to get a? I can put it in. Because I know my b, I know my everything. I know my a, I know my b. I know a, I know my b. Now I want to get a now. Okay, how am I going to get a? A. Okay. I'm gonna have to expand it. I don't see other easy way to do it. Okay, cool. Let's go. Y equal to, now this will be a. Okay, this will be y square. Y square. Negative 3y to y. Negative y. Okay, this will be negative 6. Okay. Plus. It's gonna be b y square minus 3y. Plus c y square plus 2y. Okay, now we want to get a, so I can say, there's a lot of ways I can get a. I can use the last one. So 1 equal to negative 6a. Okay, let me use there's nothing here. There's nothing there. Okay, so a, then we got a then. Because a, this one doesn't have a, this one doesn't have a. Okay, or a equal to negative 1 over 6. Okay, a equal to negative 1 over 6. So I know my a. So I can substitute all this stuff and solve. And the question is done already. And then we go to that trouble question, the one that I didn't get. Okay, a we know. So I'm going to say integral of, here it was a, remember. So it's going to be what? What is a? Negative, so it's going to be negative 1 over 6, 1 over y, dy. Now we go for the second one, plus b. What is b? 1 over 10. So 1 over 10 integral of 1y plus 2 dy. Now we go for the last one, plus c, 1 over 15. So it's going to be 1 over 15 integral 1 over y minus 3 dy. So now we finish already because it's going to be negative 1 over 6 ln of y absolute plus 1 over 10. It's going to be the same game here, ln of y plus 2 plus 1 over 15 ln of absolute 1 minus 3 plus constant. So now let's go to the problem. Let's go to the problem. Let's go to the problem, brother and sister. Okay, let's go to the problem. So now this problem here, we say, if I say, if I like sec tan f, I leave tan equals sec. Okay, but why I don't, okay, let me think, okay. Why I don't, for example, can I say, okay, you know what I'm thinking, okay, let me do this. Okay. Let me leave tan power 6. I think I can do this. I just stress myself for nothing, okay. Okay, let me leave tan power 6 this. And then let me take sec square, because if I take tan, it's going to give me sec square. So I'm going to say integral, and they'll say, so I'm going to say integral. And then this is going to be, okay, let me put here sec square x dx, and then square, okay, sec square dx, and then it's going to be sec square x, because this is going to give us 4, same thing, and this is going to be tan 6x. And this one I know, and I'm going to let tan, let's change this to tan. If we change to tan, it's going to be tan square x plus 1, and then tan power 6x sec square x dx. And then if I let it go to tan, and then it's solvable. Ooh, gone. So now I'm going to say let u equal to sec, u equal to tan x. Okay, du equal to sec square x dx. So this is going to be integral u plus 1 u power 6, and this is going to be du. Okay, it's done already. So this is going to be u power 8 plus 1 u power 9 over 9 plus u power 6 plus 1 is going to be u power 7 over 7. Integrate straight away. So u we know, u equal to tan x power 9 over 9 plus tan x power 7. Okay, we're done with that question, so we're done with all this part. Question 106 are done. So now go to 107. Let me write more question. Let's go to 150. Okay, go 150. Can be good. $107, now we go. Okay. Take the paper. Okay, cool. Now let's go. Let's go to the next one. Okay, this one here, I think I'm done with this part. This one is done. Okay, cool. Let's put it aside. This one is done. This one is done. Okay, done. This one is done. Man, a lot of questions are done here. Okay, cool. Let's go. Here we go. 107. In a row of long 2x dx 118 integral cosec square 5x dx 109 integral of tan x dx 110 integral of x cubed log of 2x log of 3x 111 Okay, 11 integral cot 112 interval 7 2x dx 115 integral okay, let me check some more questions. Okay, we go check some more questions again. I need more question, man. I'm not see the question here. The question are finished, baby. Woo. Okay. Okay, tan 5 theta sec 7 theta d theta 14 integral just a second. Cos square 2 theta d theta 115 sine theta cos theta d theta 16. Okay, let me just go with those questions because I'm not seeing more questions here, guys. Seems like the question are running away from me. Okay, cool. No, I gotta add some 5 questions here. Just a second, I need to add 5 questions. Those are fair few questions. I need more questions. Where are the questions? Send me questions, guys. I'm not seeing the question. I'm kind of checking the question right now. I don't see the question. Most of them I solved them already. All of them, not most. Okay, I need to get 5 questions more here. Okay, I see. Integral of cosec dx. Okay, 117. Until it's at 120, I'll be happy. T integral of t sine 3t dt 1180 integral of arc. Okay, arc what? Because all the arc I did, tan I did, quarter did, cinch I did. Okay, let's say arc cos of 6x dx. Okay, 119 integral x theta e theta d theta 120. Last one. That's the last question. I need a monster question right now for the last one. I don't see no more question. All the questions are done. U, integral for U. Man, it's gonna be easy, man, if I do this. Integrate Africa, D Africa. Okay, this is gonna be the last one. Okay, cool. Let's go. So now, let me start with the first question. Let me start from the beginning now. Okay. Okay. So integral of ln of 2 x dx. So this is gonna be by parts. U equal to ln. Let me check if it record. Does it record? Oh yes, it does record. Let me see. Yeah, it does. Okay. U equal to ln of 2 and then dv equal dx. This is u and this is dx. Okay. du equal to is 2x. Differentiate 2x you get 2 and then over 2x dx. This is going to be 1 over x. Okay. Now v equal to x. Now put in the formula equal to uv x ln of 2 minus integral v x du 1 over x dx. This and this cancel, so integral dx equal to x. So this can be x here plus c. We're done with this question. Now we go to the next question. let me get this out of the way. So it's going to be 120. Now let me go with the flow. Question 102. Question 108. Integral of the cosec square. When you integrate cosec, you get negative cot, but you must go first as a 1 over derivative function. And when you derivate 5x, you get 5, and then negative cot of a function. Now 103. 109, integral of tan x dx. When you integrate tan, you get integrate tan sec, so ln of sec of a function. You gotta put an absolute anytime you when you have a ln, you must put absolute x plus constant. You know, 1 over, when you derivate your derivative equal to 1, so 1 divided by 1 equal to 1. That's why I did not write it. Now question 101, 110. 110, that's by part. This one here. This is going to be u, and this is going to be dv. Nope. Okay. This is u because it's ln, and this is going to be dv. Okay. So now, let u. So that's our integral we have, which is 10. Let u equal to ln of 3x. So differentiate is going to be du, and this is going to be 3 over 3x is going to be 1 over x dx. Okay, v equal to, and then integrate this is going to be x power 4 over 4. X over 4. Okay, let's substitute now uv. So this equal to uv. X power 4 over 4 times our v. This v times u. Ln 3x minus integral v. That one. X power 4 over 4 is put my 4. Then multiplied by du 1 over x. So by x, 1 over x. This and this going to cancel, going to be power 3. X power 4 divided by x equal to x power 3 dx. Okay, now integrate, add by 1 over 1. So it's going to be x power 4 over 4. And this 4 times 4 equals 16. So x power 4 over 16. X power 4 over 16 plus c because you don't have no limit to it down. Now we'll go to the question number 111. On 111, we say, we don't have no more question here. Come on, how can that be possible? Yeah, no more question. Come on, man. This is crazy. Okay, cool. Now, so we go 111. Okay, this one here. So integral of cot. When you integrate cot, you get cosec cot, negative cosec cot. So I'm going to say 1 over derivative function, which is going to give us 4x plus 0. But it's going to be negative cosec cot. Cosec of a given function, which is 2x squared plus 6. And then we must say cot again of the same given function, 2x squared plus 6 plus constant because there's no limit. So you can say negative of there. Or you can say like that. Okay, you can write like that. 112. If you give an integrate a of a function, this may say find the derivative of a function. Write exactly the function that we have to give to me. This is a function here, a f of x, and then over ln of only a is whatever, and then plus constant. So now we say for this case here, we are saying this equal to, okay, so we're going to say 1 derivative 2x is going to give us 2. And then write exactly what they have given to you. 7, 2x. So say 7 here, 2x. And then over ln of 7. And then we plus your constant. We're done. Now let's go for this one. Okay, 113. Integral tan 5 theta and then sec 7 theta d theta. Okay, now when it's prime like this is easy. So okay, so I'm gonna say let me say tan and sec here. So it's gonna be sec tan, sec theta, tan theta. Means I'll take 1 tan and 1 sec. So here I'm gonna be left with 4 tan square, or square. It's like 4 tan, and this gonna be sec 6 of them. So now, what did that one at differentiate give me sec tan? Is sec. Now if I differentiate tan, I get sec square. If I differentiate sec, okay. So I'll let u equal to sec. So now this must be tan to sec. So tan, this square is going to be equal to sec square minus 1. So I'm going to replace tan square, it's going to be sec square minus 1. So this is going to be sec square minus 1. Instead of say tan square, it's going to be sec square minus 1. It's going to be integral sec square theta minus 1. Okay, so now we're going to do u equal to sec square, so du equal to sec tan. Sec theta, tan, theta, d theta. So this is going to be du, and this is going to be integral sec equal to u square minus 1 square. It's going to be u power 6, and this du. Okay, so now this is same as saying integral u power 4 minus 2u square plus 1 u power 6 du. So this is going to be u power 10. U power 10, but our integral is going to be u power 11 over 11 plus this, and this is going to be negative 2 u power 8 plus 1 power 9 over 9, and this is going to be just u power 6 plus 1 is going to be u power 7 over 7 plus constant, okay, and plus at the end. Our u we know, sec 11 theta over 11 plus minus 2 sec 9 theta over 9 plus sec 7 theta over 7. We're done with that question. So now we go to the question number, this one we're done with. Yeah, so we come here. Okay, or we come for this one here. Okay, so that one I'm going to go to double angle. So I got integral there. So if you go to double angle, that's going to be cos double angle, cos of 4 of angle, and then no plus 1 over 2 d theta. You want me to tell you why? It means I have to replace this is going to be there. Double angle of sine. So I go plus 1. Yes, you can just go double angle of trig, you get that one. Or you can just, if you want me to show you, I can show you. It's like saying cos double of my angle equal to 2 cos square of my angle minus 1. But this is what I'm looking for. You see this one? Cos square means I'm looking for this. But now it's not cos square, it's cos double angle. So here must be double. If this double, this must be 4. Because 2 times double is going to be 4 now. If this 2 theta, this is going to be 4 theta. So I want to look at this one. This is going to go over. It's going to be cos 4 theta plus 1 and then divided by this 2. That's what I got that one. Okay, 2 is going to go to the back. So I can say over 1 over 2. I can separate now. So this is going to be 1 over 2. Okay. This is going to be, when you integrate this, is going to give you 4. Because we differentiate this one, it's going to be 4. And then it's going to be sine 4 theta. And the plus, this half is still there. And then theta plus constant. So this is going to be 1 over 80. You can just put 1 over 80 and then we finish. Okay. That one right there. So that's a factor theorem of a trig. Factor theorem of trig. Okay, so it's sine and cos. Sine and cos means I'm going to go to double angle of compound a plus b, because a, and then this is equal to sine of a, cos of b, sine of a, cos of b. If it's plus for sine, it's going to be same thing. So we switch this. It's going to be cos of a, sine of b. We do the same thing, but I change the sign. Sine of a minus b equal to sine of a, cos of b, minus, also minus, cos of a, sine of b. Okay, so since you want to get to what we want to get, sine cos. Sine cos means these are 1 and 2 disappear, plus and minus. What I'm going to do, just plus. So this they can go. So this is going to give us sine cos. When you add them, it's going to give you times 2 sine, top and bottom, 2 sine cos b equal to, add this together, it's going to be sine a plus b plus sine a plus b. Divided by 2, divided by 2. So this is going to be 1 over 2. Okay, cool. So for this case now, it's not A. Which angle we have now? The angle is 3 and theta. So it's like 3 and theta. It's like say sine of 3 theta. It's like say it's not A now, so it is 3 theta and B just theta. Okay, now it's going to be 3 theta plus theta equal to 4 theta. 4 theta, and this is going to give us 3 theta minus theta equal to 2 theta. So I'm going to have to replace this with that one right here. So I'm going to say integral. Instead of writing that, I'll write my half. So I can say half sine of 4 theta d theta, because I'll take a half back. And then I'm going to say plus. Now integral for the second one. Remember, half is for both. Yeah, half is for both. My point. Half is for both. So it's going to be a half also for the second one. Okay? So for the second one, it's going to be sine of 2 theta d theta. Instead of this, we'll place it there. So half. Okay, now we go. It's going to be 1 over 2 times 4 equal to 8, because we must differentiate. 4 theta get 4. 4 times 2 equal to 80. And then this is going to give us negative cos 4 theta. Now we come here. It's going to be yeah. Definitely, yeah. Now we go, we say, yeah, I believe we did the right thing, you see. Okay, cool. Now we say, now we come here with plus. 1 over 2. We differentiate, get to 2 times equal to 1 over 4. 1 over 4, differentiate, integrate, sine, you get negative cos. So it's going to become negative cos of 2 theta plus c. So when you integrate that, you get this. Now, 116, question 116. Let's go to point. No, this is easy. Cosec square. When you differentiate cosec square, okay, we differentiate cosec square, what we get? Cosec square. You know, when you start to think like small things that you forgot, you know? Okay, cosec square. It's just something more, I can't forget it. Cosec square. Negative cot. So when you differentiate cosec of a function, integral, you integrate cosec of a function, what you get? You derivate your function, and they get negative cot function plus constant. So here, I'm going to say now equal to 1 derivative of function. When you derivate x, you get to 1, so it's like over 1. But then when you integrate, okay, you derivate your function 1, you get 1. But when you integrate cosec, you get negative cot. So it's going to be negative cot of a function. But for this case, just say x. So plus c. Yeah. So negative, just say negative. So it's negative. We're done. Now let's go to question number 117. So we're done in this part here. Okay, cool. Now we go. So we go for that one is easy. So 117 we say this is by parts. So I'll let u equal to t, and then dv equal to sine 3t dt. Differentiate du equal to t, and then this is v equal to when you integrate this, it's going to be 1 over 3 negative cos 3t. Now we go uv is going to be t cos 3t over 3 integral. Okay, v is that one, so it's going to be, take that one, it's going to be 1 over 3, so you're left with cos 3t times this is going to be dt. Now it's finished already. So negative t cos 3t over 3 plus 1. Okay, this you differentiate this one, it's going to be 1 over 9 because you must multiply with it, and then this is going to be sine, so we'll remove this one, sine of 3 t plus constant. We're done. Now let's go to question 118. Man. This is non-stop. No break, non-stop. Okay, cool. Now we go question number 118. So question 118. Okay, so our cos. Okay, so integral cos inverse of 6x dx. So this also by parts. Let's u. So this gonna be u, and this gonna be dv equal to dx. Okay, u equal to cos inverse of 6x. So du equal to differentiate 6x to get 6, and then this is gonna be, you must put negative because it's cos inverse. So it's gonna become negative. So 1 minus, because the function is gonna be 36x squared. This is gonna be dx. Okay, dx dv. So v equal to x. Okay, uv it's going to be x times cos inverse of 6x minus integral of v equal to x, and then take this negative, is going to become positive, and then this 6 is going to go to the back, and they'll say integral 1 minus 36x squared dx. So now we can do this is easy. So now this is easy. I'm going to say this equal to x cos negative 6x plus, we got 6 here, and then we know this half here is going to give us 72 at the bottom, and then also I'm going to have 72 at the bottom. I'm trying to do straight away, and it must be negative. And then it's going to be multiplied by half, of course, and then this is going to be square root of 1 minus 36x squared. And then I can simplify this. This is 1, this is going to be 1. 36 by 6, 1 by 6 is going to be 6. So it's going to be 1 over 6 negative. So this together is going to give us 1 over 6 negative. You can do slow by substitution, right? And then 1 over 6 down plus c. So it's going to be our answer here. I can prove to you what I say here. Look, it's x integral, right? 1 minus 36 x squared integral dx. Look, so if I let, for example, u equal to 1 minus 36x squared, so du equal to negative 72 x dx. Okay, but x dx, we know this x dx is divided by negative 272, so it's going to be like 72. So I have to say du, but I say over negative 72 is like negative 72. That's why I wrote at first negative 72. Okay, so it's going to be 1 over square root of u, and then take to the top, so it's going to be 1 over negative 72. It's going to be u negative a half integral du. So this is going to be negative 1 over 72 plus 1 is going to be square root of u, but this a half must come here. Yes, of course what I said. So it's going to be 36 negative 1 over 36 square root of u, but we know u is like 1 minus 36x squared. So this must multiply by what? By the 6 which I had here. So this could be 1 over 6 negative. Same thing, you got it. Okay, cool. So we got it. Now we go to question number 119. Is also by part. Okay, cool. So now we say the u equal to theta. This is a good one. Okay, and then dv equal to e theta. Okay, du equal to d theta. And then v equal to e theta. Also, when you integrate this, it's going to give you the same thing. Okay, uv, this and that going to be theta e theta minus integral v e theta du equal to d theta. $120, we finish. Equal to Africa square over 2 plus constant, because we're always constant with the base. This is how mathematics confuse a lot of people and a lot of students, to the point whereby the student get confused. Huh? This is Africa, alright? Are doing gorilla way. You know, we've been going through a lot of things. So when you go for war or when you go for something, we go it hard. Thanks a lot for your time, man. Leave all these dogs. Thanks for your time. I appreciate it. Okay, share this video to many people. You know, I just do it for my heart. I want to do more questions, but the problem, I don't have no question. I wanted to do 500 questions in one intake or 1,000 questions because I'm a fearless. You know, I never get tired. This is a machine. This is Africa machine. You can give me more. You see this stuff here? All this stuff, let me show you. Done, both page. Done, both page. Done, both page. All this stuff has been done, all this question, because it was like I'm solving question inside the question, and equation inside the question. So please do let me know what would you want me to do for you, because I'm doing this for you and for me to leave a legacy. Okay? So we say, why? Because I'm here to do it for you, to do for me, and to do for the African continent, and do for the world. Okay? Thanks a lot for your time. I truly appreciate it. This is how we do in Africa. Easy. Peace. Easy, man. Easy.